down to like 10 days, whatever. And then whatever I said, the other C's are for this one. Yada yada yada. I'm gonna get Siri and stuff. I think everything's working.
Is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion because the semicolon is needed for the header of a for statement. Automatic semicolon insertion never inserts one of the two semicolons in the header of a for statement. The source, return, a plus b, is transformed by automatic semicolon insertion into the following. Return, a plus b. The source, a equals b plus c, is transformed by automatic semicolon insertion into the following. A equals b plus c. The source, if a b else c equals d, is not a valid ECMAScript sentence and is not altered by automatic semicolon insertion before the else token. Either
This other computer I'm programming on, it's like on and off. I don't know. Some days it runs good, and some days it's laggy. It should just always be the same. It's probably whatever.
that begins the second line can be interpreted as an argument list for a function call. A equals b plus c, d plus e print. In the circumstance that an assignment statement must begin with a left parenthesis, it is a good idea for the programmer to provide an explicit semicolon at the end of the preceding statement rather than to rely on automatic semicolon insertion. 2, 1, 0. 3 interesting cases of automatic semicolon insertion. This section is non-normative. Note 1. The expression a plus b is not treated as a value to be returned by the return statement, because a line terminator separates it from the token return. Note 2. The token plus plus is not treated as a postfix operator applying to the variable b, because a line terminator occurs between b and plus plus. ECMA International 2024-241. ECMAScript programs can be written in a style with very few semicolons by relying on automatic semicolon insertion. As described above, semicolons are not inserted at every new line, and automatic semicolon insertion can depend on multiple tokens across line terminators. As new syntactic features are added to ECMAScript, additional grammar productions could be added that cause lines relying on automatic semicolon insertion preceding them to change grammar productions when parsed. For the purposes of this section, a case of automatic semicolon insertion is considered interesting if it is a place where a semicolon may or may not be inserted, depending on the source text which precedes it. The rest of this section describes a number of interesting cases of automatic semicolon insertion in this version of ECMAScript. 2, 1, 0. 3. 1 interesting cases of automatic semicolon insertion in statement lists. In a statement list, many statement list items end in semicolons, which may be omitted using automatic semicolon insertion. As a consequence of the rules above, at the end of a line ending in expression, a semicolon is required if the following line begins with any of the following: an opening parenthesis. Without a semicolon, the two lines together are treated as a call expression, an opening square e bracket. Without a semicolon, the two lines together are treated as property access, rather than an array literal or array assignment pattern, a template literal. Without a semicolon, the two lines together are interpreted as a tag template. The 13th of March 2011, with the previous expression as the member expression, an array plus or. Without a semicolon, the two lines together are interpreted as a usage of the corresponding.
I think there's like a...
Without a semicolon, the two lines together may be parsed instead as the multiplicative operator. For example, if the regexp has flags 2, 1, 0, 3,
like 9,000 something, whatever keywords.
which include no line terminator here.
Get the rest of this today.
In the grammar. Introducing a line terminator in these locations would,
At least this program's working.
without the optional operand. The rest of this section describes a number of productions using no line terminator here. In this version of ECMAScript 2.1.0.3.2, one list of grammar productions with optional operands and no line terminator here. Update expression, continue statement, break statement, return statement, yield expression, async function definitions, 15.8, with relation to function definitions, 15.2. 42. ECMA International 2024. 13. ECMAScript language. Expressions. 3.1. Identifiers syntax. Identifier reference. Yield. Await. Identifier. Yield. Yield. Await. Await. Binding identifier. Yield. Await. Identifier. Yield. Await. Label identifier. Yield. Await. Identifier. Yield. Yield. Await. Await. Identifier. Identifier name but not reserved word. 3. 1. 1. Static semantics. Early errors. Binding identifier. Identifier. It is a syntax error if the source text matched by this production is contained in strict mode code and the string value of identifier is either arguments or eval. Identifier reference. Yield. Binding identifier. Yield. Label identifier. Yield. It is a syntax error if the source text matched by this production is contained in strict mode code. Identifier reference. Await. Binding identifier. Await. Label identifier. Await. It is a syntax error if the goal symbol of the syntactic grammar is module. Binding identifier. Yield. Await. Yield. It is a syntax error if this production has a yield parameter. Binding identifier. Yield. Await. Await. ECMA International 2024 243. Yield and await are permitted as binding identifier in the grammar, and prohibited with static. Note, semantics below. To prohibit automatic semicolon insertion in cases such as let await 0, it is a syntax error if this production has an await parameter. Identifier reference. Yield. Await. Identifier. Binding identifier. Yield. Await. Identifier. Label identifier. Yield. Await. Identifier. It is a syntax error. Or if this production has a yield parameter and string value of identifier as yield. It is a syntax error if this production has an await parameter and string value of identifier as await. Identifier. Identifier name but not reserved word. It is a syntax error if this phrase is contained in strict mode code and the string value of identifier name is one of implements, interface, let, package, private, protected, public, static, or yield. It is a syntax error if the goal symbol of the syntactic grammar is module and the string value of identifier name is await. It is a syntax error if the string value of identifier name is the string value of any reserved word except for yield or await. 3. 1. 2. Static semantics. String value. The syntax-directed operation string value takes no arguments and returns a string. It is defined piecewise over the following productions. Identifier name, identifier start, identifier name, identifier part. Let id text unescape be identifier code points of identifier name, return code points to string. Id text unescaped. Identifier reference. Yield. Binding identifier. Yield. Label identifier. Yield. Return yield. Identifier reference. Await. Binding identifier. Await. Label identifier. Await. Return await. Identifier. Identifier name but not reserved word. Return the string value of identifier name. Private identifier. Identifier name. Return the string concatenation of 0 times 0023, number sign, and the string value of identifier name. Module export name. String literal 1.
So I'm gonna be defining the rest of these, whatever. I'm replacing them with a new define for the type. Psh, I'll be back.
Identifier. Return. Resolve by.
I need some Claritin. Freaking allergies. I'm dying. I hate trees. Trees suck.
Resolve binding. Await. Note 1. The result of evaluating an identifier reference is always a value of type reference. 3.2 Primary expression syntax. Primary expression. Yield. Await. This identifier reference yield await. Literal. Array literal yield await. Object literal yield await. Function expression. Class expression yield await. Generator expression. Async function expression. Async generator expression. Regular expression literal. Template literal yield await. Tagged. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Yield await. Capital C O V E R. Capital P A R E N T H E S I Z E D. Capital E X P R E S S I O N. Capital A N. Yield await. Expression plus in yield await. Expression plus in yield await. Dot. Binding identifier yield await. Dot. Binding pattern yield await. Expression plus in yield await. Binding identifier yield await. Expression plus in yield await. Binding pattern yield await. Note 2. In non-strict code, the keyword yield may be used as an identifier. Evaluating the identifier reference resolves the binding of yield as if it was an identifier. Early error restriction ensures that such an evaluation only can occur for non-strict code. ECMA International 2024 245. Supplemental syntax. When processing an instance of the production, primary expression, yield, await, capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, yield await. The interpretation of capital C, O, V, E, R, capital P, A, R, E, N, T, H, E, S, I, Z, E, D, capital E, X, P, R, E, S, S, I, O, N, capital A, N, is refined using the following grammar. Parenthesized expression, yield, await. Expression, plus in yield await. 3, 2, 1. Ethis keyword. 3, 2, 1. 1 runtime semantics. Evaluation. Primary expression. This. Return. Resolve this binding. 3, 2. 2 identifier reference. C13.1 for identifier reference 1 3, 2. 3 literals. Syntax. Literal. Null literal. Boolean literal. Numeric literal. String literal. 3, 2, 3. 1 runtime semantics. Evaluation. Literal. Null literal 1. Return null. Literal. Boolean literal. If Boolean literal is the token false, return false. If Boolean literal is the token true, return true. Literal. Numeric literal. Return the numeric value of numeric literal as defined in 1 2, 9, 3. Literal. String literal. Return the SV of string literal as defined in 1 2, 9, 4, 2, 46. ECMA International 2024 1 3, 2, For array initializer, array elements may be elided at the beginning, middle, or end of the element list. Whenever a comma in the element list is not preceded by an assignment expression, that is, a comma at the beginning or after another comma, the missing array element contributes to the length of the array and increases the index of subsequent elements. Elided array elements are not defined. If an element is elided at the end of an array, that element does not contribute to the length of the array. Syntax: array literal, yield, await, elision ort, element list yield await, element list yield await, elision ort, element list, yield, await, elision ort assignment expression, plus in yield await, elision ort spread element yield await, element list yield await, elision ort assignment expression, plus in yield await, element list yield await, elision ort spread element yield await, elision, spread element, yield, await, dot. Assignment expression, plus in yield await, 1 3, 2, 4, 1 runtime semantics, array accumulation. The syntax-directed operation array accumulation takes arguments array, and next int x, an integer, and returns either a normal completion containing an integer or an abrupt completion. It is defined piecewise over the following productions. Elision. Let len be next index plus 1. Perform. Set. Array. Length. Len. True. Note: the above step throws if len exceeds 232. 1. Return len. Elision. Return. Array accumulation of elision with arguments array and next index plus 1. Element list. Elision ort assignment expression. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw array to string next int x. Init value. Return next index plus 1. Note: an array literal is an expression describing the initialization of an array using a list of 0 or more expressions, each of which represents an array element, enclosed in square brackets. The elements need not be literals. They are evaluated each time the array initializer is evaluated. ECMA International 2024 247. Element list. Elision ort spread element. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Return. Array accumulation of spread element with arguments array and next index. Element list. Elision ort assignment expression. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index. Let init result be. Evaluation of assignment expression. Let init value be. Get value. Init result. Perform. Create data property or throw array to string next int x. Init value. Return next index plus 1. Element list. Elision ort spread element. Set next index 2. Array accumulation of element list with arguments array and next index. If elision is present, then a set next index 2. Array accumulation of elision with arguments array and next index 3. Return. Array accumulation of spread element with arguments array and next index. Spread element. Assignment expression. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. B if next is done. Return next index. C perform. Create data property or throw array to string next int x. Next. D set next index to next index plus 1. Note: create data property or throw is used to ensure that own properties are defined for the array, even if the standard built-in array prototype object has been modified in a manner that would preclude the creation of new own properties using 3, 2, 4, 2. Runtime semantics. Evaluation. Array literal. Elision ort. Let array be. Array create 0 if elision is present, then a perform. Array accumulation of elision with arguments array and 0, 3. Return array. Array literal. Element list. Let array be. Array create. 0. Perform. Array accumulation of element list with arguments array and 0. Return array. Array literal. Element list. Elision opt. 2. Let array be. Array create. 0. Let next index be. Array accumulation of element list with arguments array and 0. 48. ECMA I. International 2024. 3. If elision is present, then a perform. Array accumulation of elision with arguments array and next index. Return array. 3. 2. 5. Object initializer. Syntax. Object literal. Yield. Await. Property definition list yield await. Property definition list yield await. Property definition list. Yield. Await. Property definition yield await. Property definition list yield await. Property definition yield await. Property definition. Yield. Await. Identifier reference yield await. Cover initialized name yield await. Property name yield await. Assignment expression. Plus in yield await. Method definition yield await. Dart. Assignment expression. Plus in yield await. Property name. Yield. Await. Literal property name. Computed property name yield await. Literal property name. Identifier name. String literal numeric literal. Computed property name. Yield. Await. Assignment expression. Plus in yield await. Cover initialized name. Yield. Await. Identifier reference yield await. Initializer. Plus in yield await. Initializer. In. Yield. Await. Assignment expression in yield await. Note 2 method definition is defined in 15.4. Note 1 an object initializer is an expression describing the initialization of an object, written in a form resembling a literal. It is a list of 0 or more pairs of property keys and associated values, enclosed in curly brackets. The values need not be literals. They are evaluated each time the object initializer is evaluated. Copyright sign. ECMA International 2024 249. Note 3 in certain contexts, object literal is used as a cover grammar for a more restricted secondary grammar. The cover initialized name production is necessary to fully cover these secondary grammars. However, use of this production results in an early syntax error in normal contexts where an actual object literal is expected. 3, 2, 5, 1 static semantics. Early errors. Property definition. Method definition. Bullet. It is a syntax error if has direct super of method definition is true. It is a syntax error if private bound identifiers of method definition is not empty. In. Used as a cover grammar for object assignment pattern and may be recognized as part of a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. When object literal appears in a context where object assignment pattern is required, the following early error rules are not applied. In addition, they are not applied when initially parsing a capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N or capital C O V E R capital C A L L capital E X P R E S S I O N capital A N D capital A S Y N C capital A R R. Property definition. Cover initialized name. It is a syntax error if any source text is matched by this production. Object literal. Property definition list. Property definition list. It is a syntax error if property name list of property definition list contains any duplicate entries for proto and at least 2 of those entries were obtained from productions of the form. Property definition. Property name. Assignment exp. Russian. This rule is not applied if this object literal is contained within a script that is being parsed for JSON parse. See step 4 of JSON parse. 3, 2, 5. To static semantics is computed property key. The syntax-directed operation is computed property key takes no arguments and returns a boolean. It is defined piecewise over the following productions: property name, literal property name, return false, property name, computed property name, return true. Addition to describing an actual object initializer, the object literal productions are also 250. ECMA International 2024. Note 1. This production exists so that object literal can serve as a cover grammar for object assignment pattern. It cannot occur in an actual object initializer. Note 2. The list returned by property name list does not include property names defined using a computed property name. 1, 3, 2, 5, 3. Static semantics. Property name list. The syntax-directed operation property name list takes no arguments and returns a list of strings. It is defined piecewise over the following productions: property definition list. Property definition. Let prop name be prop name of property definition. If prop name is empty, return a new empty list. Return prop name. Property definition list. Property definition list. Property definition. Let list be property name list of property definition list. Let prop name be prop name of property definition. If prop name is empty, return list. Return the list concatenation of list and prop name. 3, 2, 5, 4. Runtime semantics. Evaluation. Object literal. Return ordinary. Object create. Object prototype. Object literal. Property definition list. Property definition list. Let obj be ordinary. Object create. Object prototype. Perform. Property definition. Evaluation of property definition list with argument obj. Return obj. Literal property name. Identifier name. Return string value of identifier name. Literal property name. String literal 1. Return the SV of string literal. Literal property name. Numeric literal. Let NBR be the numeric value of numeric literal. Return. To string. NBR. Computed property name. Assignment expression. Let exp value be. Evaluation of assignment expression. Let prop name be. Get value. Exp value. Return. To property key. Prop name. 3, 2, 5. 5. Runtime semantics. Property definition evaluation. The syntax-directed operation property definition evaluation takes argument object, an object, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: property definition list, property definition list, property definition. Perform. Property definition evaluation of property definition list with argument object. Perform. Property definition evaluation of property definition with argument object. Return unused. ECMA International 2024 251. Property definition. Assignment expression. Let exp value be. Evaluation O. F assignment expression. Let from value be. Get value. Exp value. Let excluded names be a new empty list. Perform. Copy data properties. Object. From value. Excluded names. Return unused. Property definition. Identifier reference. Let prop name be string value of identifier reference. Let exp value be. Evaluation of identifier reference. Let prop value be. Get value. Exp value. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw. Object. Prop name. Prop value. Return unused. Property definition. Property name. Assignment expression. Let prop key be. Evaluation of property name. If this property definition is contained within a script that is being evaluated for JSON parse, see step 7 of JSON parse. Then, a let is proto set to be false. Else if prop key is proto and is computed property key of property name is false, then a let is proto set to be true. Else, a let is proto set to be false. If is anonymous function definition, assignment expression, is true and is proto setter as false, then a let prop value be. Named evaluation of assignment expression with argument prop key. Else, a let exp value ref be. Evaluation of assignment expression be let prop value be. Get value, exp value ref. If is proto setter as true, Then, if proper value is an object or proper value is null, then I perform object, prop value be return unused. Assert. Object is an ordinary, extensible object with no non-configurable properties. Perform. Create data property or throw, object, prop key, prop value 0. Return unused. Property definition. Method definition. Perform. Method definition. Evaluation of method definition with arguments object and true. Return unused. 3, 2, 6 function defining expressions. See 15.2 for primary expression. Function expression. See 15.5 for primary expression. Generator expression. See 15.7 for primary expression. Class expression. See 15.8 for primary expression. Async function expression. See 15.6 for primary expression. Async generator expression. 52. Copyright sign. ECMA International 2024. 132. 7 regular expression literals syntax. C12. 9. 5. 3. 2. 7. 1 static semantics. Early errors. Primary expression. Regular expression literal. It is a syntax error if capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, regular expression literal, is false. 3, 2, 7, 2 static semantics, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, literal. The abstract operation, capital I, S, capital V, A, L, I, D, capital R, E, G, U, L, A, R, capital E, X, P, R, E, S, S, I, O, N, capital L, I, T, E, R, A, takes argument literal, a regular expression literal parse node, and returns a boolean. It determines if its argument is a valid regular expression literal. It performs the following steps when called. Let flags be flag text of literal. If flags contains any code points other than D, G, I, M, S, U, V, or Y, or if flags contains any code point more than once, return false. If flags contains U, let U be true, else let U be false. If flags contains V, let TV be true, else let V be false. Let pattern text be body text of literal. If U is false and V is false, then let string value be code points to string. Pattern text. B set pattern text to the sequence of code points resulting from interpreting each of the 16-bit elements of string value as a Unicode BMP code point. UTF-16 decoding is not applied to the elements. Let parse result be parse pattern. Pattern text. U, V. If parse result is a parse node, return true, else return false. 3, 2, 7, 3 runtime semantics. Evaluation primary expression, regular expression literal. Let pattern be code points to string, body text of regular expression literal. Let flags be code points to string, flag text of regular expression literal. Return. regexp create, pattern, flags. 3, 2, 8 template literals syntax. Template literal, yield, await, tagged. No substitution template. Substitution template yield await tagged. Substitution template yield await tagged. Template head expression plus in yield await. Template spans yield await tagged. Template spans yield await tagged. Template tail. Template middle list yield await tagged. Template tail. ECMA International 2024 253. Template middle list. Yield. Await. Tagged. Template middle expression. Plus in yield await. Template middle list yield await tagged. Template middle expression. Plus in yield await. 3, 2, 8, 1 static semantics. Early errors. Template literal. Yield. Await. Tagged. No substitution template. It is a syntax error if the tagged parameter was not set and no substitution template contains not escape sequence. Template literal. Yield. Await. Tagged. Substitution template yield await tagged. It is a syntax error if the number of elements in the result of template strings of template literal with argument false is greater than or equal to 232. Substitution template. Yield. Await. Tagged. Template head expression. Plus in yield await. Template spans yield await tagged. It is a syntax error if the tagged parameter was not set and template head contains not escape sequence. Template spans. Yield. Await. Tagged. Template tail. It is a syntax error if the tagged parameter was not set and template tail contains not escape sequence. Template middle list. Yield. Await. Tagged. Template middle expression. Plus in yield await. Template middle list yield await tagged. Template middle expression. Plus in yield await. It is a syntax error if the tagged parameter was not set and template middle contains not escape sequence. 3, 2, 8, 2 static semantics. Template strings. The syntax-directed operation template strings takes argument draw, a boolean, and returns a list of either strings or undefined. It is defined piecewise over the following productions. Template literal. No substitution template. Return template string. No substitution template. Raw. Substitution template. Template head expression template spans. Let head be template string. Template head. Raw. Let tail be temp. 8 strings of template spans with argument draw. Return the list concatenation of head and tail. Template spans. Template tail. Return template string. Template tail. Raw. Template spans. Template middle list template tail. Let middle be template strings of template middle list with argument draw. Let tail be template string. Template tail. Raw. Return the list concatenation of middle and tail. 54. ECMA International 2024. Template middle list. Template middle expression 1. Return template string. Template middle. Raw. Template middle list. Template middle list template middle expression. Let front be template strings of template middle list with argument draw. Let last be template string. Template middle. Raw. Return the list concatenation of front and last. 3, 2, 8, 3 static semantics. Template string. Template token. Raw. The abstract operation template string takes arguments template token. A no substitution template parse node. A template head parse node. A template middle parse node, or a template tail parse node, and raw, a boolean, and returns a string or undefined. It performs the following steps when called. If raw is true, then a let string be the TRV of template token, else a let string be the TV of template token. Return string. 3, 2, 8, 4 get template object. Template literal. The abstract operation get template object takes argument template literal, a parse node, and returns an array. It performs the following steps when called. Let realm be the current realm record. Let template registry be realm. For each element of template registry, do if E is the same parse node as template literal, then I return E. Let raw strings be template strings of template literal with argument true. Assert. Raw strings is a list of strings. Let cook strings be template strings of template literal with argument false. Let count be the number of elements in the list cook strings. Assert. Count 232 1. Let template be array create. Count 0. Let raw obj be array create. Count 1. Let index be 0 2. Repeat. While index count a let prop be to string. Index B let cooked value be cook strings. Index C perform. Define property or throw. Template. Prop. Property descriptor. Cooked value. Writable. False. True. False. D let raw value be the string value raw strings. index e perform, define property or throw, raw obj, prop, property descriptor, raw value, false, true, false, f set index to index plus 1, 3, perform, set integrity level, raw obj, frozen, 4, perform, define property or throw, template, raw, property descriptor, raw obj, false, enumerable, false, false, 5, perform, set integrity level, template, frozen, 6, append the record, template literal, template, to realm, 7, return template. Note this operation returns undefined if raw is false and template token contains a not escape sequence. In all other cases, it returns a string. ECMA International 2024 255. Note 1. The creation of a template object cannot result in an abrupt completion. Note 2. Each template literal in the program code of a realm is associated with a unique template object that is used in the evaluation of tagged templates. 1, 3, 2, 8, 6. The template objects are frozen and the same template object is used each time a specific tag template is evaluated. Whether template objects are created lazily upon first evaluation of the template literal or eagerly prior to first evaluation is an implementation choice that is not observable to ECMAScript code. 1, 3, 2, 8, 5. Runtime semantics. Substitution evaluation. The syntax-directed operation substitution evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Template spans. Template tail. Return a new empty list. Template spans. Template middle list. Template tail. Return. Substitution evaluation of template middle list. Template middle list. Template middle expression. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Return sub. Template middle list. Template middle list. Template middle expression. Let preceding be. Substitution evaluation of template middle list. Let next ref be. Evaluation of expression. Let next be. Get value. Next ref. Return the list concatenation of preceding and next. 3, 2, 8, 6. Runtime semantics. Evaluation. Template literal. No substitution template. Return the TV of no substitution template as defined in 1, 2, 9, 6. Substitution template. Template head expression. Template spans. Let head be the TV of template head as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To string. Sub. Let tail be. Evaluation of template spans. Return the string concatenation of head, middle, and tail. 56. ECMA International 2024. Note 3. Future editions of this specification may define additional non-enumerable properties of template objects. Note 1. The string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Template spans. Template tail. Return the TV of template tail as defined in 1, 2, 9, 6. Template spans. Template middle list. Template tail. Let head be. Evaluation of template middle list. Let tail be the TV of template tail as defined in 1, 2, 9, 6. Return the string concatenation of head and tail. Template middle list. Template middle expression. Let head be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let middle be. To str in. Sub. Return the string concatenation of head and middle. Template middle list. Template middle list. Template middle expression. Let rest be. Evaluation of template middle list. Let middle be the TV of template middle as defined in 1, 2, 9, 6. Let subref be. Evaluation of expression. Let sub be. Get value. Subref. Let last be. To string. Sub. Return the string concatenation of rest, middle, and last. 3, 2, 9. The grouping operator. 3, 2, 9. 1. Static semantics. Early errors. Primary expression. Capital C, O, V, E, R. Capital P, A, R, E, N, T H E S I Z E D capital E X P R E S S I O N capital A N capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N must cover a parenthesized expression. 3, 2, 9. To runtime semantics. Evaluation. Primary expression. Capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Let expa be the parenthesized expression that is covered by capital C O V E R capital P A R E N T H E S I Z E D capital E X P R E S S I O N capital A N. Return. Evaluation of expa parenthesized expression. Expression. Return. Evaluation of expression. This may be of type reference. Note to the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note 3 the string conversion semantics applied to the expression value like string prototype concat rather than the plus operator. Note this algorithm does not apply get value to evaluation of expression. The principal motivation for this is so that operators such as delete and type off may be applied to parenthesized expressions. ECMA International 2024 257 13.3 left-hand side expressions syntax. Member expression, yield, await. Primary expression yield await. Member expression yield await. Expression, plus in yield await. Member expression yield await. Identifier name member expression yield await. Template literal yield await, plus tagged super property yield await, meta property, new member expression yield await, arguments yield await, member expression yield await, private identifier super property, yield await, super expression, plus in yield await, super identifier name meta property. New target. Import meta new target. New target. Import meta. New expression. Yield, await, member expression yield await, new expression yield await, call expression, yield, await, capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, yield await, super call yield await, import call yield await, call expression yield await, arguments yield await, call expression yield await, expression, plus in yield await, call expression yield await. Identifier name, call expression yield await, template literal yield await, plus tagged, call expression yield await. Private identifier super call, yield, await. Super arguments yield await. Import call, yield, await. Import, assignment expression, plus in yield await. Arguments, yield, await. Argument list yield await. Argument list yield await. 58. ECMA International 2024. Argument list, yield, await. Assignment expression, plus in yield await. Dart. Assignment expression, plus in yield await. Argument list yield await. Assignment expression, plus in yield await. Argument list yield await. assignment expression, plus in yield await, optional expression, yield, await, member expression yield await, optional chain yield await, call expression yield await, optional chain yield await, optional expression yield await, optional chain yield await, optional chain, yield, await, arguments yield await, expression, plus in yield await, identifier name, template literal yield await, plus tagged, private identifier, optional chain yield await, arguments yield await, optional chain yield await, expression, plus in yield await, optional chain yield await, identifier name, optional chain yield await, template literal yield await, plus tagged, optional chain yield await, private identifier, left-hand side expression, yield, await, new expression yield.
So, now I think I'm back.
Processing an instance of the production, call expression, capital C, O.
I need some more caffeine.
Capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. The interpretation of capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R, is refined using the following grammar. Call member expression, yield, await, member expression yield await, arguments yield await. 3, 1 static semantics. 3, 1 static semantics. Early errors. Optional chain. Template literal. Optional chain template literal. It is a syntax error if any source text is matched by this production. ECMA International 2024 259. Note this production exists in order to prevent automatic semicolon insertion rules 12.10 from being applied to the following code A, B, C, so that it would be interpreted as two valid statements. The purpose is to maintain consistency with similar code without optional chaining A, B, C, which is a valid statement and where automatic semicolon insertion does not apply. Import meter. Import meta. It is a syntax error if the syntactic goal symbol is not module 1.3.3 to property accessors. Note properties are accessed by name, using either the dot notation, member expression, identifier name call expression, identifier name, or the bracket notation, member expression, expression, call expression, expression. The dot notation is explained by the following syntactic conversion. Member expression, identifier name is identical in its behavior to member expression, identifier name string, and similarly, call expression, identifier name is identical in its behavior to call expression, identifier name string, where identifier name string is the result of evaluating string value of identifier name. 3, 2, 1 runtime semantics, evaluation, member expression, expression, let base reference be. Evaluation of member expression, let base value be. Get value, base reference. If the source text matched by this member expression is strict mode code, let strict be true, else let strict be false. Return. Capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital E, X, P, R, base value, expression, strict, 60, ECMA International 2024, member expression, identifier name, let base reference be. Evaluation of member expression, let base value be. Get value, base reference. If the source text match by this member expression is strict mode code, let strict be true, else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict member expression private identifier let base reference be evaluation of member expression let base value be get value base reference let field name string be the string value of private identifier return make private reference base value field name string call expression expression let base reference be evaluation of call expression let base value be get value base reference if the source text match by this call expression is strict mode code let strict be true else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict call expression identifier name let base reference be evaluation of call expression let base value be get value base reference if the source text match by this call expression is strict mode code let strict be true else let strict be false. Return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict call expression private identifier let base reference be evaluation of call expression let base value be get value base reference let field name string be the string value of private identifier return make private reference base value field name string 3 capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R base value expression strict the abstract operation capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R takes arguments base value, an ECMAScript language value, expression, an expression parse node, and strict, a boolean, and returns either a normal completion containing a reference record or an abrupt completion. It performs the following steps when called. Let property name reference be. Evaluation of expression. Let property name value be. Get value. Property name reference. Let property key be. To property key, property name value. Return the reference record. Base value, property key, strict. This value, empty. 3, 4, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, base value, identifier name, strict. The abstract operation, capital E, V, A, L, U, A, T, E, capital P, R, O, P, E, R, T, Y, capital A, C, C, E, S, S, capital W, I, T, H, capital I, D, E, N, takes arguments base value, an ECMAScript language value, identify an identifier name parse node.
It was I don't know. Control find seems buggy. It was finding more files a second ago, and now it's not finding those files that it was. So I don't know, something's off. Let's try the research program.
New expression, empty, member expression, new member expression arguments 1. Return. Evaluate new, member expression, arguments 3, 5, 1. 1 evaluate new, construct expr, arguments. The abstract operation evaluate new takes arguments construct expr, a new expression parse node or remember expression parse node, and arguments, empty or an arguments parse node, and returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. Let ref be. Evaluation of construct expr. Let constructor be. Get value, ref. If arguments is empty, then a let arglist be a new empty list for. Else a let arglist be. Argument list evaluation of arguments. If is constructor is false, throw a type error exception. Return. Construct, constructor, arglist. 3, 6 function calls. 3, 6, 1 runtime semantics. Evaluation. Call expression. Capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Let expr be the call member expression that is covered by capital C, O, V, E, R, capital C, A, L, L, capital E, X, P, R, E, S, S, I, O, N, capital A, N, D, capital A, S, Y, N, C, capital A, R, R. Let member expr be the member expression of expr. Let arguments be the arguments of expr. Let ref be. Evaluation of member expr. Let fun be. Get value, ref. If ref is a reference record, is property reference, ref is false, and ref is eval, then if same value, func, %eval %, is true, then I let arglist be. Argument list evaluation of arguments. 2. If arglist has no elements, return undefined. 3. Let eval arg be the first element of arglist. 5. If the source text matched by this call expression is strict mode code, let strict caller be true, otherwise let strict caller be false. V return. Perform eval arg, strict caller, true. Let this call be this call expression. Let tail call be as in tail position. This call. Return. Evaluate call. Func. Ref. Arguments. Tail call. A call expression evaluation that executes step 6 AV is a direct eval. Call expression arguments. Let ref be. Evaluation of call expression. Let func be. Get value, Ref. Let this call be this call expression. Let tail call be as in tail position. This call.
Oh, I was looking for signed in, not unsigned. That was a
1 3 3 6.
There's a lot of signed ins I gotta get after I get these unsigned. That's great.
U8 call takes arguments func. An ECMAScript language value. Ref. An ECMAScript language value or a reference record. Arguments. A parse node. And tail position. A boolean. And returns either a normal completion containing an ECMAScript language value or an abrupt completion. It performs the following steps when called. If ref is a reference.
So I got 7,000, or yeah, it's just 7,119 unsigned, and then 9,688 signed. It's great. It's better than 20,000 on minimum. It's less than 10,000. But it's more than 100 or 20. It's
is true. Perform prepare for tail call. Return. Call. Func. This value. Arglist. 3 3 7th super keyword. 3 3 7 1 runtime semantics. Evaluation super property. Super. Expression. Let env get this environment. Let actual this be.
I think I'm gonna finish off the unsigned ins, replacing them, and then I'll get to the signed ins.
Let property key be. To property key, property name value. If the source text matched by the super property is strict mode code, let strict be true, else let strict be false. Return. Make super property reference. Actual this. Property key. Strict. Super property.
And then after all this, I gotta go through and find all the address arithmetic and update all that too. It's a lot more difficult to find. It's not just a keyword. Yeah.
New target beget new target. Assert. New target is an.
This is getting old.
If this constructor, func, is false, throw a type error exception. Let result be. Construct. Func. Arglist. New target. Let the ser beget this environment. Perform the ser bind this value. Result. Let f be the ser. 0. Assert. F is an ECMAScript function object. 1. Perform. Initialize instance elements. Result. F2. Return result. ECMA International 2024 263 133 to get superconstructor. The abstract operation get superconstructor takes no arguments and returns an ECMAScript language value. It performs the following steps when called. Let envrec beget this environment. Assert. envrec is a function environment record. Let active function be envrec. Assert. Active function is an ECMAScript function object. Let superconstructor be active function. Return superconstructor. 3 7 3 make super property reference. Actual this. Property key. Strict. The abstract operation makes super property reference takes arguments actual this. An ECMAScript language value. Property key. A property key. And strict. A boolean. And returns either a normal completion containing a super reference record or a throw completion. Capital IT performs the following steps when called. Let env beget this environment. Assert. env has super binding. Is true. Let base value be env get super base. Return the reference record. Base value. Property key. Strict. This value. Actual this. 3 8 argument lists. Note the evaluation of an argument list produces a list of values 1 3 8 1 runtime semantics. Argument list evaluation. The syntax-directed operation argument list evaluation takes no arguments and returns either a normal completion containing a list of ECMAScript language values or an abrupt completion. It is defined piecewise over the following productions. Arguments. Return a new empty list. Argument list. Assignment expression. Let be. Evaluation of assignment expression. Let arg be. Get value. Ref. Return arg. Argument list. Assignment expression. Let list be a new empty list. Let spread ref be. Evaluation of assignment expression. Let spread obj be. Get value. Spread ref. Let iterator record be. Get iterator. Spread obj. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return list. See append next to list. Argument list. Argument list. Assignment expression. 1. 2. Let preceding args be. Argument list. Evaluation of argument list. Let ref be. Evaluation of assignment expression. 64. ECMA International 2024. 3. Let arg be. Get value. Ref. Return the list concatenation of preceding args and arg. Argument list. Argument list. Assignment expression. Let preceding args be. Argument list. Evaluation of argument list. Let spread ref be. Evaluation of assignment expression. Let iterator record be. Get iterator. Get value. Spread ref. Sync. Repeat. Let next be. Iterator step value. Iterator record. Be if next is done. Return preceding args. See append next to preceding args. Template literal. No substitution template. Let template literal be this template literal. Let site obj be get template object. Template literal. Return site obj. Template literal. Substitution template. Let template literal be this template literal. Let site obj be get template object. Template literal. Let remaining be. Argument list. Evaluation of substitution template. Return the list concatenation of site obj and remaining. Substitution template. Template head expression. Template spans. Let first subref be. Evaluation of expression. Let first sub be. Get value. First subref. Let rest sub be. Substitution evaluation of template spans. Assert. Rest sub is a possibly empty list. Return the list concatenation of first sub and rest sub. 3. 9 optional chains. 3. 9. 1 runtime semantics. Evaluation. Optional expression. Member expression optional chain. Let base reference be. Evaluation of member expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return. Undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Optional expression. Call expression optional chain. Let base reference be. Evaluation of call expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. Note an optional chain is a chain of one or more property accesses and function calls, the first of which begins with the token. ECMA International 2024 265. Optional expression. Optional expression optional chain. Let base reference be. Evaluation of optional expression. Let base value be. Get value. Base reference. If base value is either undefined or null, then a return undefined. Return. Chain evaluation of optional chain with arguments base value and base reference. 3. 9. 2 runtime semantics. Chain evaluation. The syntax-directed operation chain evaluation takes arguments base value, an ECMAScript language value, and base reference, an ECMAScript language value or a reference record, and returns either a normal completion containing either an ECMAScript language value or a reference record, or an abrupt completion. It is defined piecewise over the following productions. Optional chain. Arguments. Let this chain be this optional chain. Let tail call be as in tail position. This chain. Return. Evaluate call. Base value. Base reference. Arguments. Tail call. Optional chain. Expression. If the source text matched by this optional chain is strict mode code, let strict be true, else let strict be false. Return. Capital E V A L U A T E, capital P R O P E R T Y, capital A C C E S S capital W I T H capital E X P R base.
This whole thing is a lot more complicated than I remember. It's really annoying. Oh man, I'm gonna take a break. Oh, it sucks so bad. It's gonna take forever.
P R O P E R T Y capital A C C E S S capital W I T H capital I D E N base value identifier name strict optional chain. Private identifier. Let field name string be the string value of private identifier. Return make private reference. Base value. Field name string. Optional chain. Optional chain arguments. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. Let this chain be this optional chain. Let tail call be as in tail position. This chain return. Evaluate call. New value. New reference. Arguments. Tail call. Optional chain. Optional chain. Expression. Let optional chain be optional chain. Let new reference be. Chain evaluation of optional chain with arguments base value and base reference. Let new value be. Get value. New reference. If the source text match by this optional chain is strict mode code, let strict be true. Else let strict be false. Return. Capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W I T H capital E X P R new value expression strict optional chain identifier name let optional chain be optional chain let new reference be chain evaluation of optional chain with arguments base value and base reference let new value be get value new reference if the source text match by this optional chain is strict mode code let strict be true else let strict be false return capital E V A L U A T E capital P R O P E R T Y capital A C C E S S capital W.
I wrote this JavaScript engine to like work in like on really low level like computers and stuff, and I had to like spend a year optimizing it because doing a bunch of like memory's a game where you access pieces of memory to access other pieces of memory. Memory. Man, there's an echo in this mic. And the way I originally had it set up, there's too many small pieces of memory accessing other pieces of memory. So I had to like I had to rewrite it to account for bigger chunks of memory. I had to whatever. I can't explain it. It's whatever. So I have like several different versions of the program that I can like toggle between depending on how I want to build it. And I gotta like update them all. I don't want to have to like change the build and test every time I update it, so I'm only replacing a keyword. So if I'm really careful and only replace the keyword, I can assume that it won't break old code, because I still want to maintain that old code to run on lower level computers. It'll take so long to like test every possible build mode.
Used. Let module be module completion.
So
Doing steps when called.
I think I'm just gonna like replace all the type keywords. I'm gonna get that over with. And then I'm gonna write a program or a script or something to like search all the files, and then add some define guard at the top to throw a compiler warning to say this file's not been updated to support 64-bit arithmetic if it's a 64-bit build. And then I can update only the files that are in use for the modern computer build, and all the old stuff will exist packed away in the folders, so I can still have it. It won't support 64-bit until I update it, but then when it builds, if I pick a build configuration that pulls in one of those older files that doesn't have that I didn't update, that I didn't turn off the thing at the top to say this hasn't been updated, it'll catch it and it'll throw a warning. At least I'll be warned, and I'll be like, oh, I gotta like go through this stupid file and update it, instead of having to like have it build and be like, oh shit, something's wrong, where is it wrong, and I have to like figure it out every time. So I think I'm gonna do that. So I'm just gonna get to these 7,000, the 9,000. I just want to get this keyword in place at least in all the files, even if I'm not updating them all. So like this is just done. And then when I get to arithmetic, I'll have to like systematically pick what to update so I don't waste time on the older build modes, because I don't know. I kind of it's my plan without really explaining everything or giving anything away.
March
This take forever.
2. 1 runtime semantics. Evaluation. New target. New target 1. Return get new target. Import meter. Import meta. Let module be get active script or module. Assert. Module is a source text module record. Let import meter be module if import meter is empty. Then A set import meter to ordinary object create. Null. B let import meter values be host get import meter properties. Module C for each record. P of import meter values. Do I perform. Create data property or throw. Import meter. P D perform host finalize import meter. Import meter. Module E set module to import meter. F return import meter. Else A assert. Import meter is an object. B return import meter. 3. 1 2 1. 1 host get import meter properties. Module record. The host defined abstract operation host get import meter properties takes argument module record, a module record, and returns a list of records with fields, an ECMAScript language value. It allows hosts to provide property keys and values for the object returned from import meter. The default implementation of host get import meter properties is to return a new empty list. Note attack template is a function call where the arguments of the call are derived from a template literal 1328. The actual arguments include a template object 1328 and the values produced by evaluating the expressions embedded within the template literal 68. Copyright sign, ECMA International 2024, 1331212. To host finalize import meter. Module record. The host-defined abstract operation host finalize. Import meter takes arguments import meter, an object, and module record, a module record, and returns unused. It allows hosts to perform any extraordinary operations to prepare the object returned from import meter. Most hosts will be able to simply define host get import meter properties and leave host finalize import meter with its default behavior. However, host finalize import meter provides an escape hatch for hosts which need to directly manipulate the object before it is exposed to ECMAScript code. The default implementation of host finalize import meter is to return unused. 3.4 Update expression syntax. Update expression, yield, await, left-hand side expression yield await, left-hand side expression yield await, left-hand side expression yield await, plus unary expression yield await, unary expression yield await, 1 3 4 1 static semantics, early errors, update expression, left-hand side expression plus, no line terminator here, plus, no line terminator here, left-hand side expression. It is an early syntax error if assignment target type of left-hand side expression is not simple. Update expression plus unary expression. Unary expression. It is an early syntax error if assignment target type of unary expression is not simple. 3 4 2 postfix increment operator 1 3 4 2 1 runtime semantics. Evaluation. Update expression. Left-hand side expression plus, let LHS be. Evaluation of left-hand side expression, let old value be. Numeric. Get value, LHS. If old value is a number, then a let new value be number. Add old value, 1. Else assert old value is a big int. Be let new value be big int. Add old value, 1z. Perform. Put value, LHS. New value. Return old value. ECMA International 2024 269. 1 3 4 3 postfix decrement operator 1 3 4 3 1.
Windows 7 had some way to like Sublime. I could have different thumbnails for like different file types. So like a C file and a JavaScript file and a header file, a CSS file, HTML file. Like I could change the icon to like make so I could tell like it's gonna be open in Sublime and it's a C file, it's a this file, it's a that file, and that's gone. Or like I don't know how to do that in Windows 11 because I've been like dragging my old Sublime text settings from like 2000 whatever, from like every install whatever, like from Sublime Text 2 so whatever, and I think that kind of like disappeared, or we're gonna look it up. I don't know how to do that again, but I need to like tell what gets opened by what by changing the default program to change the icon so we can like see it better, because I don't know, whatever, this is annoying. I gotta like I think change a default program that it opens in by file type so I can like this is just, I don't know, Windows 11 sucks. You're like, I'm not gonna complain, whatever. I'll just shut up and whatever.
The International 2000.
I need to stop saying whatever. I don't know why, that's my new word. I need to stop saying whatever.
Yield await. Delete unary expression yield await. Void unary expression yield await. Type of unary expression yield await plus unary expression yield await. Unary expression yield await. Unary expression yield await. Unary expression yield await plus await. Await expression yield 3 5 1. The delete operator 3 5 1 1 static semantics. Early errors. Unary expression. Delete unary expression. It is a syntax error if the unary expression is contained in strict mode code and the derived unary expression is primary expression. Identifier reference. Member expression. Member expression. Private identifier. Call expression. Call expression. Private identifier. Optional chain. Private identifier. Or optional chain. Optional chain. Private identifier. It is a syntax error if the derived unary.
I have some duplicate files, so
O V E R capital P A R E N.
this 429 files might come down to like 380 files. I have to like carefully remove only what's not needed. I have a backup, but it sucks to get a backup and then like try to make it work with whatever has changed between the old version and the new version.
T H E S I.
I can't believe we still have file systems that are accessed by string names in a file path in 2025. It's just ridiculous. This is stupid. I should be able to like make a file, a folder, a data tree, paste something, have all the links and references hold. Everything should be possible. This Windows is, everything sucks ass.
Reference ref is true, then A assert ref is false. B return true if as property reference ref is true, then A assert is private reference ref is false. B if is super reference ref is true. Throw a reference error exception. C let base objb to object ref. D let delete status be base obj ref. E if delete status is false and ref is true. Throw a type error exception. F return delete status. Else a let base be ref. B assert base is an environment record. C return base delete binding ref. The last rule means that expressions such as delete foo produce early errors because note of recursive application of the first rule. ECMA International 2024 271. Note 1 when a delete operator occurs within strict mode code. A syntax error exception is thrown if its unary expression is a direct reference to a variable, function argument, or function name. In addition, if a delete operator occurs within strict mode code and the property to be deleted has the attribute false.
I think I need to go through all the file trees first and like prune all the files that are that look like duplicates, that I hope are duplicates, or copies between changes, and then I'll move them to a new folder outside of the main directory that's being searched to try to cut down that 7,000, 9,000 so it doesn't feel so overwhelming, and try to get like only the files that are needed, whatever.
Semantics. Evaluation. Unary expression. Type of unary expression. Let val be. Evaluation of unary expression. If val is a reference record, then if is unresolvable reference, val is true. Return undefined. Set val to get value. Val. If val is undefined, return undefined. If val is null, return object. If val is a string, return string. If val is a symbol, return symbol. If val is a boolean, return boolean. If val is a number, return number. 0. If val is a big int, return bigint. 1. Assert. Val is an object. 2. Note. The step is replaced in section B. 3, 6, 3. 3. If val has an internal slot, return function. 4. Return object. 3, 5. For unary plus operator. Note the unary plus operator converts its operand to number type. Note get value must be called even though its value is not used because it may have observable side effects. 272. ECMA International 2024. 13544. 1 runtime semantics, evaluation, unary expression, plus unary expression, let x be. Evaluation of unary expression, return to number. Get value, expa, 3, 5, 5 unary operator, 3, 5, 5, 1 runtime semantics, evaluation, unary expression, let x be. Evaluation of unary expression, let old value be. Denumeric. Get value, expa, if old value is a number, then a return number, unary minus, old value 4. Else, AB, assert, old value is a big int, return big int, unary minus, old value. The unary operator converts its operand to a numeric value and then negates it. Negating +0, note, produces -0, and negating -0 produces +0, bitwise not operator, unary expression, 3, 5, 6, 3, 5, 6, 1 runtime semantics, evaluation, let x be. Evaluation of unary expression, let old value be. Denumeric. Get value, expa, if old value is a number, then a return number, bitwise not, old value 4. Else, AB, assert, old value is a big int, return big int, bitwise not, old value, logical not operator, unary expression, 3, 5, 7, 3, 5, 7, 1 runtime semantics, evaluation, let x be. Evaluation of unary expression, let old value be to Boolean. Get value, expa, if old value is true, return false, return true. 3.6 exponentiation operator syntax, exponentiation expression, yield, await, unary expression yield await, update expression yield await, exponentiation expression yield await. ECMA International 2024 273 136 1 runtime semantics, evaluation, exponentiation expression, update expression, exponentiation expression, return. Capital E V A L U A T E, capital S T.
I hate deleting backups. Because I just like throw stuff in a folder, hoping I don't need it. And if I need it, I'm gonna be fucked. I'll just like move them into a directory outside of the directories in use and like make a note of the file path that the files were grouped at instead of like recreating the whole fucking folder tree. And I'll just throw files in there so if I need them later, they're there. Have a couple backups, whatever, and like 2.95 gigs. It's a waste of space.
Capital B I N A R Y, capital E, multiplicative expression, text, exponentiation expression, 3.8 additive operators syntax, additive expression, yield, await, multiplicative expression yield await, additive expression yield await plus multiplicative expression yield await, additive expression yield await, multiplicative expression yield await, 3, 8, 1 the addition operator, plus, note the addition operator either performs string concatenation or numeric addition, 3, 8, 1, 1 runtime semantics, evaluation, additive expression plus multiplicative expression, return. Capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R I C capital B I N A R Y capital E additive expression plus multiplicative expression. Note, the operator performs multiplication, producing the product of its operands. The operator performs division, producing the quotient of its operands. The percent operator yields the remainder of its operands from an implied division. 274. Copyright sign, ECMA International 2024. 138. To the subtraction operator. 3, 8, 2. 1 runtime semantics. Evaluation. Additive expression. Additive expression. Multiplicative expression. Return. Capital E V A L U A T E capital S T R I N G capital O R capital N U M E.
I'm gonna name the folder Copy Graveyard. It's pretty creative. That's my excitement for today. Copy Graveyard. I'm gonna put all the copies of backup copies of copies of copies. Yup.
Shift expression yield await. Additive expression yield await. Shift expression yield await. Additive expression yield await. 3, 9, 1 the left shift operator. 3, 9, 1. 1 runtime semantics. Evaluation. Shift expression. Shift expression. Additive expression. Return. Capital E V A L U A T E capital S.
Is the word graveyard a single word, or is there space in it? I don't know. Doesn't matter.
M E R I C capital B I N A R Y capital E shift expression. Additive expression. 3, 9. To the signed right shift operator. 3, 9, 2. 1 runtime semantics. Evaluation. Shift expression. Shift expression. Additive expression. Return. Capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E shift expression. Additive expression. 3, 9. 3 the unsigned right shift operator. Note, the operator performs subtraction, producing.
I just realized that I can take a screenshot and I'll paste that into the folder. And I don't have to make a readme note. Oh, this is gonna save a ton of time doing this. So like, I can like take the folder, the files, whatever. Just like this. And I drag them over to here. Oh crap, I gotta take the screenshot first. Let's put it back. Like this, whatever. Command. Okay. Windows key, Shift S. And take a. Oh, it's really laggy. Screenshot. And files in use, dang it, I gotta back up again. So I got my screenshot, pictures. I'll drag and drop this into here. And now, oh, this is great. So now I can like see that it was in this directory. Wrong button. I can open up this picture here. You can see the path name and stuff. I don't even have to make a README file. I can like grab these fucking files that are probably duplicates. And I'll drag them over here. Some say comments and some say notes. I'll just do those two.
Relational expression.
Drag them all over. Rename the folder to comments/notes. With notes. Or notes and copies. You can't have slash in a file, folder, whatever. Dang it. Notes or copy graveyard. That works. So now I can do Control F again, since there's a less to replace.
B. Evaluation of shift expression. Let val b. Get value. Ref. Let rb is less than val. Val. False. If r is either true or undefined, return false.
It's 410 files.
International 2024. Note to the in grammar parameter is needed to avoid confusing the in operator in a relational expression with the in operator in a for statement. Relational expression equals shift expression. Let ref b. Evaluation of relational expression. Let val b.
Okay, so that's a lot better. The other files that I was replacing at first, a couple days ago, those were like, they didn't say copy after it, but as I got through all the ones, the file names that didn't say copy, now when I'm going through things it finds, I see the word copy a lot in the file path name. So I'm gonna try to like get rid of some of those until there's less of them, and then I'll like dig through and like replace whatever's left. I don't know, it should go quicker. Because I don't want to like replace a bunch of files that are like notes or like copies of something. Because that's a waste of time.
Property, reval. To property key, val. Relational expression. Private identifier in shift expression. Let private identifier.
I won't say it. I'm not gonna let my ego win.
Let private env be the running execution context's private environment. Let private name be resolved private identifier. Private env. Private identifier. If private element find. Reval. Private name. Is not empty. Return true. Return false. 3. 1.
I think I still need to make a note of the file path so I won't have to like type it up. It'd be nice if you could have a screenshot or whatever and like highlight an area, tag it with text, but the operating system doesn't do that apparently. I don't know, I think I gotta think. I'm trying to like plan ahead when I get to going through the addresses, the address arithmetic. I want to wrap all the address arithmetic, whatever you want to call it, with macros for like every operation, and I want to try to like lots of times it's like I'll like divide by like some amount with the shift, and then I'll multiply, and then I'll OR to the bottom of the value, the field offset. I want to try to categorize all those operations and use macros instead of just put a literal in place, because I have to make a compiler that's going to go through, or a parser, whatever, a static code parser, an obfuscator. I don't know. I gotta like, there's like a bunch of files, a bunch of folders. It takes the compiler longer to build. When it's done, I'm gonna have to pass it through to like sanitize the whole program, remove all the redundancies and like inline things instead of including files over and over and over. So like it's like a recipe with a bunch of pieces, and this is only when I'm building it, but like the release build is gonna be like I'm gonna cut all the fat, really like streamline it so the compiler gets like a single file. You just like shoot through whatever and build it. So I'm trying to like I'm trying to think ahead. There's like a whole lot of things to account for. And I can't stop thinking of that while I'm trying to do this. I'm gonna go think for a minute. I'm gonna get back to this. I'm hoping I don't remove something that's needed and then like have to figure out why something's not working. So I'll be back.
Return true. 278. ECMA International 2024. Note the result of evaluating an equality operator is always of type Boolean, reflecting whether the relationship named by the operator holds between its two operands. Note 1. Given the above definition of equality, string comparison can be forced by $the equals $B. Numeric comparison can be forced by plus equals plus B. Boolean comparison can be forced by equals B. Note 2. The equality operators maintain the following invariants. A equals B is equivalent to a equals.
This computer's pretty good for 2 megahertz.
Always transitive. For example, there might be 2 distinct string objects, each representing the same string value. Each string object would be considered equal to the string value by the equals operator, but the 2 string objects would not be equal to each other. For example, new string the equals A and A equals new string the are both true. New string the equals new string the is false. Note 4. Comparison of strings uses a simple equality test on sequences of code unit values. There is no attempt to use the more complex, semantically oriented definitions of character or string equality and collating order defined in the Unicode specification. Therefore, strings values that are canonically equal according to the Unicode standard could test as unequal. In effect, this algorithm assumes that both strings are already in normalized form. 3.12 Binary bitwise operators syntax. Bitwise and expression in yield await. Equality expression in yield await. Bitwise and expression in yield await. And equality expression in yield await. Bitwise or expression in yield await. Bitwise and expression in yield await. Bitwise or expression in yield await. Bitwise and expression in yield await. Bitwise or 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 expression in yield await. 3. 1 2 1 Runtime semantics. Evaluation. Bitwise and expression. Bitwise and expression and equality expression. Return. Capital E. V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E bitwise and expression and equality expression. ECMA International 2024 279 bitwise or expression bitwise and expression. Return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E bitwise or expression bitwise and expression bitwise or expression bitwise or expression bitwise or expression. Return capital E V A L U A T E capital S T R I N G capital O R capital N U M E R I C capital B I N A R Y capital E bitwise or expression bitwise or expression. 3.13 Binary logical operators syntax. Logical and expression in yield await bitwise or expression in yield await. Logical and expression in yield await and bitwise or expression in yield await. Logical or expression in yield await. Logical and expression in yield await. Logical or expression in yield await. Logical and expression in yield await. Coalesce expression in yield await. Coalesce expression head in yield await. Bitwise or expression in yield await. Coalesce expression head in yield await. Coalesce expression in yield await. Bitwise or expression in yield await. Short circuit expression in yield await. Logical or expression in yield await. Coalesce expression in yield await. 3.13 runtime semantics. Evaluation. Logical and expression and bitwise or expression. Letter FB. Evaluation of logical and expression. Letter val b. Get value. Ref. Let bool be to boolean. Val. If bool is false, return val. Letter FB. Evaluation of bitwise or expression. Return. Get value. Ref. Logical or expression. Logical and expression. Letter FB. Evaluation of logical or expression. Letter val b. Get value. Ref. Let bool be to boolean. Val. If bool is true, return val. Letter FB. Evaluation of logical and expression. Return. Get value. Ref. 280. ECMA International 2024. The value produced by a and or operator is not necessarily of type boolean. The value produced, note, will always be the value of one of the two operand expressions. Coalesce expression head. Bitwise or expression. Letter FB. Evaluation of coalesce expression head. Letter val b. Get value. Ref. If the val is either undefined or null, then a letter FB. Evaluation of bitwise or expression b return. Get value. Ref. Else a return val. 3.14 Conditional operator. Syntax. Conditional expression in yield await. Short circuit expression in yield await. Short circuit expression in yield await. Assignment expression plus in yield await. Assignment expression in yield await. 3.14 runtime semantics. Evaluation. Conditional expression. Short circuit expression. Assignment expression. Letter FB. Evaluation of short circuit expression. Let val be to boolean. Get value. Ref. If val is true, then a let true ref b. Evaluation of the first assignment expression b return. Get value. True ref. Else a let false ref b. Evaluation of the second assignment expression be return. Get value, false ref. Note the grammar for a conditional expression in ECMAScript is slightly different from that in C and Java, which each allow the second sub-expression to be an expression but restrict the third expression to be a conditional expression. The motivation for this difference in ECMAScript is to allow an assignment expression to be governed by either arm of a conditional and to eliminate the confusing and fairly useless case of a comma expression as the center expression. ECMA International 2024 281 13.15 Assignment Operators Syntax. Assignment expression in yield await. Conditional expression in yield await plus yield. Yield expression in await. Arrow function in yield await. Async arrow function in yield await. Left-hand side expression yield await equals assignment expression in yield await. Left-hand side expression yield await. Assignment operator assignment expression in yield await. Left-hand side expression yield await. And equals assignment expression in yield await. Left-hand side expression yield await equals assignment expression in yield await. Left-hand side expression yield await equals assignment expression in yield await. Assignment operator, one of, equals percent equals plus equals and equals. 3, 1, 5, 1 static semantics. Early errors. Assignment expression. Left-hand side expression equals assignment expression. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. It is a syntax error if assignment target type of left-hand side expression is not simple. Assignment expression. Left-hand side expression assignment operator assignment expression left-hand side expression and equals assignment expression left-hand side expression equals assignment expression left-hand side expression equals assignment expression. It is a syntax error if assignment target type of left-hand side expression is not simple. 3. 1, 5, 2 runtime semantics. Evaluation. Assignment expression. Left-hand side expression equals assignment expression. 82. If left-hand side expression is neither an object literal nor an array literal, then a letter of B. Evaluation of left-hand side expression. BF is anonymous function definition, assignment expression, and is identifier ref of left-hand side expression are both true. Then I let eval B. Named evaluation of assignment expression with argument ref. C else I let ref B. Evaluation of assignment expression 2. Let eval B. Get value, ref D perform. Put value, ref. Reval E return reval. Let assignment pattern be the assignment pattern that is covered by left-hand side expression. ECMA International 2024. 3. Let ref B. Evaluation of assignment expression. Let eval B. Get value, ref perform. Capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, T, capital E, V, A, L, U, A, T, of assignment pattern with argument reval. Return reval. Assignment expression. Left hands. Id expression assignment operator assignment expression. Let ref B. Evaluation of left-hand side expression. Let eval B. Get value. Ref. Let ref B. Evaluation of assignment expression. Let eval B. Get value. Ref. Let assignment op text be the source text matched by assignment operator. Let op text be the sequence of Unicode code points associated with assignment op text in the following table. Assignment op text equals percent plus equals and equals. Let R be capital A P P L Y capital S T R I N G capital O R capital N U M E R I C capital B, I, N, A, R, Y, capital O, P, E, R, val, opt text, reval, perform, put value, ref, R, return R, assignment expression, left-hand side expression and equals assignment expression, little ref B, evaluation of left-hand side expression, little val B, get value, ref, little bool B to boolean, val, if bool is false, return val, if is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then a letter val B. Named evaluation of assignment expression with argument ref, else a letter of B. Evaluation of assignment expression B letter val B. Get value, ref, perform. Put value, ref, reval, return reval, assignment expression, left-hand side expression equals assignment expression, letter of B. Evaluation of left-hand side expression, little val B. Get value, ref, little bool B to boolean, val, if bool is true, return val, if is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then a letter val B. Named evaluation of assignment expression with argument ref 6. Else a letter of B. Evaluation of assignment expression B letter val B. Get value, ref, ECMA International 2024 283 7. Perform. Put value, ref, reval, return reval, assignment expression, left-hand side expression equals assignment expression, letter of B. Evaluation of left-hand side expression, little val B. Get value, ref, if val is neither undefined nor null, return val, if is anonymous function definition, assignment expression, is true and is identifier ref of left-hand side expression is true, then a letter val B. Named evaluation of assignment expression with argument ref, else a letter of B. Evaluation of assignment expression B letter val B. Get value, ref, perform. Put value, ref, reval, return reval, 3, 1, 5, 3, capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, opt text, reval, the abstract operation, capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, takes arguments val, an ECMAScript language value, opt text, comma %, plus, and, or, and reval, an ECMAScript language value, and returns either a normal completion containing either a string, a begint, or a number, or a throw completion. It performs the following steps when called. If opt text is plus, then a letter prim B. To primitive, val B letter prim B. To primitive, reval C if prim is a string or reprim is a string, then I let lstrb. To string, prim 2. Let rstrb. To string, reprim 3. Return the string concatenation of lstr and rstr. D set val till prim. E set reval to reprim. Note: at this point, it must be a numeric operation. Letter num b. To numeric, val. Letter num b. To numeric, reval. If type, num, is not type, renum. Throw a type error exception. If num is a big int, then, note when this expression occurs within strict mode code. It is a runtime error if ref in step 1d, 2 is an unresolvable reference. If it is, a reference error exception is thrown. Additionally, it is a runtime error if the ref in step 8, 7, 6 is a reference to a data property with the attribute value false, to an accessor property with the attribute value ABCD. Let if op text is return big int exponentiate num renum. If op text is comma return big int divide num renum. If op text is percent return big int remainder num renum. If op text is return big int unsigned right shift num renum. Operation be the abstract operation associated with op text and type num. In the following table, 84 ECMA International 2024 op text type num. Operation number exponentiate number multiply big int multiply number divide number remainder number add percent plus number big int number op text type num plus big int number big int number big int number big int comma number big int number big int number big int. Operation big int add number subtract big int subtract number left shift big int left shift number signed right shift big int signed right shift number and signed right shift number bitwise and big int bitwise and number bitwise or big int bitwise or number bitwise or big int bitwise or return operation num renum. Note 1 no hint is provided in the calls to primitive in steps 1a and 1b. All standard objects except dates handle the absence of a hint as if number were given. Dates handle the absence of a hint as if string were given. Exotic objects may handle the absence of a hint in some other manner. Note 2 step 1c differs from step 3 of the is less than algorithm by using the logical or operation instead of the logical and operation. 3, 1, 5, 4, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, capital E.
Okay, I'll be back in a second, but this Sound Blaster card, this is like the coolest
L, U,
like install I've ever seen. It's really impressive. Watch this.
G, capital O, R, capital N, U, M, E.
I should like turn off the other computer.
I, N, A, R, Y, capital E, takes arguments left operand, a pars.
I need to like turn off pixelization of this program. If I mirror the desktop, it'll mess up all the stupid windows I have open. So it's like there's still a filter going on, but I'll pick the less distracting one. If there is one, I think they're all just distracting. I'll just go with this one. It's not very distracting, but it's a fancy install program. And I wasted time burning this to a disk to find out that I can't even run it in Windows 11 because Windows they cut support when they went full 64-bit for like everything. So I got like a bunch of stuff that I can't even use now unless I use older OS and whatever. I think the sound's working. I can't hear anything. Whatever. I need to stop saying whatever. This might give me a blue screen, so blue screen of death. I'll like cancel the installation. Last time I fucked up Windows and had to like undo a bunch of stuff. Last time I had like I'm not gonna risk getting blue screen. I might just get a blue screen and restart. Is there a game on here? I need to stop getting distracting. I just said that wrong, whatever. It's amazing. I can run this really old game demo. I have both 2D and 3D support because that's awesome. They recommend using Direct 3D on the G. This is pretty funny that it is able to like get to this point, and it's loading up the prompt with a bunch of like modern info that didn't exist back in way back. And it's still, if this runs, that's pretty awesome. Or look at me, a blue screen. So I'm gonna pick a 3D, Direct 3D, whatever. They have a README file. That's cool. Oh, it's a website I should have opened with Chrome. Can I, where's README? I'll save it as HTML, then try to open it. Will Notepad not show me the path of this directory? Man. It already exists, that directory. I need to drop the bitrate on the stream because the streaming software is garbage. Where is the README file? This is a boring README file. Controls, I don't know. But will it run? Da-da-da. I don't know if it's running. Last time they had like a whole like animation that played. It's not playing now, so I'm just gonna stop. I don't think the game's gonna play. Can I run it as administrator? Only one copy can run at a time, but no copies are running, so oh, there it is right here. I don't think it's gonna run. That's cool. Well, that was disappointing. I'm gonna actually take a break now and get back to whatever the heck I was doing. It didn't even play the animation that I thought it would. Total waste time. And now the other program's gonna like start on startup when it restarts. I hope it doesn't give me a blue screen.
The abstract operation, capital E, V, A, L, U, A, T, E, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital E, takes arguments left operand, a parse node, optext, a sequence of Unicode code points, and right operand, a parse node, and returns either a normal completion containing either a string, a big int, or a number, or an abrupt completion. It performs the following steps when called. Let b. Evaluation of left operand. Let eval b. Get value. Ref. Let ref b. Evaluation of right operand. Let eval b. Get value. Ref. Return. Capital A, P, P, L, Y, capital S, T, R, I, N, G, capital O, R, capital N, U, M, E, R, I, C, capital B, I, N, A, R, Y, capital O, P, E, R, val, optext, reval. 3. 1.5. 5 Destructuring assignment supplemental syntax. In certain circumstances when processing an instance of the production assignment expression, left-hand side expression equals assignment expression. The interpretation of left-hand side expression is refined using the following grammar. Assignment pattern. Yield. Await. Object assignment pattern yield await. Array assignment pattern yield await. ECMA International 2024 285. Object assignment pattern. Yield. Await. Assignment dress property yield await. Assignment property list yield await. Assignment property list yield await. Assignment dress property yield await opt. Array assignment pattern. Yield. Await. Eligible assignment dressed element yield await opt. Assignment element list yield await. Assignment element list yield await. Eligible assignment dressed element yield await opt. Assignment dress property. Yield. Await. Dart. Destructuring assignment target yield await. Assignment property list. Yield await. Assignment property yield await. Assignment property list yield await. Assignment property yield await. Assignment element list. Yield await. Assignment elision element yield await. Assignment element list yield await. Assignment elision element yield await. Assignment elision element yield await. Elision ought assignment element yield await. Assignment property yield await. Identifier reference yield await. Initializer plus in yield await opt property name yield await. Assignment element yield await. Assignment element yield await. Destructuring assignment target yield await. Initializer plus in yield await opt assignment rest element yield await dot. Destructuring assignment target yield await. Destructuring assignment target yield await. Left-hand side expression yield await. 3, 1, 5, 5, 1 static semantics. Early errors. Assignment property. Identifier reference initializer opt. It is a syntax error if assignment target type of identifier reference is not simple. Assignment res property. Destructuring assignment target. It is a syntax error if destructuring assignment target is either an array literal or an object literal. Destructuring assignment target. Left-hand side expression. If left-hand side expression is either an object literal or an array literal, the following early error rules are applied. Left-hand side expression must cover an assignment T pattern. If left-hand side expression is neither an object literal nor an array literal, the following early error rule is applied. 86. Copyright sign. ECMA International 2024. It is a syntax error if assignment target type of left-hand side expression is not simple. 1.3.1.5.5. 2 runtime semantics. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T. Capital E V A L U A T. The syntax directed operation. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T. Capital E V A L U A T. Takes argument value, an ECMAScript language value, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Object assignment pattern. Perform. Require object coercible. Value. Return unused. Object assignment pattern. Assignment property list. Assignment property list. Perform. Require object coercible. Value. Perform. Capital P R O P E R T Y. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N. Of assignment property list with argument value. Return unused. Object assignment pattern. Assignment res property. Perform. Require object coercible. Value. Let excluded names be a new empty list. Return. Capital R E S T. Capital D E S T R U C T U R I N G. Capital A S S I G N M E N T. Capital E V A. Of assignment res property with arguments value and excluded names. Object assignment pattern. Assignment property list. Assignment res property. Perform. Require object coercible. Value. Let excluded names be. Capital P R O P E R T Y. Capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment property list with argument value return. Capital R E S T, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A, of assignment dress property with arguments value and excluded names. Array assignment pattern. Let iterator record B. Get iterator value sync return. Iterator close. Iterator record. Normal completion unused. Array assignment pattern. Elision. Let iterator record B. Get iterator value sync. Let result be completion. Iterator destructuring assignment evaluation of elision with argument iterator record. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Elision not assignment rest element. Let iterator record B. Get iterator value sync. If elision is present, then a let status be completion. Iterator destructuring assignment evaluation of elision with argument iterator record. B. If status is an abrupt completion, then I assert iterator record is true. 2. Return status. Let result be completion. Iterator destructuring assignment evaluation of assignment rest element with argument iterator record. ECMA International 2024 287. 4. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Assignment element list. Let iterator record B. Get iterator value sync. Let result be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If iterator record is false, return. Iterator close. Iterator record. Result. Return result. Array assignment pattern. Assignment element list. Elision not assignment rest element opt. Let iterator record B. Get iterator value sync. Let status be completion. Iterator destructuring assignment evaluation of assignment element list with argument iterator record. If status is an abrupt completion, then if iterator record is false, return. Iterator close. Iterator record. Status. B. Return status. If elision is present, then assert status to completion. Iterator destructuring assignment evaluation of elision with argument iterator record. B. If status is an abrupt completion, then I assert iterator record is true. 2. Return status. If assignment rest element is present, then assert status to completion. Iterator destructuring assignment evaluation of assignment rest element with argument iterator record. If iterator record is false, return. Iterator close. Iterator record. Status. Return status. 3. 1 5 5 3 Runtime semantics. Capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N. The syntax directed operation. Capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, takes argument value, an ECMAScript language value, and returns either a normal completion containing a list of property keys or an abrupt completion. It collects a list.
I'll get back to finding, replacing, whatever, or moving files out and stuff, I don't know, whatever.
Property list. Assignment property. Let property names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment property list with argument value. Let next names be capital P R O P E R T Y, capital D E S T R U C T U R I N G, capital A S S I G N M E N, of assignment property with argument value. Return the list concatenation of property names and next names. Assignment property identifier reference initializer opt. Let P be string value of identifier reference. Let LRF be resolve binding. P let V be jet value. P if initializer is present and V is undefined. Then if is anonymous function definition initializer is true. Then I set V to named evaluation of initializer with argument P be else I let default value be evaluation of initializer to set V to get value default value perform put value ref V return P 88 ECMA International 2024 assignment property name assignment element let name be evaluation of property name perform capital K E Y E D, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V, of assignment element with arguments value and name. Return name 3155 for runtime semantics. Capital R E S T, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A. The syntax directed operation, capital R E S T, capital D E S T R U C T U R I N G, capital A S S I G N M E N T, capital E V A, takes arguments value, an ECMAScript language value, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: assignment dress property, destructuring assignment target, let be evaluation of destructuring assignment target, capital L, addressed objb ordinary object create, %object prototype %perform, copy data properties, rest obj, value, excluded names, return, put value, ref, rest obj, 3155 runtime semantics, capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A S S I G N M E N. The syntax directed operation, capital I T E R A T O R, capital D E S T R U C T U R I N G, capital A, S, S, I, G, N, M, E, N, takes argument iterator record, an iterator record, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: assignment element list, assignment elision element, return, capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment elision element with argument iterator record, assignment element list, assignment element list, assignment elision element, perform, capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment element list with argument iterator record, return, capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment elision element with argument iterator record, assignment elision element, assignment element, return, capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment element with argument iterator record, assignment elision element, elision assignment element, perform, capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record, return, capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of assignment element with argument iterator record, elision. If iterator record is false, then a let next be completion, iterator step, iterator record. B if next is an abrupt completion, set iterator record to true, see return if abrupt. Next. D if next is false, set iterator record to true, return unused. Elision. Elision. Perform. Capital I, T, E, R, A, T, O, R, capital D, E, S, T, R, U, C, T, U, R, I, N, G, capital A, S, S, I, G, N, M, E, N, of elision with argument iterator record. If iterator record is false, then a let next be completion, iterator step, iterator record. B if next is an abrupt completion, set iterator record to true. ECMA International 2024 289. See return if abrupt. Next. D if next is false, set iterator record to true 3. Return unused. Assignment element. Destructuring assignment target initializer opt. If destructuring assignment target is neither an object literal nor an array literal, then let ref b. Evaluation of destructuring assignment target. Let value be undefined. If iterator record is false, then let next be. Iterator step value. Iterator record b. If next is not done, then I set value to next. If initializer is present and value is undefined, then if is anonymous function definition, initializer, is true and is identifier ref of destructuring assignment target is true, then I let vb. Named evaluation of initializer with argument ref b else I let default value be. Evaluation of initializer 2. Let vb. Get value. Default value else I let vb value. If destructuring assignment target is either an object literal or an array literal, then I let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target be return. Capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of nested assignment pattern with argument v return. Put value ref v assignment rest element. Destructuring assignment target. If destructuring assignment target is neither an object literal nor an array literal, then let ref b. Evaluation of destructuring assignment target. Let a be. Array create 0 let 0 repeat. While iterator record is false, let next be. Iterator step value. Iterator record b. If next is not done, then I perform. Create data property or throw a to string n next 2. Set n to n plus 1. If destructuring assignment target is neither an object literal nor an array literal, then a return. Put value ref a. Let nested assignment pattern be the assignment pattern that is covered by destructuring assignment target return. Capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of nested assignment pattern with argument A 3 1 5 5 6 runtime semantics capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V. The syntax directed operation capital K E Y E D capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V takes arguments value, an ECMAScript language value, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions. Assignment element. Destructuring assignment target initializer opt. If destructuring assignment target is neither an object literal nor an array literal, then let ref b. Evaluation of destructuring assignment target. Let vb. Jet. Value. Property name. If initializer is present and v is undefined, then 290. ECMA International 2024. Note left to right evaluation order is maintained by evaluating a destructuring assignment target that is not a destructuring pattern prior to accessing the iterator or evaluating the initializer. If is anonymous function definition, initializer, and is identifier ref of destructuring assignment target are both true, then I let RHS value be. Named evaluation of initializer with argument ref b else I let default value be. Evaluation of initializer 2. Let RHS value be get value, default value, else let RHS value be v. If the structuring assignment target is either an object literal or an array literal, then let assignment pattern be the assignment pattern that is covered by destructuring assignment target. Be return capital D E S T R U C T U R I N G capital A S S I G N M E N T capital E V A L U A T of assignment pattern with argument RHS value. Return put value ref RHS value 3.16 comma operator syntax expression in yield await assignment expression in yield await expression in yield await assignment expression in yield await 1316 1 runtime semantics evaluation expression assignment expression let ref be evaluation of expression perform get value ref let ref be evaluation of assignment express ion return get value ref for ECMAScript language statements and declarations syntax statement yield await return block statement yield await return variable statement yield await empty statement expression statement yield await if statement yield await return breakable statement yield await return continue statement yield await break statement yield await plus return statement yield await with statement yield await return labeled statement yield await return throw statement yield await try statement yield await return debugger statement note get value must be called even though its value is not used because it may have observable side effects. ECMA International 2024 291 declaration yield await hoistable declaration yield await default class declaration yield await default lexical declaration plus in yield await hoistable declaration yield await default function declaration yield await default generator declaration yield await default async function declaration yield await default async generator declaration yield await default breakable statement yield await return iteration statement yield await return switch statement yield await return 4.1 statement semantics 4.1 runtime semantics evaluation hoistable declaration generator declaration async function declaration async generator declaration return empty hoistable declaration function declaration return evaluation of function declaration breakable statement iteration statement switch statement let new label set be a new empty list return labeled evaluation of this breakable statement with argument new label set 4.2 block syntax block statement yield await return block yield await return block yield await return statement list yield await return opt statement list yield await return statement list item yield await return statement list yield await return statement list item yield await return statement list item yield await return statement yield await return declaration yield await 92 ECMA International 2024 142 1 static semantics early errors block statement list it is a syntax error if the lexically declared names of statement list contains any duplicate entries. It is a syntax error if any element of the lexically declared names of statement list also occurs in the are declared names of statement list 4.2 runtime semantics evaluation block return empty block statement list let old env be the running execution context's lexical environment let block env be new declarative environment old env perform block declaration instantiation statement list block env set the running execution context's lexical environment to block env let block value be completion Evaluation of statement list. Set the running execution context cell. Executable environment to env. Return block value. Statement list. Statement list item. Let SL be. Evaluation of statement list. Let S be completion. Evaluation of statement list item. Return. Update empty. S. SL. 4. 2. 3 block declaration instantiation. Code. ENV. The abstract operation block declaration instantiation takes arguments code, a parse node, and ENV, a declarative environment record, and returns unused code is the parse node corresponding to the body of the block. ENV is the environment record in which bindings are to be created. It performs the following steps when called. Let declarations be the lexically scoped declarations of code. Let private ENV be the running execution context's private environment. For each element D of declarations, do a for each element DN of the bound names of D. Do ECMA International 2024 293. Note 1. No matter how control leaves the block, the lexical environment is always restored to its former state. Note 2. The value of a statement list is the value of the last value producing item in the statement list. For example, the following calls to the eval function all return the value 1 eval 1 eval 1 eval 1 var a. Note when a block or case block is evaluated, a new declarative environment record is created and bindings for each block scoped variable, constant, function, or class declared in the block are instantiated in the environment record. If this constant declaration of D is true, then perform env create immutable binding. Dn, true 2. Else perform env create mutable binding. Dn, false. Note, the step is replaced in section B. 3, 2, 6. B if D is either a function declaration, a generator declaration, an async function declaration, or an async generator declaration, then I let fn be the sole element of the bound names of D. 2. Let fo be instantiate function object of D with arguments env and private env. 3. Perform env initialize binding, fn, fo. Note, the step is replaced in section B. 3, 2, 6. Return unused. 4.3 declarations in the variable statement. 4, 3, 1. Syntax. Lexical declaration. In. Yield. Await. Let or const binding list and yield await. Let or const. Let const binding list. In. Yield. Await. Lexical binding in yield await. Binding list and yield await. Lexical binding in yield await. Lexical binding. In. Yield. Await. Binding identifier yield await. Initializer in yield await opt binding pattern yield await. Initializer in yield await. 4, 3, 1. 1 static semantics. Early errors. Lexical declaration. Let or const binding list. It is a syntax error if the bound names of binding list contains let. It is a syntax error if the bound names of binding list contains any duplicate entries. Lexical binding. Binding identifier initializer opt. It is a syntax error if initializer is not present and is constant declaration of the lexical declaration containing this lexical binding is true. 94. ECMA International 2024. Let and const declarations. Let and const declarations define variables that are scoped to the running execution contexts. Note, lexical environment. The variables are created when their containing environment record is instantiated but may not be accessed in any way until the variable's lexical binding is evaluated. A variable defined by a lexical binding with an initializer is assigned the value of its initializer's assignment expression when the lexical binding is evaluated, not when the variable is created. If a lexical binding in a let declaration does not have an initializer, the variable is assigned the value undefined when the lexical binding is evaluated. 1, 4, 3, 1. 2 runtime semantics. Evaluation. Lexical declaration. Let or const binding list. Perform. Evaluation of binding list. Return empty. Binding list. Binding list. Lexical binding. Perform. Evaluation of binding list. Return. Evaluation of lexical binding. Lexical binding. Binding identifier. Let LHS be. Resolve binding. String value of binding identifier. Perform. Initialize reference binding. LHS. Undefined. Return empty. Lexical binding. Binding identifier initializer. Let binding id be string value of binding identifier. Let LHS be resolve binding. Binding id. If is anonymous function definition initializer is true, then a let value be named evaluation of initializer with argument binding id. Else a let RHS be evaluation of initializer be let value be get value RHS perform initialize reference binding LHS value return empty lexical binding binding pattern initializer let RHS be evaluation of initializer let value be get value RHS let env be the running execution context's lexical environment return binding initialization of binding pattern with arguments value and env 4 3 2 variable statement syntax variable statement yield await our variable declaration list plus in yield await. A static semantics rule ensures that this form of lexical binding never occurs in a const. Note declaration. A var statement declares variables that are scoped to the running execution contexts. Note variable environment. Our variables are created when their containing environment record is instantiated and are initialized to undefined when created. Within the scope of any variable environment, a common binding identifier may appear in more than one variable declaration, but those declarations collectively define only one variable. A variable defined by a variable declaration with an initializer is assigned the value of its initializer's assignment expression when the variable declaration is executed, not when the variable is created. ECMA International 2024 295. Variable declaration list. In yield await variable declaration in yield await variable declaration list in yield await variable declaration in yield await variable declaration in yield await binding identifier yield await initializer in yield await opt binding pattern yield await initializer in yield await 4 3 2 1 runtime semantics evaluation variable statement var variable declaration list perform evaluation of variable declaration list return empty variable declaration list variable declaration list variable declaration perform evaluation of variable declaration list return evaluation of variable declaration binding identifier 1 return empty variable declaration binding identifier initializer. Let binding id be string value of binding identifier. Let LHS be resolve binding. Binding id. If is anonymous function definition initializer is true, then a let value be named evaluation of initializer with argument binding id. Else a let RHS be evaluation of initializer be let value be get value RHS perform put value LHS value return empty variable declaration binding pattern initializer let RHS be evaluation of initializer let eval be get value RHS return binding initialization of binding pattern with arguments reval and undefined 4 3 3 destructuring binding patterns syntax binding pattern yield await object binding pattern yield await array binding pattern yield await. Note if a variable declaration is nested within a with statement and the binding identifier in the variable declaration is the same as the property name of the binding object of the with statement's object environment record. Then step 5 will assign value to the property instead of assigning to the variable environment binding of the identifier. 96. ECMA International 2024. Object binding pattern. Yield await binding rest property yield await binding property list yield await binding property list yield await binding rest property yield await opt array binding pattern yield await eligenort binding rest element yield await opt binding element list yield await binding element list yield await eligenort binding rest element yield await opt binding rest property yield await dart binding identifier yield await binding property list yield await binding property yield await binding property list yield await binding property yield await binding element list yield await binding elision element yield await binding element list yield await Binding elision element yield await. Binding elision element yield await. Elision not binding element yield await. Binding property yield await. Single name binding yield await. Property name yield await. Binding element yield await. Binding element yield await. Single name binding yield await. Binding pattern yield await. Initializer plus in yield await opt. Single name binding yield await. Binding identifier yield await. Initializer plus in yield await opt. Binding rest element yield await dart. Binding identifier yield await. Binding pattern yield await. 4, 3, 3, 1 runtime semantics. Property binding initialization. The syntax-directed operation property binding initialization takes arguments value, an ECMAScript language value, and environment record or undefined, and returns either a normal completion contain in a list of property keys or an abrupt completion. It collects a list of all bound property names. It is defined piecewise over the following productions: binding property list, binding property list, binding property. Let bound names be. Property binding initialization of binding property list with arguments value and environment. Let next names be. Property binding initialization of binding property with arguments value and environment. Return the list concatenation of bound names and next names. ECMA International 2024 297. Binding property. Single name binding. Let name be the sole element of the bound names of single name binding. Perform. Keep binding initialization of single name binding with arguments value, environment, and name. Return name. Binding property. Property name. Binding element. Let P be. Evaluation of property name. Perform. Keep binding initialization of binding element with arguments value, environment, and P. Return P. 4, 3, 3, 2 runtime semantics. Rest binding initialization. The syntax-directed operation rest binding initialization takes arguments value, an ECMAScript language value, environment and environment record or undefined, and excluded names, a list of property keys, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding rest property, binding identifier. Let LHS be. Resolve binding. String value of binding identifier. Environment. Let rest obj be ordinary object create. %object prototype %perform. Copy data properties. Rest obj. Value. Excluded names. If environment is undefined, return. Put value. LHS. Rest obj. Return. Initialize reference binding. LHS. Rest obj. 4, 3, 3, 3 runtime semantics. Keep binding initialization. The syntax-directed operation keep binding initialization takes arguments value, an ECMAScript language value, environment and environment record or undefined, and property name, a property key, and returns either a normal completion containing unused or an abrupt completion. It is defined piecewise over the following productions: binding element, binding pattern initializer opt. Let VB. Jet. Value. Property name. If initializer is present and v is undefined, then a let default value be. Evaluation of initializer be set v2. Get value. Default value. Return. Binding initialization of binding pattern with arguments v and environment. Single name binding. Binding identifier initializer opt. Let binding id be string value of binding identifier. Let LHS be. Resolve binding. Binding id. Environment. Let VB. Jet. Value. Property name. If initializer is present and v is undefined, then if is anonymous function definition, initializer, is true, then I set v2. Named evaluation of initializer with argument binding id be else. Note when undefined is passed for environment, it indicates that a put value operation should be used to assign the initialization value. This is the case for formal parameter lists of non-strict functions. In that case, the formal parameter bindings are pre-initialized in order to deal with the possibility of multiple parameters with the same name. 98. ECMA International 2024. I2. Let default value be. Evaluation of initializer. Semvia2. Get value. Default value. 5. If environment is undefined, return. put value, LHS, v, return. Initialize reference binding, LHS, v, 4.4 empty statement syntax, empty statement, 4, 1 runtime semantics, evaluation, empty statement, 1. Return empty, 4.5 expression statement syntax, expression statement, yield, await, look ahead, function, async, no line terminator here, function, class, let, expression, plus in yield await. Note an expression statement cannot start with a u plus 007b, left curly bracket, because that might make it ambiguous with a block. An expression statement cannot start with the function or class keywords because that would make it ambiguous with a function declaration, a generator declaration, or a class declaration. An expression statement cannot start with a async function because that would make it ambiguous with an async function declaration or a async generator declaration. An expression statement cannot start with the two-token sequence let, because that would make it ambiguous with a let lexical declaration whose first lexical binding was an array binding pattern. 4, 5, 1 runtime semantics, evaluation, expression statement, expression, let x per f be. Evaluation of expression, return, get value, x per f, 4.6 thief statement syntax, if statement, yield, await, return, if, expression, plus in yield await, statement yield await return, else, statement yield await return, if, expression, plus in yield await, statement yield await return, look ahead else, the look ahead restriction, look ahead else, resolves the classic dangling else problem in the note usual way. That is, when the choice of associated if is otherwise ambiguous, the else is associated with the nearest, innermost, of the candidate ifs. ECMA International 2024 299. Volume 1 Fundamental Algorithms. Volume 1 Fundamental Algorithms, The Art of Computer Programming 3rd edition. Reading, Massachusetts. Harlow, England. Menlo Park, California. Berkeley, California. Don Mills, Ontario. Sydney, Bonn, Amsterdam, Tokyo, Mexico City. X is a trademark of the American Mathematical Society. Metafont is a trademark of Addison Wesley. Library of Congress. Cataloging and publication data. Knuth, Donald Irvin, 1938. The Art of Computer Programming, Fundamental Algorithms. I. Donald Irvin Knuth, 3rd ed. XX. 650 page 24 centimeters. Includes bibliographical references and index. ISBN 02-189-683-4. Electronic Digital Computers. Programming 2. Computer Algorithms. I. Title QS 76.6K64 1997 5.1 DC 21 7 2147 SIP. Internet page http www.cs faculty stanford edu. Knuth.html contains current information about this book and related books. Copyright sign 1997 by Addison Wesley Longman. All rights reserved. No part of this publication may be reproduced, stored in a retrieval system, or transmitted, in any form, or by any means, electronic, mechanical, photocopying, recording, or otherwise, without the prior consent of the publisher. Printed in the United States of America.
I think this is like copyrighted, so I just won't play it. I'll just do something else. Man. I'll just have it like read publicly accessible documentation.
TITAR. The 8080 is a complete 8-bit parallel central processor unit, CPU, for use in general-purpose digital computer-sized TEMs. It is fabricated on a single LSI chip, see Figure 2.1, using Intel's N-Chan Silicon Gate MOS process. The 8080 transfers data and internal state information via an 8-bit bidirectional 3-state data bus, DQD7. Memory and peripheral device addresses are transmitted over a separate 16-bit 3-state address bus, A0 a 15. 6 timing and control outputs, sync, DBIN, WA, T, WR, HLDA and INT, M and 8 from the 8080, while 4 control inputs, ready, hold, anti and reset, 4 power inputs, plus 12V, plus 5V, MIT heady HLDA, F, 5 volt, and GND, and 2 clock inputs, 0 1 incepted by the 8080, GNDOD, OD, O, 0 10 minus 5V 011 reset 012, 2, RAC, O, AOA, 5, minus 0, AGO, AOA, a 50A, O plus HVOA 2, O, I, OA, minus 0, wait radio number 1, RU dot SPRT, comma SL, equals DPO and TETO, 09, hold 013 NTO 1415 int 016 DBIN 017 WRO 18 SYNCO 19 W plus 5 VO 20, dot, and A. 3AA capital J Timi Bapwa dot duomameter dot R dot AMYWI figure 2.1 8080 photomicrograph with pin designations. BTI UTUC MNA Dart. -1. 080 Architecture of the 8080 CPU. The 8080 CPU consists of the following functional units: register array and address logic, arithmetic and logic unit, ALU, instruction register and control section bidirectional, 3-state data bus buffer. Figure 2.2 illustrates the functional blocks within the 8080 CPU. Registers. The register section consists of a static RAM array, organized into 6 16-bit registers. Program counter, PC, stack pointer, SP, 6 8-bit general-purpose registers arranged in pairs, referred to as B, C, D, E, and H, L. A temporary register pair called W, Z. The program counter maintains the memory address of the current program instruction and is incremented automatically during every instruction fetch. The stack pointer maintains the address of the next available stack location in memory. The stack pointer can be initialized to use any portion of read-write memory as a stack. The stack pointer is decremented when data is pushed onto the stack and incremented when data is popped off the stack. That is, the stack grows downward. The 6 general-purpose registers can be used either as single registers, 8-bit, or as register pairs, 16-bit. The temporary register pair, W, Z, is not program addressable and is only used for the internal execution of instructions. 8-bit data bytes can be transferred between the internal bus and the register array via the register select multiplexer. 16-bit transfers can proceed between the register array and the address latch or the incrementer-decrementer circuit. The address latch receives data from any of the 3 register pairs and drives the 16 address output buffers, A0 to 15, as well as the incrementer-decrementer circuit. The incrementer-decrementer circuit receives data from the address latch and sends it to the register array. The 16-bit data can be incremented or decremented or simply transferred between registers. Data bus interrupt hold wait. Write control sync clocks. int hold wait sync. To reset ACK ready. Figure 2.2. 8080 CPU functional block diagram. Address bus. 2. DDBI directional data bus. Arithmetic and logic unit. ALU. The ALU contains the following registers: an 8-bit accumulator, an 8-bit temporary accumulator, a CT, a 5-bit flag register, 0, carry, sign, parity and auxiliary carry. The processor cycle. An instruction cycle is defined as the time required to fetch and execute an instruction. During the fetch, a selected instruction 1, 2 or 3 bytes is extracted from memory and deposited in the CPU's instruction register. During the execution phase, the instruction is decoded and translated into specific processing activities. Every instruction cycle consists of 1, 2, 3, 4 or 5 machine cycles. A machine cycle is required each time the CPU accesses memory or an I/O port. The fetch portion of an instruction cycle requires 1 machine cycle for each byte to be fetched. The duration of the execution portion of the instruction cycle depends on the kind of instruction that has been fetched. Some instructions do not require any machine cycles other than those necessary to fetch the instruction. Other instructions, however, require additional machine cycles to write or read data from memory or I/O devices. The DAD instruction is an exception in that it requires 2 additional machine cycles to complete an internal register pair add. See Chapter 4. Each machine cycle consists of 3, 4 or 5 states. A state is the smallest unit of processing activity and is defined as the interval between 2 successive positive going transitions of the 0-1 driven clock pulse. The 8080 is driven by a 2-phase clock oscillator. All processing activities are referred to the period of this clock. The 2 non-overlapping clock pulses, labeled 0-1 and 0-2, are furnished by external circuitry. It is the 0-1 clock pulse which divides each machine cycle into states. Timing logic within the 8080 uses the clock inputs to produce a sync pulse, which identifies the beginning of every machine cycle. The sync pulse is triggered by the low to high transition of 0-2, as shown in Figure 2.3. First state of every machine cycle, an 8-bit temporary register, TMP, arithmetic, logical and rotate operations are performed in the ALU. The ALU is fed by the temporary register, TMP, and the temporary accumulator, a CT, and carry flip-flop. The result of the operation can be transferred to the internal bus or to the accumulator. The EPILOGUE also feeds the flag register. The temporary register, TMP, receives information from the internal bus and can send all or portions of it to the EPILOGUE. The flag register and the internal bus, the accumulator, SCC, can be loaded from the EPILOGUE and the internal bus and can transfer data to the temporary accumulator, SCT, and the internal bus. The contents of the accumulator, ACC, and the auxiliary carry flip-flop can be tested for decimal correction during the execution of the DAA instruction. See Chapter 4, Instruction Register and Contro. During an instruction fetch, the first byte of an instruction, containing the OP code, is transferred from the internal bus to the 8-bit instruction register. The contents of the instruction register are, in turn, available to the instruction decoder. The output of the decoder, combined with various timing signals, provides the control signals for the register array, ALU and data buffer blocks. In addition, the outputs from the instruction decoder and external control signals feed the timing and state control section, which generates the state and cycle timing signals. Data bus buffer. This 8-bit bidirectional 3-state buffer is used to isolate the CPU's internal bus from the external data bus, do through die. In the output mode, the internal bus content is loaded into an 8-bit latch that, in turn, drives the data bus output buffers. The output buffers are switched off during input or non-transfer operations. During the input mode, data from the external data bus is transferred to the internal bus. The internal bus is pre-charged at the beginning of each internal state, except for the transfer state, T3, described later in this chapter. M-sync \-3. Sync does not occur in the second and third machine cycles of a DAD instruction, since these machine cycles are used for an internal register pair ADD. Figure 2.3.01.02 in sync timing. There are 3 exceptions to the defined duration of a state. They are the wait state, the hold, HLDA, state, and the halt, HLTA, state, described later in this chapter. Because the wait, the HLDA, and the HLTA states depend upon external events, they are by their nature of indeterminate length. Even these exceptional states, however, must be synchronized with the pulses of the driving clock. Thus, the duration of all states are integral multiples of the clock period. To summarize then, each clock period marks a state, 3 to 5 states constitute a machine cycle, and 1 to 5 machine cycles comprise an instruction site. A full instruction cycle requires anywhere from 4 to 18 states for its completion, depending on the kind of instruction involved. Machine site identification. With the exception of the DAD instruction, there is just one consideration that determines how many machine cycles are required in any given instruction cycle: the number of times that the processor must reference a memory address or an addressable peripheral device in order to fetch and execute the instruction. Like many processors, the 8080 is so constructed that it can transmit only one address per machine cycle. Thus, if the fetch and execution of an instruction requires 2 memory references, then the instruction cycle associated with that instruction consists of 2 machine cycles. If 5 such references are called for, then the instruction cycle contains 5 machine cycles. Every instruction cycle has at least one reference to memory, during which the instruction is fetched. An instruction cycle must always have a fetch, even if the execution of the instruction requires no further references to memory. The first machine cycle in every instruction cycle is therefore a fetch. Beyond that, there are no fast rules. It depends on the kind of instruction that is fetched. Consider some examples. The add register, ADDR instruction is an instruction that requires only a single machine cycle, fetch, for its completion. In this 1-byte instruction, the contents of one of the CPU's 6 general-purpose registers is added to the existing contents of the accumulator. Since all the information necessary to execute the command is contained in the 8 bits of the instruction code, only one memory reference is necessary. 3 states are used to extract the instruction from memory, and 1 additional state is used to accomplish the desired addition. The entire instruction cycle thus requires only 1 machine cycle that consists of 4 states, or 4 periods of the externa. clock. Suppose now, however, that we wish to add the contents of a specific memory location to the existing contents of the accumulator, ADDM. Although this is quite similar in principle to the example just cited, several additional steps will be used. An extra machine cycle will be used. In order to address the desired memory location, the actual sequence is as follows. First, the processor extracts from memory the 1-byte instruction word addressed by its program counter. This takes 3 states. The 8-bit instruction word obtained during the fetch machine cycle is deposited in the CPU's instruction register and used to direct activities during the remainder of the instruction cycle. Next, the processor sends out, as an address, the contents of its H and L registers. The 8-bit data word returned during the semi-MORYAD machine cycle is placed in a temporary register inside the 8080 CPU. By now 3 more clock periods, states, have elapsed. In the 7th and final state, the contents of the temporary register are added to those of the accumulator. 2 machine cycles, consisting of 7 states in all, complete the ADDM instruction cycle. At the opposite extreme is the Save H and L registers, SHLD instruction, which requires 5 machine cycles. During an SHLD instruction cycle, the contents of the processor's H and L registers are deposited in 2 sequentially adjacent memory locations. The destination is indicated by 2 address bytes which are stored in the 2 memory locations immediately following the operation code byte. The following sequence of events occurs. 1. A fetch machine cycle, consisting of 4 states. During the first 3 states of this machine cycle, the processor fetches the instruction indicated by its program counter. The program counter is then incremented. The 4th state is used for internal instruction decoding. 2. A memory read machine cycle, consisting of 3 states. During this machine cycle, the byte indicated by the program counter is read from memory and placed in the processor's Z register. The program counter is incremented again. 3. Another memory read machine cycle, consisting of 3 states, in which the byte indicated by the processor's program counter is read from memory and placed in the W register. The program counter is incremented, in anticipation of the next instruction fetch. 4. A memory WRT to machine cycle, of 3 states, in which the contents of the L register are transferred to the memory location pointed to by the present contents of the W and Z registers. The state following the transfer is used to increment the W Z register pair so that it indicates the next memory location to receive data. 5. A memory WRT to machine cycle, of 3 states, in which the contents of the H register are transferred to the new memory location pointed to by the W Z register pair. In summary, the SHLD instruction cycle contains 5 machine cycles and takes 16 states to execute. Most instructions fall somewhere between the extremes typified by the ADDR and the SHLD instructions. The input, INP, and the output, out instructions, for example, require 3 machine cycles, a fetch, to obtain the instruction, a memory read, to obtain the address of the object peripherate, and an input or an output machine cycle to complete the transfer. -4. White no one instruction cycle will consist of more than 5 machine cycles. The following 10 different types of machine cycles may occur within an instruction cycle. Basic transition sequence. In the present discussion, we are concerned only with the basic sequence and with the ready function. The hold and interrupt functions will be discussed later. The 8080 CPU does not directly indicate its internal state by transmitting a state control output during each state. Instead, the 8080 supplies direct control output, int, HLDA, dbin, WR and wait, for use by external circuitry. Recall that the 8080 passes through at least 3 states in every machine cycle, with each state defined by successive low to high transitions of the 0-1 clock. Figure 2.5 shows the timing relationships in a typical fetch machine cycle. Events that occur in each state are referenced to transitions of the 0 and 0-2 clock pulses. The sync signal identifies the first state, T, in every machine cycle. As shown in Figure 2.5, the SYNC signal is related to the leading edge of the 0-2 clock. There is a delay, TPC between the low to high transition of 0-2 and the positive going edge of the sync pulse. There also is a corresponding delay, also TP, between the next 0-2 pulse and the falling edge of the sync signal. Status information is displayed on DQD7 during the same 0-2 to 0-2 interval. Switching of the status signals is likewise controlled by 0-2. The rising edge of 0-2 during T also loads the processor's address lines, a QA15. These lines become stable within a brief delay, TP, of the 0-2 clocking pulse, and they remain stable until the first 0-2 pulse after state T3. This gives the processor ample time to read the data returned from memory. Once the processor has sent an address to memory, there is an opportunity for the memory to request a wait. This it does by pulling the processor's RAADY line low, prior to the ready setup interval, TRG, which occurs during the 0-2 pulse within state T2 or TW. As long as the RAADY line remains low, the processor will idle, giving the memory time to respond to the addressed data request. Refer to Figure 2.5. The processor responds to a wait request by entering an alternative state, TW, at the end of T2, rather than proceeding directly to the T3 state. Entry into the TW state is indicated by a wait signal from the processor, acknowledging the memory's request. A low to high transition on the wait line is triggered by the rising edge of the 0 clock and occurs within a brief delay, TPC, of the actual entry into the TW state. A wait period may be of indefinite duration. The processor remains in the waiting condition until its RAADY line again goes high. A ready indication must precede the falling edge of the 0-2 clock by a specified interval, TRG, in order to guarantee an exit from the T state. The cycle may then proceed, beginning with the rising edge of the next 0-1 clock. A wait interval will therefore consist of an integral number of TV states and will always be a multiple of the clock period. Fetch, M1, memory write, stack write, input, 1, 2, 3, 4, 5, 6, 7, 8, interrupt, 9, halt, output, 10, halt, interrupt. The machine cycles that actually do occur in a particular instruction cycle depend upon the kind of instruction, with the overriding stipulation that the first machine cycle in any instruction cycle is always a fetch. The processor identifies the machine cycle in progress by transmitting an 8-bit status word during the first state of every machine cycle. Updated status information is presented on the 8080's data lines, D0, D7, during the SYNC interval. This data should be saved in latches and used to develop control signals for external circuitry. Table 2.1 shows how the positive true status information is distributed on the processor's data bus. Status signals are provided principally for the control of external circuitry. Simplicity of interface, rather than machine cycle identification, dictates the logical definition of individual status bits. You will therefore observe that certain processor machine cycles are uniquely identified by a single status bit, but that others are not. The M status bit, DG, for example, unambiguously identifies a fetch machine.
The computer's failing on me, it's great.
Indicated by the coincidence of stack and met VTR signals. Machine cycle identification data is also valuable in the test. Table 2.1 lists the status bit outputs for each type of machine cycle. State transition sequence. Every machine cycle within an instruction cycle consists of 3 to 5 active states, referred to as T, T2, T3, T4, T5 or TW. The actual number of states depends upon the instruction being executed.
Windows sucks.
The state transition diagram in Figure 2.4 shows how the 8080 proceeds from state to state in the course of a machine cycle. The diagram also shows how the ready, hold, and
Why can't I hear?
And how the conditions on these lines may
Testing.
5. Instructions for the 8080 require from 1 to 5 machine cycles for complete execution.
Testing.
And 80 sends out 8-bit of status info.
Let's just work. Anything, will anything just work? Anything at all.
Symbols, inter, WO, stack, bit, D0, definition, acknowledge signal for interrupt request.
Testing, why can't I hear this?
Is active. HLTAD3 indicates that the operation in the current machine cycle will be a write memory or output function. WO equals 0.0. Otherwise, a read memory or input operation will be executed. Indicates that the address bus holds the pushdown stack address for the address of an output device, and the data bus will contain the output data when WR is active. Provides a signal to indicate that the CPU is in the fetch cycle for the first byte of an instruction. Indicates that the address bus contains the address of an input device and the input data should be placed on the data bus when DBIN is active. Designates that the data bus will be used for memory read data. Out MINP ME.
Nothing is.
3. D type of matching cycle into 00000000101 D1W I10101011 D2
Test. Oh, there it goes. Finally.
00 D3 HLTA 000.
So like, I guess Windows File Explorer. You know, you like click folder here. This thing's like totally unstable. It's a piece of shit. I have to like restart again. Oh, this is so stupid. I got this update security, whatever. Well, it said update security. Maybe they should like update the file system of all things on Windows before like they created the cure and the virus on Windows. They don't give a shit about security. Just Windows this is so annoying. Restart again.
The processor may either transmit or receive data, depending on whether an output or an input operation is involved. Figure 2.6 illustrates the timing that is characteristic of a data input operation. As shown, the low to high transition of 0 to during T2 clears status information from the processor's data lines, preparing these lines for the receipt of incoming data. The data presented to the processor must have stabilized prior to both the 0 data setup interval DS1L3T precedes the falling edge of the 0 pulse defining state T3, and the 02 data setup interval TQG2 that precedes the rising edge of 02 and state T3. This same data must remain stable during the data hold interval TDH. THST occurs following the rising edge of the 02 pulse. Data placed on these lines by memory or by other external devices will be sampled during T3. During the input of data to the processor, the 8080 generates a DBIN signal which should be used externally to enable the transfer. Machine cycles in which DBIN is available include fetch, memory read, stack read, and interrupt. DBIN is initiated by the rising edge of 02 during state T2 and terminated by the corresponding edge of 02 during T3. Any TW phases intervening between T2 and T3 will therefore extend.
I have a feeling that the computer might not restart. I need to make like I don't know, I'm just gonna back stuff up just in case Windows is fucked, because it really crashed. There's like corrupt files. It's just great.
Page 26, Figure 2.6 input instruction site. Note: at refer to status word chart on page 26, Figure 2.7. OUTP instruction site, -9, data, output delay interval, TDD, following the 02 clock's leading edge. Data on the bus remains stable throughout the remainder of the machine cycle. until replaced by updated status information in the subsequent T state. Observe that a ready signal is necessary for completion of an output machine cycle. Unless such an indication is present, the processor enters the TW state.
I need to find a bigger drive to like back stuff up onto.
Hi, the 8080 CPU generates a WR output for the synchronization of external transfers during those machine cycles in which the processor outputs data. These include memory write, stack write, and output. The negative going leading edge of WR is referenced to TH, rising edge of the first 0 clock pulse following T2, and occurs within a brief delay, TPC, of that event. WR remains low until retriggered by the leading edge of 0 during the state following T3. Note that any T states intervening between T2 and T3 of the output machine cycle will necessarily extend WR, in much the same way that TBN is affected during data input operations. All processor machine cycles consist of at least 3 states, T, T2, and T3 as just described. If the processor has to wait for a response from the peripheral or memory with which it is communicating, then the machine cycle may also contain one or more TW states. During the 3 basic states, data is transferred to or from the processor. After the T3 state, however, it becomes difficult to generalize. T4 and T5 states are available if the execution of a particular instruction requires them, but not all machine cycles make use of these states. It depends upon the kind of instruction being executed and on the particular machine cycle within the instruction cycle. The processor will terminate any machine cycle as soon as its processing activities are completed, rather than proceeding through the T4 and T5 states every time. Thus, the 8080 may exit a machine cycle following the T3, the T4, or the T5 state and proceed directly to the T state of the next machine cycle, state T1, T2, TW optional, T3, T4, T5. Optional, associated ACTVTES. A memory address or I/O device number is placed on the address bus. F15.0. Status information is placed on data bus. D7.0. The CPU samples the ready and hold inputs and checks for halt instruction. Processor enters wait state if ready is low or if halt instruction has been executed. An instruction byte, fetch machine cycle, data byte, memory read, stack read, or interrupt instruction interrupt machine cycle, is input to the CPU from the data bus, or a data byte, memory write, stack write or output machine cycle, is output onto the data bus. States T4 and T5 are available if the execution of a particular instruction requires them. If not, the CPU may skip one or both of them. T4 and T5 are only used for internal processor operations. TB22. State definitions. -10 interrupt sequences. The 8080 has the built-in capacity to handle external interrupt requests. A peripheral device can initiate an interrupt simply by driving the processor's interrupt INT line high. The interrupt INT input is asynchronous, and a request may therefore originate at any time during any instruction cycle. Internal logic reclocks the external request, so that a proper correspondence with the driving clock is established. As Figure 2.8 shows, an interrupt request, INT, arriving during the time that the interrupt enable line, int, is high, acts in coincidence with the 02 clock to set the internal interrupt latch. This event takes place during the last state of the instruction cycle in which the request occurs, TH, thus ensuring that any instruction in progress is completed before the interrupt can be processed. The interrupt machine cycle which follows the arrival of an enabled interrupt request resembles an ordinary fetch machine cycle in most respects. The IV1 status bit is transmitted as usual during the sync interval. It is accompanied, however, by an interstatus bit, do, which acknowledges the external request. The contents of the program counter are latched onto the CPU's address lines during T, but the counter itself is not incremented during the interrupt machine cycle, as it otherwise would be. In this way, the pre-interrupt status of the program counter is preserved, so that data in the counter may be restored by the interrupted program after the interrupt request has been processed. The interrupt cycle is otherwise indistinguishable from an ordinary fetch machine cycle. The processor itself takes no further special action. It is the responsibility of the peripheral logic to see that an 8-bit interrupt instruction is jammed onto the processor's data bus during state T3. In a typical system, this means that the data in bus from memory must be temporarily disconnected from the processor's main data bus, so that the interrupting device can command the main bus without interference. The 8080's instruction set provides a special 1-byte call which facilitates the processing of interrupts. The ordinary program cat takes 3 bytes. This is the restart instruction, RST. A variable 3-bit field embedded in the 8-bit field of the RST enables the interrupting device to direct a call to one of 8 fixed memory locations. The decimal addresses of these dedicated locations are 0, 8, 16, 24.
I'm just gonna restart and hope for the best.
Any of these addresses may be used to store the first instruction, S, of a routine designed to service the requirements of an interrupting device. Since the RST is a call, completion of the instruction also stores the old program counter contents on the stack. Figure 2.8 interrupt timing, -11, figure operation, read mode, figure operation, write mode, MN 213 is less than 14, T5, GIA NNTL, exclamation point 150K NNN D7.0, hold request, hold FF internal, -9. HOLD, it, hold request, hold ready, hold FF internal, -10. HOLD, capital J, sys attached electrical characteristics, and T5 operation can be done internally. PL5FL.FL, J, JLJ, J.
The hard drive I'm using, it's like a little quirky. I should have just used the Samsung for the main drive.
On the processor, an external.
It's like not booting, it's really slow, it's great.
To a request of this kind by toting its address to other devices sharing the buses. At the same time,
I think it's working.
acknowledged hold. The address and data buses are under control of the peripheral which originated the.
Okay, good. I'd be really, really pissed if like everything's effed up.
Synchronized internally. A hold signal must be stable prior to the hold setup interval, THs that precedes the rising edge of 02. Figures 2.9 and 2.10 illustrate the timing involved in hold operations. Note the delay between the asynchronous hold request and the reclocked hold. As shown in the diagram, a coincidence of the ready, the hold, and the 02 clock sets the internal hold latch. Setting the latch enables the subsequent rising edge of the 0 clock pulse to trigger the HLDA output. Acknowledgement of the hold request precedes slightly the actual floating of the processor's address and data lines. The processor acknowledges a hold at the beginning of T3, if a read or an input machine cycle is in progress. See Figure 2.9. Otherwise, acknowledgement is deferred until the beginning of the state following T3. See Figure 2.10. In both cases, however, the HLDA goes high within a specified delay, TP, of the rising edge of the selected 01 clock pulse. Address and data lines are floated within a brief delay after the rising edge of the next 02 clock pulse. This relationship is also shown in the diagrams. To all outward appearances, the processor has suspended its operations once the address and data buses are floated. Internally, however, certain functions may continue. If a hold request is acknowledged at T3, and if the processor is in the middle of a machine cycle which requires 4 or more states to complete, the CPU proceeds through T4 and T5 before coming to a rest.
1 second. I don't even know, I'm trying to find stupid.
Processing is thus permitted to overlap the
Failed to like finish copying.
entire system. The processor exits the holding state through a sequence similar to that by which it entered. A hold request is terminated asynchronously when the external device has completed its data transfer. The HLDA output returns to a low level following the leading edge of the next 01 clock pulse. Normal processing resumes with the margin cycle following the last cycle that was executed. Halt sequences. When a halt instruction HLT is executed, the CPU enters the halt state T, after state T2 of the next margin cycle, as shown in Figure 211. There are only 3 ways in which the 8080 can exit the halt state. A high on the reset line will always reset the 8080 to state T. Reset also clears the program counter. A hold input will cause the 8080 to enter the hold state, as previously described. When the hold line goes low, the 8080 re-enters the halt state on the rising edge of the next 01 clock pulse. An interrupt, that is, int goes high while int is enabled, will cause the 8080 to exit the halt state and enter state T on the rising edge of the next 01 clock pulse. Note, the interrupt enable int flag must be set when the halt state is entered, otherwise, the 8080 will only be able to exit via a reset signal. Figure 212 illustrates halt sequencing in flowchart form. Startup of the 8080 CPU. When power is applied initially to the 8080, the processor begins operating immediately. The contents of its program counter, stack pointer, and the other working registers are naturally subject to random factors and cannot be specified. For this reason, it will be necessary to begin the power-up sequence with reset. An external reset signal of 3 clock period duration minimum restores the processor's internal program counter to 0. Program execution thus begins with memory location 0, following a reset. Systems which require the processor to wait for an explicit startup signal will store a halt instruction L, HLT, in the first 2 locations. A manual or an automatic interrupt will be used for starting. In other systems, the processor may begin executing its stored program immediately. Note, however, that the reset has no effect on status flags, or on any of the processor's working registers, accumulator, registers, or stack pointer. The contents of these registers remain interminate, until initialized explicitly by the program. -13. Status information. Figure 211.
And a second now, I'm trying to just find this stupid.
Tout chart. -14. Figure 213. Reset. Figure 214. Rotation between hold and NT in the halt state. -15. Mnemonic OP code. MLL. T2 MT3. PC equals PC plus 1 inst TMPIR. M2. T2 T21 T3. Data. ITMP. Data bus B2 TDD B2 TTMP PC equals PC plus 1 B2 PC PC plus 182 PC PC plus 1 B2 PC equals PC plus 1 B2 Z OID 65 D4 MOV R1 R2010 D MOV RM010 D MOV MRSPHLMV Data MVIM data D3 D2 D1 do DSSS D110 0 SSS 1001 D110 T1 PC out status T4 SSS WTMP XT3 ISSS ITMP HL capital X XXXXXXXX THL DE CTMP TOACT AWACT SSS WTMP LIACT IACT AWACT SSS WTMP A ACT AWACT A ACT SSS WTMP IAACT A ACT A ACT T5 ITMP DDD SP T1 HLOUT status C HL out status PCOUT status PC out status stol statusta RP out status 91 HLOUT status PC equals PC plus 1 B2 TMP 91 IACT plus TTMP plus CYA HL out data TMP status PC at PC equals PC plus 1 B2 TMP status 9 SCTTMP A LX type data LD ADA star ADA LHL DADA SHLD ADA LDAX RPM stacks RPM XCHG ADA ADDM 100 ADA A110 ADCA 100 ADCM 100 010 10 10 0010 10 10 10 0, 0, 0, 1 0, 0 0 10 0 1 1 1 0 1 1 0 0 1. In XRP 0 0 RPDC XRP 0 0 RPDAD RPM 0 0 RPDAA 0 0 1 0 ANA 10 10 ANAM 10 10 1 1 0 1110 HLOUT status PC out status del tar HLOUT status PC out statusts HLOUT statusts HL out status re ACT 9 HLOUT statusts data TMP PC equals PC plus 1 B5 TMP ACT TMP CYA DATA TMP 111 111 0 DD 011 0110 0 0 UPI 0001 0011 1010 011 010 010 0 RP 0 RP 110 10 11 PC equals PC plus 1 B2 Z data A data bus 00 ACIDA SWA SUBM SUID ATA SBBR SBBM 1001 SB IDA to 110 INRA 00 DDT 100 INRM 00 11 0 10 0 DCRR 00 DDT 101 DCRM 00 110101 ACT KTMPWA data TMP 000001 0 SSS 0 110 0 110 1 SSS 1110 1110 0 SSS 0 110 0 110 1 SSS PC out statusts 0 1 1 1 0 1 1 1 0 0 1 0 1 1 1 0 SSS 0 1 1 0 capital X TDDDWTMP TMP plus 1 ALU X RP plus 1 IP 1 capital X DAAA flag SMO SSS FTMP AWACT ALU DDD RPRP PC out status PC equals PC plus 1 inst TTMPIR ACT plus ITMP A data TMP minus 16 DDDWTMP ALU DDDITMPI plus 1 ALU PC plus 1 B2 TMP data TMP plus 1 ALU data TMP I ALU L TMP ACT plus TMP ALU L CY M3 M4 M5 T1 T2 MT3 T1 T2 I2 T3 T1 T2 tar T3 T4 T5 HLOUT status PC out status PC out statuses 9 9 9 9 I 91 91 9 9 HLOUT status TL HLOUT status RHT act 9 PC plus 1 PC equals PC plus 1 PC plus 1 PC PC plus 1 TMP data bus B3 RH B3 WB3 W WZ out status WZ out status del status ACT plus TTMP A ACT plus TMP A ACT plus TMP plus CYA ACT plus TMP plus CY ACT TMP A ACT TMP A ACT TMP CYA ACT TMP CYA ALU databus ALU databus HWTMP ALU H CY ACT plus TMP plus CYALU ACT plus TMP A data WZ out L capital A databus LK databus WZ out status 16 WZ out data statusts dot I minus 17 WZ out status databus mnemonic and DAR 3XRARXRAM XRI data aura M aura data CMPR CMPM CPI data RLC RRC RAL RA CMA CMC STC JM Padage Condada I Core Ada C Condadrati RET A Condadrati 7 RST.
I need to uninstall that sound card, whatever.
XTHL import OUTPOR LDL HLT NOP 0000 OPD DED 5D4 110 010 010 1110 1110 1110 10 11 0 SS 10 11 011 1111 01 01 111 000 000 001 001 010 010 00111111 0011 0111 1011 01 SSS HLOUT statists PCOUT 9 HL out statists PC out statists 9 9 9 91 PC out statists PC out status PC out statists PC out statists SP out status SP out status SP out statuses SP out statuses SP out statuses SP out statuses SP out status SP out statushes PC out statists FC out status 6 PC out status data PC +1 lagged TMP flags code D3 D2 D1 do T PC out status MLTL T2 MT3 PC plus.
I guess it's gonna restart. That's cool. Didn't even give a warning.
SWTMP A act to act a whack TSS SWTMP T at act a whack CTMP A act torally rotate FIE.
I'm gonna have to like try to focus again all over. This is so much fun.
Tests 10.0 1cc 100 1cc 11,000,000 and 1001 11cc 00011 m.
Is BIOS stuck? I have this bad feeling that it's not going to turn on. Oh good, it works.
1. Judge condition if true SPSP -1 capital Z ZB2 ZB2 Z data Z PCH data bus IRH data bus A data bus data R1 data flags data ZB2 Z WB2 Z W 10111111 111 111 010000000 11111 10.
I'm gonna try to uninstall a couple other things and then whatever. Stop saying whatever, I'll do it too. And I should also like pronunciate what I'm saying instead of like talk really lazy. Not finish or like start words.
PCI PC +1 PC +1 PC +1 SPSP +1.
Oh, I didn't even finish my sentence when I was saying that. And like finish, what, I'm not even gonna do whatever.
PC +1 data TMP B2 TMP 011C010 110 1 C100 S PC at PC +1 statists 9 ACT plus TMPHA TMP, TMP.
Move a couple more programs.
Inst TMPI inst TMPI RTHL Juge Conditio NTLH SP SP1 PC SPS.
I can uninstall Copilot. That's great. I can't do it on this computer. It's like stuck. I don't know.
9 T2 T3 AC.
Uninstall Diablo. Game work. Diablo 2.
ACT plus TMP A ACT plus TMP A ACT plus TMP A ACT flags ACT TMP.
Windows like messed up the monitors again.
Spout statuses SP out statuses.
It flipped desktop 1 with desktop 2, so I have to like edit this program again.
Spout statuses.
Go to the desktop.
Statuses PC plus 1 SPSP plus 1 SPSP plus 1 TMP UNOI SP out PCH statuses SPSP minus 1 data bus SP out statuses TPCL data bus WZ out status WZ out status WZOUT status dot H WZOUT status SPSP plus 1 SPSP plus 1 flags data A L databus RH capital A capital W capital A DST bus M3 M4 M5 PC out status I was E plus 1 PC plus 1 B3W WZOUT PC at PC plus 1 B3 WWZOUT WZ plus 1 PC
I don't know if it even uninstalled.
W spout IPCH databus spout CLI databus WZOUT status.
I don't think Windows is capable of uninstalling Diablo 2.
WZ plus 1 PC.
It installed it, but didn't launch. And now it can't launch to uninstall.
Databus WZ HL minus 19 notes. The first memory cycle IV1S outweighs an instruction fetch. The first, or only, byte containing the opcode.
I think I can just delete it without screwing anything up, hopefully, because that's what I'm just going to do, I guess. Just delete the folder.
To the CPU. The contents of the internal bus during T4 and T5 are available at the data bus. This is designed for testing purposes only. An X denotes that the state is present, but is only used for such internal operations as instruction decoding. Only register pairs RP equals B, registers B and C, or RP equals D, registers D and E, may be specified. 2T the condition was met. The contents of the register pair WZ are output on the address lines AO15 instead of the contents of the
It's got some where these GIFs were fancy. Yeah, GIFs.
The instruction fetch M1 of the next instruction cycle. 4 if the condition was not met. Subcycles M2 and M3.
I've never used Paint 3D. I'm gonna try it for now, whatever.
Stack read subcycle 16. Stack write subcycle condition CCC.
NZ not 0, Z równa się 0, 000 Z, Z.
So what's the 3D about Paint 3D?
010.
C carry CY equals 1 0 1 1 PO parity odd P equals 0 100 PE parity even P equals 1 101 P plus S equals 0 110 M minus S equals 1 111 8 I
You like pick this and make it bigger.
output subcycle 0. The processor will remain idle in the halt state until an interrupt, a reset or a hold is accepted. When a hold request is accepted, the CPU enters the hold mode. After the hold mode,
Like, can I copy and paste it to Paint 3D? Ooh, wow.
after an interrupt,
Did like size main dump. I can't crop it bigger.
data word
This Paint 3D seems pretty half-assed. Maybe this work here.
During the execution of DAD, M2 and M3 are required for an internal register pair add. Memory is not
What? I can't change it.
logical or rotate instructions are not moved into the accumulator A until state T2 of the next instruction cycle. That is, A is loaded while the next instruction is being fetched. This overlapping of operations allows for faster processing. 0. If the value of the least significant 4 bits of the accumulator is
Okay, how do I make a new file that's like a certain size or whatever?
If 4 bits of the accumulator is now greater than 9, or if the carry bit is set, 6 is added to the most significant bits of the
Background's white. How do I get like
first subsite, the
look 3D-ish?
CDEHL value, -20.
This is very unintuitive GUI here. This is what the fuck even is this program? It's shit. I think it's just basic shit. Oh, it's a shape. It's amazing. Well, computers have come so far. Microsoft really takes advantage of hardware and stuff, and this is so cool. Wow, amazing.
Performance system that
Got, like PCs in here. Oh, there we go. How do we make it 3D again?
and the functions common to any computer system. Control bus, a unidirectional
I had it said like to orbit and to click into whatever. But it's not like 3D anymore.
contains the central processing unit, system timing and interface circuitry to memory and I/O
Oh, it's 3D view, that's it, okay.
ROM, and read.
Now I did, like, delete the fucking white background. Just, did it crash? I think it crashed.
Blocks, data bus,
I'll just make a new file in old school paint, which is also shit.
identify a particular memory location or I/O device. 2.
You know,
PU module issues a binary code on the address bus to identify which particular
how the heck do we get a transparent background?
receives or transmits data with the selected memory location or I/O device. The CPU module returns to T and issues the next activity command. Module refers to a functional block. It does not reference a printed circuit board manufactured by Intel. FBUS refers to a set of signals grouped together because of the similarity of their functions. It is easy to see at this point that the CPU module is the central element in any computer system. -1, Figure 3.1. Typical computer system block diagram. Basic system operation. The following pages will cover the detailed design of the CPU module with the 8080. The 3 buses, data, address and control, will be developed and the interconnection to memory and I/O will be shown. Design philosophies and system architectures presented in this manual are consistent with product development programs underway at Intel for the MCS-80. And components and software for MCS-80 from Intel.
Red, green, blue, alpha. Where the fuck is
Characteristics that are as close as possible to those of the 8200.
It's still not transparent.
224 and 8228 are too complex to practically implement in standard components, so only the basic functions of the 8224 and 8228 are generated. Since significant benefits in system timing and component count reduction can be realized by using the 8224 and 8228, this is the preferred method of implementation. 2. 3. The 8080 Central Processing Unit, a clock generator and high-level driver, a bidirectional data bus driver and system control logic. 080 CPU. The operation of the 8080 CPU is covered in previous chapters of this manual, so title reference will be made to it in the design of the module, clock generator and high-level driver. The 8080 is a dynamic device, meaning that its internal storage elements and logic circuitry require a timing reference, clock, supplied by external circuitry, to refresh and provide timing control signals. The 8080 requires two such clocks. Their waveforms must be non-overlapping and comply with the timing and levels specified in the 8080 AC and DC characteristics. Page 515. Clock generator design. The clock generator consists of a crystal-controlled. The following will discuss the design of the three major areas contained in the CPU module. This design is presented as an alternative to the Intel 8.
I don't think it's transparent.
Controller. By studying the alternative approach, the designer can more clearly see the considerations involved in the specification and engineering of the 8002.
A transparent canvas. Is that too much to ask for?
Meant. Figure.
I guess it's too much to ask for. In Paint, so hidden in some stupid menu.
A. Reset. -2. A 12. Oscillator. Figure 3.3. 8080 Shyark generator. 0 MHz oscillator. A 4-bit counter. And gating circuits. The
Did it just like glue the guy to like the background?
settable, synchronous, binary counter. By presetting the counter as shown in figure 3.3 and clocking it with the
Kind of like paste these as like separate layers.
be measured at the output of the high-level driver to take into AC count the added delays and waveform distortions within such a device. High-level driver design. The voltage level of the clocks for the 8080 is not TTL compatible. B. To 11 volts VC, with rise times and fall times under 50 ns. The capacitive drive is...
I don't think 3D Paint does what I thought 3D Paint would do. I'm done. Oh, it just crashed. It crashed again. Okay, I'm done.
Clock generator, a capacitivity coupled to a dual high-level clock driver. The driver must be capable of complying with the 8080 clock input specifications. Page 515. A driver of this type usually has little problem supplying the positive transition when biased from the 8080 VPO supply, 12V, but to achieve the low voltage specification, VLC 0.8 volts maximum, the driver is biased to the 8080 VGB supply, -5V.
I don't even know if this is like the full game. It's only got like a couple of characters in it. How is it even the whole game?
Due to the pulsed waveforms. Now a circuit is apparent that can easily comply with.
Maybe I had to like download from the internet or something.
Typically less than -3 10 ns. Figure 3.4. High-level driver 7 AMRA 8080 pin 22 7
Just to save a copy of this, whatever.
The clock generator can also be used to provide other signals that the designer can use to simplify large system timing or the interface to dynamic memories. Functions such as power on reset, synchronization of externa, rex, TS, hold, ready, etc., and single step could easily be added to the clock generator to further enhance its capabilities. For instance, the 20 MHz signal from the oscillator can be buffered so that it could provide the basis for communication baud rate generation. The clock generator diagram also shows how to generate an advanced timing signal, 01A, that is handy to using
There's no uninstaller.
requests. It can also be used to generate a strobe, STSTB, That is the latching signal for the status information which is available on the data bus at the beginning of each machine cycle. A simple gating of this.
Why won't it just uninstall?
In system control logic, the system memory and I/O devices communicate with the CPU over the bidirectional data bus. The system control bus is used to gate data on
Just gonna ignore that program then.
by the operation of the 8080 CPU. The data lines of the 8080 CPU nature, that is, their output drivers have the ability to be forced into a high impedance mode and are, effectively, removed from the circuit. This three-state bus technique allows the designer to construct a system around a single 8-bit parallel bidirectional data bus and simply gate the information on or off this bus by selecting or deselecting, three-stating. Memory and I/O devices with signals from the control bus bidirectional data bus driver design. The 8080 data bus, D7D0, has two major areas of concern for the designer. Input voltage level V, 3.3 volts minimum. Output drive capability, LOT, 17 RNA maximum. Figure 3.5, 8080 system control, -4 dB0 dB1 dB2 dB3 dB4 dB5 dB6 dB7. MEMR. The input level specification implies that any semiconductor memory or I/O device connected to the 8080 data bus must be able to provide a minimum of 3.3 volts in its high state. Most semiconductor memories and standard TTL I/O devices have an output capability of between 2.0 and 2.8 volts. Obviously, a direct connection onto the 8080 data bus would require pull-up resistors, whose value should not affect the bus speed or stress the drive capability of the memory or I/O components. The 8080 output drive capability.
I'm almost done uninstalling or whatever.
Memory size and I/O requirements are minimal and the entire system is contained on a single printed circuit board. Most systems, however, take advantage of the high-performance computing power of the 8080 CPU and thus a more typical system would require some form of buff. Faring on the 8000.
Why is Skype like with every install?
Driver whose
Uninstall Microsoft News. And uninstall OneDrive.
volts that not only meets the 8080 input spec but provides the designer with a worst-case 350 mV noise margin. A pair of 8216s are connected directly to the 8080 data bus, D7D0, as shown in Figure 3.5. Note that the dBin signal from the 8080 is connected to the direction controller input, gen, so the correct flow of data on the bus is maintained. The chip select, CS, of the 8216 is connected to bus enable, BUSEN, to allow for DMA activities by deselecting the data bus buffer and forcing the outputs of the 8216s into their high impedance, three-state, mode. This allows other devices to gain access to the data bus DMA system control logic design. The control bus maintains discipline of the bidirectional data bus. That is, it determines what type of device will have access.
That's one of like
and 80 CPU within the proper timing windows as dictated by the CPU operational characteristics, as described previously.
I should probably restart again after like uninstalling crap.
Bit latch, like an Intel 8212, connected directly to the 8080 data bus, D7D0, as shown in Figure 3.5 which store the status information. The signal that loads the data into the status latch comes from the clock generator. It is status strobe, STSTB, and occurs at the start of each machine cycle. Note that the status latch is connected onto the 8080 data bus, D7D0 before the bus buffer. This is to maintain the integrity of the data bus and simplify control bus timing in DMA-dependent environments. As shown in the diagram, a simple gating of the outputs of the status latch with the dbin and WR signals from the 8080 generate the 4 control signal.
How do I turn off this stupid Windows Update thing? I'm gonna just restart and then try to get back to whatever.
4. IO write. IOW connect directly to the MCS-80 component family of ROMs, RAMs and IO devices. A fifth signal, interrupt acknowledge, inter, is added to the control bus by gating data off the status latch with the dbin signal from the 8080 CPU. This signal is used to enable the interrupt instruction port which holds the RST instruction onto the data bus. Other signals that are part of the control bus such as WO, stack and M1 are present to aid in the testing of the system and also to simplify interfacing the CPU to dynamic memories or very large systems that require several levels of bus buffering. Address buffer design. The address bus, A15A0, of the 8080, like the data bus, is sufficient to support a small system that has a moderate size memory and I/O structure, confined to a single card. To expand the size of the system that the address bus can support, a simple buffer can be added, as shown in Figure 3.6. The NTTF 8212 or 8216 is an excellent device for this function. They provide low input loading 0.25 mA, high output drive and insert a minimal delay in the system timing. Note that bus enable, BUSEN, is connected to the buffers so that they are forced into their high impedance, 3-state, mode during DMA activities so that other devices can gain access to the address bus. -5, exclamation point interfac ng the 8080 CPU to memory and exclamation point 0 devices. The 8080 interfaces with standard semiconductor memory components and 0 devices. In the previous text, the proper control signals and buffering were developed which will produce a simple bus system similar to the basic system example shown at the beginning of this chapter. In Figure 3.6, a simple but exact 8080 typical system is shown that can be used as a guide for any 8080 system, regardless of size or complexity. It is a 3-bus architecture, using the signals developed in the CPU module. Note that memory and I/O devices interface in the same manner and that their isolation is only a function of the definition of the read-write signals on the control bus. This allows the 8080 system to be configured so that memory and I/O are treated as a single array, memory-mapped I/O, for small systems that require high throughput and have less than 32K memory size. This approach will be brought out later in the chapter. ROM interface. A ROM is a device that stores data in the form of program or other information such as lookup tables and is only read from. Thus the term read-only memory. This type of memory is generally non-volatile, meaning that when the power is removed the information is retained. This feature eliminates the need for extra equipment like tape readers and disks to load programs initially. An important aspect in small system design. Interfacing standard ROMs, such as the devices shown in the diagram, is simple and direct. But data lines are connected to the B.
Something is wrong.
The address inputs tie to the address bus with possible decoding of the most significant bits as chip selects and the EMR signal from the control.
Windows is like a piece of shit. Oh fuck. God damn it. Blue screen of death, that's great.
Memory read command, MEMR. That gates the address data onto the data bus. RAM interface. A RAM is a device that stores data. This data can be program, active lookup tables, temporary values or external stacks. Storage elements. RAMs do not hold their data when power is removed, so in the case where program or lookup tables data is stored, a method to load STSTB clock 8224 generator and driver sync 1 RDY 8080A CPU WRD0D7 DBI NHLDA N.
Is it working? I don't know.
I. 8,216, 8,702, 8,302, 8,704 ROMs 8308, 8708, 8316, A. 8,102, A4, 8,107 B4 RAMs 8210, 510.
I actually need to back stuff up, I think. I'll be right back.
System I/O communication interface priority address buffers 101.2 8111 2 8102 2 a decoder I optional J data bus 8 control bus 6 U address bus 16 212 I/O 255 peripheral interface capital A -6 RAM memory must be provided such as floppy disk, paper tape, etc. The CPU treats RAM in exactly the same manner as ROM for addressing data to be read. Writing data is very similar. The RAM is issued an address during the first portion of the memory write cycle, T1 and T2. In T3, when the data that is to be written is output by the CPU and is stable on the bus, an MEMW command is generated. The MEMW signal is connected to the RW input of the RAM and strobes the data into the addressed location. TN Figure 3.7. A typical memory system is illustrated to show how standard semiconductor components interface to the 8080 bus. The memory array shown has 8K bytes, 8 bits byte, of ROM storage, using 4 NTE, 8216 IS and 512 bytes of RAM storage, using Intel 8111 static RAMs. The basic interface to the bus structure detailed here is common to almost any size memory. The only addition that might have to be made for larger systems is more buffers, 8216/8212, and decoders, 8205, for generating chip selects. The memories chosen for this example have an access time of 850 ns, max. To illustrate that slower, economical devices can be easily interfaced to the 8080 with little effect on performance. When the 8080 is operated from a clock generator with a TCY of 500 ns, the required memory access time is approximately 450-550 ns. See detailed timing specification page 516. Using memory devices of this speed such as Intel 8308, 8102A, 8107A, etc. the RE80Y input to the 8080 CPU can remain high because no wait states are required. Note that the bus interface to memory shown in Figure 3.7 remains the same. However, if slower memories are to be used, such as the devices illustrated, 8316A, 8111, that have access times slower than the minimum requirement to simple logic control of the RE80Y input to the 8080 CPU will insert an extra wait state that is equal to one or more clock periods as an access time adjustment delay to compensate. The effect of the extra wait state is naturally a slower execution time for the instruction. A single wait changes the basic instruction cycle to 2.5 microseconds, Figure 3.7. Typica. Memory interface 8K plus 512 8K memory map control bus 6 address bus 16 -7 ROM, 0 interface genera. Theory. As in any computer-based system, the 8080 CPU must be AB to communicate with devices or structures that exist outside its normal memory array. Devices like keyboards, paper tape, floppy disks, printers, displays and other control structures are used to input information into the 8080 CPU and display or store the results of the computational activity. Probably the most important and strongest feature of the 8080 microcomputer system is the flexibility and power of its I/O structure and the components that support it. There are many ways to structure the I/O array so that it will fit the total system environment to maximize efficiency and minimize component count. The basic operation of the I/O structure can best be viewed as an array of single-byte memory locations that can be read from or written into. The 8080 CPU has special instructions devoted to managing such transfers, in, out. These instructions generally isolate memory and I/O arrays so that memory address space is not affected by the I/O structure and the general concept is that of a simple transfer to or from the accumulator with an addressed port. Another method of I/O architecture is to treat the I/O structure as part of the memory array. This is generally referred to as memory mapped I/O and provides the designer with a powerful new instruction set devoted to I/O manipulation. Isolated I/O, system control, 8228, figure 39 so, 8id, 0, memory mapped, exclamation point 0, MEMW, IOR. IOW to memory devices to I/O devices, memory mapped I/O, figure 38. Memory I/O mapping so 8id, 0, in figure 39 the system control signals, previously detailed in this chapter, are shown. This type of I/O architecture separates the memory address space from the I/O address space and uses a conceptually simple transfer to or from accumulator technique. Such an architecture is easy to understand because I/O communicates only with the accumulator using the in or out instructions. Also because of the isolation of memory and I/O, the full address space, 65K, ISIN affected by I/O addressing. Examples: MOVA, MOVM, RMVI MLDA, star, LHLDS HLDADDM input port to any register, output any register to port, output immediate data to port, input to ACC, output from ACC to port, 16-bit input, 16-bit output, add port to ACC, and port with a CC, -8. By assigning an area of memory address space as I/O, a powerful architecture can be developed that can manipulate I/O using the same instructions that are used to manipulate memory locations. Thus, a new instruction set is created that is devoted to zero handling, as shown in figure 310. New control signals are generated by gating the MEMR and MEMW signals with a 15, the most significant address bit. The new I/O control signals connect in exactly the same manner as isolated I/O, thus the system bus characteristics are unchanged. By assigning a 15 as the I/O flag, a simple method of I/O discipline is maintained. If F15 is a 0 then memory is active. If F15 is a 1 then I/O is active. Other address bits can also be used for this function. F15 was chosen because it is the most significant address bit so it is easier to control with software and because it still allows memory addressing of 32K. I/O devices are still considered address ports but instead of the accumulator as the only transfer medium many of the internal registers can be used. All instructions that could be used to operate on memory locations can be used in I/O. It is easy to see that from the list of possible new instructions that this type of I/O architecture could have a drastic effect on increased system throughput. It is conceptually more difficult to understand than isolated I/O and it does limit memory address space, but memory mapped 0 can mean a significant increase in overall speed and at the same time reducing required program memory area. Figure 310. Memory mapped 0 addressing. With both systems of I/O structure, the addressing of each device can be configured to optimize efficiency and reduce component count. One method, the most common, is to decode the address bus into exclusive chip selects that enable the addressed I/O device, similar to generating chip selects in memory arrays. Another method is called linear select. In this method, instead of decoding the address bus, a singular bit from the bus is assigned as the exclusive enable for a specific I/O device. This method, of course, limits the number of I/O devices that can be addressed but eliminates the need for extra decoders, an important consideration in small system design. A simple example illustrates the power of such a flexible I/O structure. The first example illustrates the format of the second byte of the in or out instruction using the isolated I/O technique. The devices used are Intel 8255 programmable peripheral interface units and are linear selected. Each device has 3 ports and from the format it can be seen that 6 devices can be addressed without additional decoders. The second example uses memory mapped I/O and linear select to show how 13 devices, 8255, can be addressed without the use of extra decoders. The format shown could be the second and third bytes of the LDA or star instructions or any other instructions used to manipulate I/O using the memory mapped technique. It is easy to see that such a flexible I/O structure, that can be tailored to the overall system environment, provides the designer with a powerful tool to optimize efficiency and minimize component count. Example number 2, a 7A is a 4A3A. IEO capital L port selects. Example number 1, a 7A is a 4A3A. REOL addresses 68255's 118 ports 144 bits. Port selects. Device selects. Figure 312. Memory mapped exclamation point 0. Linear setect. 8255. 0 interface examt. TN figure 316. A typic ATO system is shown that uses a variety of devices. 8212. 8251 and 8255. It could be used to interface the peripherals around an intelligent CRT terminals, keyboards, display, and communication interface. Another application could be in a process controller to interface sensors, relays, and motor controls. The limitation of the application area for such a circuit is solely that of the designer's imagination. The I/O structure shown interfaces to the 8080 CPU using the bus architecture developed previously in this chapter. Either isolated or memory-mapped techniques can be used, depending on the system I/O environment. The 8251 provides a serial data communication interface so that the system can transmit and receive data over communication links such as telephone lines. Figure 311 Solicited TO, linear setect, 8255, -9, addresses 13 8255's. 39 ports 312 bits. Device selects. IO flag. IO. Memory. 000A41. Capital X. Figure 313. 8251 format. 212 number 1 select. Active high. 8212 number 2 select. Active high. 212 number 3 select. Active high. The 2. 8255s provide 24 bits each of programmable I/O data and control so that keyboards, sensors, paper tape, etc. can be interfaced to the system. 001A3A, IEO, figure 314, 8255 format, 0 port is 01 PORTB1CI PORTC 1. Command, addressing the structure is described in the formats illustrated in figures 313. 314, 315. Linear setect is used so that no decoders are required, thus, each device has an exclusive enable bit. The example shows how a powerful yet flexible I/O structure can be created using a minimum component count with devices that are all members of the 8080 microcomputer system. Figure 316. Typical 0 interface. LCD control. 251 select. Active low, data, command, port select, 255 number 1 select, active low, 256 number 2 select, active low, -10. The 8212s can be used to drive long lines or LED indicators due to their high drive capability. 15 mA, figure 315, 8212 format. A computer, no matter how sophisticated, can only do what it is told to do. One tells the computer what to do via a series of coded instructions referred to as a program. The realm of the programmer is referred to as software, in contrast to the hardware that comprises the actual computer equipment. A computer's software refers to all of the programs that have been written for that computer. When a computer is designed, the engineers provide the central processing unit, CPU, with the ability to perform a particular set of operations. The CPU is designed such that a specific operation is performed when the CPU control logic decodes a particular instruction. Consequently, the operations that can be performed by a CPU define the computer's instruction set. Each computer instruction allows the programmer to initiate the performance of a specific operation. All computers implement certain arithmetic operations in their instruction set, such as an instruction to add the contents of 2 registers. Often logical operations, for example, or the contents of 2 registers, and register operate instructions, for example, increment to register, are included in the instruction set. A computer's instruction set will also have instructions that move data between registers, between a register and memory, and between a register and an I/O device. Most instruction sets also provide condition A instructions. A conditional instruction specifies an operation to be performed only if certain conditions have been met. For example, jump to a particular instruction if the result of the last operation was 0. Conditional instructions provide a program with a decision-making capability. By logically organizing a sequence of instructions into a coherent program, the programmer can tell the computer to perform a very specific and useful function. The computer, however, can only execute programs whose instructions are in a binary coded form. That is, a series of ones and zeros. That is called machine code. Because it would be extremely cumbersome to program in machine code, programming languages have been developed. There are programs available which convert the programming language instructions into machine code that can be interpreted by the processor. One type of programming language is assembly language. A unique assembly language mnemonic is assigned to each of the computer's instructions. The programmer can write a program, called the source program, using these mnemonics and certain operands. The source program is then converted into machine instructions called the object code. Each assembly language into one machine code instruction 1 or more bytes by an assembly program. Assembly.
I'm gonna let these couple things like copy whatever. It doesn't look like it's taking too long, I don't know.
Data transfer group. Move data between registers or between memory and registers. Arithmetic.
Windows, it might just keep crashing on me over and over and over. So while it's working, I wanna like save a bunch of shit.
PROLOGUE. Conditional and unconditional jump instructions. Subroutine call instructions and return instructions. Stack. 0 and machine control. Group. Includes IO instructions, as well as instructions for maintaining the stack and internal control flags. Instruction and data formats. Memory for the 8080 is organized into 8-bit quantities, called bytes. Each byte has a unique 16-bit binary address corresponding to its sequential position in memory. The 8080 can directly address up to 65,536 bytes of memory, which may consist of both read-only memory, ROM, elements and random access memory, RAM, elements. Read-write memory. Data in the 8080 is stored in the form of 8-bit binary integers. Data word DDG D5 D4 D3 D2 D2 MSB LSB. When a register or data word contains a binary number, it is necessary to establish the order in which the bits of the number are written. In the Intel 8080, B, T0 is referred to as the least significant bit, LSB, and bit 7 of an 8-bit number is referred to as the most significant bit, MSB. The 8080 program instructions may be 1, 2 or 3 bytes in length. Multiple byte instructions must be stored in successive memory locations. The address of the first byte is always used as the address of the instructions. The exact instruction format will depend on the particular operation to be executed. Address where the data is located. The higher order bits of the address are in the first register of the pair, the low order bits in the second. Immediate. The instruction contains the data itself. This is either an 8-bit quantity or a 16-bit quantity. Least significant byte first, most significant byte second. Byte 1D, byte 2D. Single byte instructions 2I. 2-byte instructions. ITL. 3-byte instructions. Opcode. Do opcode. Do data or address. Unless directed by an interrupt or branch instruction, the execution of instructions proceeds through consecutively increasing memory locations. A branch instruction can specify the address of the next instruction to be executed in one of 2 ways. Direct. The branch instruction contains the address of the next instruction to be executed except for the RST instruction. Byte 2 contains the low order address and byte 3 the higher order address. Register indirect. The branch instruction indicates a register pair which contains the address of the next instruction to be executed. The higher order bits of the address are in the first register of the pair, the low order bits in the second. The RST instruction is a special 1-byte call instruction usually used during interrupt sequences. RST includes a 3-bit field, Program control is transferred to the instruction whose address is 8 times the contents of this 3-bit field. Condition flags. There are 5 condition flags associated with the execution of instructions on the 8080. They are 0, sign, parity, carry, and auxiliary carry, and are each represented by a 1-bit register in the CPU. A flag is set by forcing the bit to 1, reset by forcing the bit to 0, unless indicated otherwise. When an instruction affects a flag, it affects it in the following manner: byte 1d7 feet, I, to do, opcode, data, or address, ID, I, addressing modes, byte 2d, often the data that is to be operated on is stored in memory. When multi-byte numeric data is used, the data, like instructions, is stored in successive memory locations, with the least significant byte first, followed by increasingly significant bytes. The 8080 has 4 different modes for addressing data stored in memory or in registers. Direct, bytes 2 and 3 of the instruction contain the exact memory address of the data item. The low-order bits of the address are in byte 2. The higher-order bits in byte 3. Register. The instruction specifies the register or register pair in which the data is located. Register and direct. The instruction specifies a register pair which contains the memory 0, sign, parity, carry. If the result of an instruction has the value 0, this flag is set. Otherwise it is reset. If the most significant bit of the result of the operation has the value 1, this flag is set. Otherwise it is reset. If the modulo 2 sum of the bits of the result of the operation is 0, that is, if the result has even parity, this flag is set. Otherwise it is reset. That is, if the result has odd parity. If the instruction resulted in a carry, from addition, or a borrow, from subtraction or a comparison, out of the higher order bit, this flag is set. Otherwise it is reset. -2. Auxiliary carry. If the instruction caused a carry out of bit 3 and into bit 4 of the resulting value, the auxiliary carry is set. Otherwise it is reset. This flag is affected by single precision additions, subtractions, increments, decrements, comparisons, and log-ical operations, but is principally used with additions and increments preceding a DAA, decimal adjust accumulator, instruction, symbols and abbreviations. The following symbols and abbreviations are used in the subsequent description of the 8080 instructions. Symbols meaning RHSP, the first, high order, register of a designated register pair, the second, low order, register of a designated register pair, 6-bit program counter register, PCH and PCL are used to refer to the higher order and low order 8 bits respectively. 6-bit stack pointer register, SPH and SPL are used to refer to the higher order and low order 8 bits respectively. Bit M of the register are bits are numbers 7 through 0 from left to right. Accumulator adder, data 16 byte 2, byte 3 port R1, R2DDD, SSS, register A, 6-bit address quantity 8-bit data quantity 16-bit data quantity, the second byte of the instruction, the third byte of the instruction, bit address of an I/O device, one of the registers A, B, C, D, E, H, L, the bit pattern designating one of the registers A, B, C, D, E, H, L, DDD equals destination, SSS equals source, DDD or SSS register name, 11A mob 001C, 10D, 11E, 00H, 01L, one of the register pairs, B represents the B, C pair with B is the higher order register and C is the low order register, D represents the D, E pair with D is the higher order register and E is the low order register, H represents the H, L pair with H is the higher order register and L is the low order register. SP represents the 16-bit stack pointer register, the bit pattern designating one of the register pairs. D, H, SP, RP reg, Stirper, R0BC, 1DE, 0HL, 1SP, M-AVV plus, asterisk, NNNN, sign, parity, carry, and auxiliary carry, respectively. The contents of the memory location or reg IST is enclosed in the parentheses. I stands for read to logical and exclusive O are inclusive or addition. 2's complement subtraction. Multiplication is exchanged with the 1's complement. For example, A. The restart number 0th, rough 7. The binary representation 000 through 111 for restart number 0 through 7 respectively. RP. Description format. The following pages provide a detailed description of the instruction set of the 8080. Each instruction is described in the following manner. The MAC80 assembler format, consisting of the instruction mnemonic and operand fields, is printed in boldface on the left side of the first line. The name of the instruction is enclosed in parenthesis on the right side of the first line. The next line, S, contain a symbolic description of the operation of the instruction. This is followed by a narrative description of the operation of the instruction. The following line, S, contain the binary fields and patterns that comprise the machine instruction. -3, Z, S, P, CY. See the condition flags. 0, 6. The test 4 lines contain incidental information about the execution of the instruction. The number of machine cycles and states required to execute the instruction are listed first. If the instruction has 2 possible execution times, as in a conditional jump, both times will be listed, separated by a slash. Next, any significant data addressing modes, see page 42, are listed. The last line lists any of the 5 flags that are affected by the execution of the instruction. Data transfer group. This group of instructions transfers data to and from registers and memory. Condition flags are not affected by any instruction in this group. Mov RL. R2. Move register. R1. R2. The content of register R2 is moved to register R1. 0 feet 1 DDDSSS. Cycles. 1 states. 5 addressing. Register. Flags. None. Move from memory. R. H. L. The content of the memory location, whose address is in registers H and L, is moved to register R. 01 DDTD 110. Cycles. 2 states. 7. Addressing. Reg and direct flags. None. Move to memory. H. L. R. The content of register R is moved to the memory location whose address is in registers H and L. S. MVTR. Data. Move immediate. R. Byte 2. The content of byte 2 of the instruction is moved to register 0 DDT 1 feet 0 data. MOVR. M. 0 0 1 1 feet 0 feet 1 0 data. Cycles. 3 states. 10. Addressing. IMD. Reg and direct flags. None. Load register pair immediate. RH. T. Byte 3. RL. Byte 2. Byte 3 of the instruction is moved into the higher order register, RH, of the register pair RP. Byte 2 of the instruction is moved into the low order register, RL, of the register pair RP. 0 R0 T1 low order data. High order data. Cycles. 3 states. 10. Addressing. Immediate flags. None. Mov M. R. 1110 SS. Cycles. States. Addressing. Flags. Reg and direct none. -4. MV. M. Data. Cycles. 2 states. 7. Addressing. Immediate flags. None. Move to memory immediate. Byte 2. H. L. The content of byte 2 of the instruction is moved to the memory location whose address is in registers H and L. 60. RP. Data 16. LDADA. Load accumulated direct. A. Byte 3. Byte 2. The cont. Enter the memory location, whose address is specified in byte 2 and byte 3 of the instruction, is moved to register A. SHLDADA. Store H and L direct. Byte 3. Byte 2. L. Byte 3. Byte 2 plus 1, comma H. The content of register L is moved to the memory location whose address is specified in byte 2 and byte 3. The content of register H is moved to the succeeding memory location. 0010T001 low order adder. Star adder. 11 low order adder. High order adder. Cycles. 4 states. 13. Addressing. Direct flags. None. Store accumulated direct byte 3. Byte 2. A. 1. 0. The content of the accumulator is moved to the memory location whose address is specified in byte 2 and byte 3 of the instruction. 011001 low order adder. Cycles. States. Addressing. Flags. Reg and direct none. High order adder. Cycles. 4 states. 13. Addressing. Direct flags. None. Store accumulator in direct. RP. A. The content of register A is moved to the memory location whose address is in the register pair RP. Note: only register pairs RP equals B, registers B and C, or RP equals D, registers D and E, may be specified. 00 RP 001, O, LHL data LH, the content of the memory location, whose address is specified in byte 2 and byte 3 of the instruction, is moved to register L. The content of the memory location at the succeeding address is moved to register H. 10110 low order adder, higher order adder, cycles. 5 states. 16. Addressing. Direct flags. None. Load H and L direct byte 3. Byte 2. Cycles states addressing flags. Reg indirect none. Byte 3. Byte 2 plus 1. Minus 5. STAXRP. High order adder, cycles. 5 states. 16. Addressing. Direct flags. None. 00 RT101 LDAXRP A. The content of the memory location, whose address is in the register pair RP, is moved to register a note. Only register pairs RP equals B, registers B and C, or RP equals D, registers D and E, may be specified. Load accumulator in direct. RP XCHG L. E. The contents of registers H and L are exchanged with the contents of registers D and E. 1 feet 0 feet 1 feet 0, 1 cycles. 1 states. 4. Addressing. Register flags. None. Exchange H and L with D and E. H. Comedy. Arithmetic group. This group of instructions performs arithmetic operations on data in registers and memory, unless indicated otherwise. At instructions in this group affect the 0, sign, parity, carry, and auxiliary carry flags according to the standard UIs. All subtraction operations are performed via 2's complement arithmetic and set the carry flag to 1 to indicate to borrow and clear it to indicate no borrow. ADCR. Add register with carry A plus R plus CY. The content of register R and the content of the carry bit are added to the content of the accumulator. The result is placed in the accumulator. 1 feet 0001 SSS ADDR. A. Add register. A plus R. Cycles. 1 states. 4 addressing. Register. Flags. Z. S. P. CY. A C. Add memory with the carry. A. The content of the memory location whose address is contained in the HR, NDL registers and the content of the CY flag are added to the accumulator. The result is placed in the accumulator. 00 feet 0 is less than 1 feet 1 feet 1 feet 0. ADDM. The content of register R is added to the content of the accumulator. The result is placed in the accumulator. 10,000 SSS. Cycles 1 states 4 addressing register. Flags Z. S. P. CY. A C. Add memory. A plus H. L. The content of the memory location whose address is contained in the H and L registers is added to the content of the accumulator. The result is placed in the accumulator. 000110 cycles. States. Addressing. Flags. Reg indirect Z. S. P. CY. A C. Cycles 2 states 7. Addressing reg indirect. Cycles. 2 states. 7. Addressing. Immediate flags. Z. S. P. CY. A C. Flags. Z. S. P. CY. A C. AD. Data. A. The content of the second byte of the instruction is added to the content of the accumulator. The result is placed in the accumulator. Add immediate. A plus byte 2. Sub R. A. The content of register R is subtracted from the content of the accumulator. The result is placed in the accumulator. 1 feet 00 feet 0 feet 110 data 11 cycles states. Cycles. 1 states. 4 addressing. Register. Flags. Z. S. P. CY. A C. Addressing immediate. Flags. Z. S. P. CY. A C. Minus 6. ADCM. A plus H. L plus CY. A C data. A. The content of the second byte of the instruction and the content of the CY flag are added to the contents of the accumulator. The result is placed in the accumulator. 100 feet 1 is less than 1 feet 1 feet 0 data. Add immediate with carry. A plus byte 2 plus cy. Subtract register. A. R. Sub M. Subtract memory. A. H. L. The content of the memory location whose address is contained in the H and L registers is subtracted from the content of the accumulator. The result is placed in the accumulator. SB data. Subtract immediate with borrow. A. Byte 2. CY. The contents of the second byte of the instruction and the contents of the CY flag are both subtracted from the accumulator. The result is placed in the accumulator. SBBIV. A. 00 feet 1 feet 0 1 1 feet 0 1 feet 101 1 feet 11 feet 0 cycles, states, addressing, flags, reg indirect, Z, S, P, CY, C, data, cycles, 2 states.
I'm almost on copy.
The content of the second byte of the instruction is subtracted from the content of the accumulator. The result is placed in the accumulator. 1 feet 0 feet 1 feet 0 feet 1 feet 1 feet 0 data, SBBR, cycles, 2 states. 7. Addressing, immediate flags, Z, S, P, CY. C. Subtract register with borrow. A. R. CY. The content of register R is incremented by 1. Note: all condition flags except CY are affected. DD1. Cycles 1 states 5 addressing register. Flags Z, S, P, C. 0 feet 1 feet 1 feet 0 is less than 1 I0 O. Subtract immediate. A. Byte 2. A. The content of register R and the content of the CY flag are both subtracted from the accumulator. The result is placed in the accumulator. Increment memory. H. L plus 1. 0 feet 1 1 S cycles. 1 states. 4 addressing, register, flags, Z, S, P, CY. C. Subtract memory with borrow. A, H, L, CY. Cycles, states, addressing, flags, 0, reg indirect Z, S, P, C. The content of the memory location whose address is contained in the H and L registers and the content of the CY flag are both subtracted from the accumulator. The result is placed in the accumulator. Decrement register, R, 1, 0 feet 11,110 00 DDD. 1 feet 0 is less than 1. Cycles, states, addressing, flags, reg indirect Z, S, P, CY. C. Cycles 1 states 5. Addressing register flags Z, S, P, C, -7. NRR. Increment register, R plus 1. Flags Z, S, P, CY. C. INRM. H, L. The content of the memory location whose address is contained in the H and L registers is incremented by 1. Note: all condition flags except CY are affected. DCRR. The content of register R is decremented by 1. Note: all condition flags except CY are affected. DCRTVT. Decrement memory. H, L, -1. The content of the memory location whose address is contained in the H and L registers is decremented by 1. Note: all condition flags except CY are affected. 00110101 DAA. Decimal adjust accumulator. The 8-bit number in the accumulator is adjusted to form 2 4-bit binary coded decimal digits by the following process. TNXRP. Note: all flags are affected. 0 1 feet 0 I0 T1 I1 feet 1 DCX RP. This group of instructions performs logica, Boolean, operations on data in registers and memory and on quantity on flags. Unless indicated otherwise, all instructions in this group affect the 0, sign, parity, auxiliary carry, and carry flags according to the standard rules A and AR, and register A, R. The content of register R is logically ANDed with the content of the accumulator. The result is placed in the accumulator. The CYF. AC is SID 101 feet 0 SSS RH. RL. Decrement register, RH. RL 1 cycles 3 states 10 addressing reg indirect flags Z, S, P, C. If the value of the least significant 4 bits of the accumulator is greater than 9 or if the AC flag is set, 6 is added to the accumulator. If the value of the most significant 4 bits of the accumulator is now greater than 9, or if the CY flag is set, 6 is added to the most significant 4 bits of the accumulator. Increment register pair, RH, RL, RH, RL, plus 1. The content of the register pair RP is incremented by 1. Note: no condition tags are affected. Cycles: 1 states, 4 flags, Z, S, PCY, C, capital R. Cycles: 1 states, 5 addressing register flags, none. 1. Note: no condition tags are affected. 00R1011. Cycles: states: 5 logica. Group pair. The content of the register pair RP is decremented by addressing register. Cycles: 1 states 4 addressing register flags Z, S, P, CY, C. 0 1 0 feet 0 feet 1 feet 1 feet 0 flags none. DAD RP. The content of the register pair RP is added to the content of the register pair H and L. The result is placed in the register pair H and L. Note: only either CY tag is affected. It is set if there is a carryout of the double precision add. Otherwise it is reset. 101. Add register pair to H and L. H, L, H, L plus RH, RL and of A. The contents of the memory location whose address is contained in the H and L registers is logically ANDed with the content of the accumulator. The result is placed in the accumulator. The CY tag is tiered. Cycles: states, addressing flags 0 register CY. Cycles: states, addressing flags reg indirect Z, S, P, CY, C, -8 and memory A, H, L and data and immediate A. Byte 2. The content of the second byte of the instruction is logically ANDed with the contents of the accumulator. The result is placed in the accumulator. The CY and SC flags are cleared. 1 is less than 1 is less than 0 is less than 0 feet 1 feet 1 is less than 0 data O, RA, R. Or register A, V, R. The content of register R is inclusive or with the content of the accumulator. The result is placed in the accumulator. The CY and SC flags are cleared. 0 feet 1 feet 1 feet 0 S. Sys. Cycles 1 states 4 addressing register flags Z, S, P, CY, C. 0 1 feet 1 feet 0 feet 1 feet 1 feet 0 XRAR exclusive OR A, V, R, A. The content of the memory location whose address is contained in the H and L registers is inclusive or with
Has a 6 gigs copy. And I'm gonna restart for good luck. And then get back to finding replacing. And hope Windows doesn't crash get me completely sidetracked again.
register R is subtracted from.
This is taking forever.
The condition flags are set as a result of the subtraction. This edf tag is set to 1 if A equals R. The CY flag is set to 1 if X R. Cycles: 1 states 4 addressing register flags Z, S, P, CY, C. Cycles.
And things are already crashing, I think.
A, V, H, L. Immediate Z, S, P, CY, C. Register A. The content exclusive or with the content of the accumulator. The result is placed in the accumulator. The CY and SC flags are cleared. Register Z, S, P, CY, C. A. The content of the memory location whose address is contained in the H and L registers is exclusive or with the content of the accumulator. The result is placed in the accumulator. The CY and SC flags are cleared. 0 1 is less than 0 1 1 1 feet 0. Cycles: states, addressing, flags, reg indirect, Z, S, P, CY. A C, cycles states addressing flags, cycles states addressing flags, 1 feet 10 I 1 feet 1 1.
It's got like 2 gigs to copy whatever. This computer's slow.
CY. A C, immediate. A, the content of the second byte of the instruction is exclusive ORed with the content of the accumulator. The result is placed in the accumulator. The CY and AC tags are cleared. Compare register. A, R, cycles states addressing flags, immediate Z, S, P, CY. A C, -9 OR, data. A, the content of the second byte of the instruction is inclusive ORed with the content of the accumulator. The result is placed in the accumulator. The CY and AC flags are cleared. 111 feet 011 feet 0 data cycles. 2 states. 7. Addressing, immediate flags, Z, S, P, CY. A C, CMPM. Compare memory, A, H, L. The content of the memory locatio, N whose address is contained in the H and L registers is subtracted from the accumulator. The accumulator remains unchanged. The condition flags are set as a result of the subtraction. The Z flag is set to 1 if A equals H, L. The C flag is set to 1 if A, H, L. RRC rotate right and app I, IO, CY. App O, the content of the accumulator is rotated right 1 position. The higher order bit and the CY flag are both set to the value shifted out of the low order bit POSIT on. Why the CY tag is affected. 0 feet 0 is less than 0 1 is less than 1 feet 1 1. RLC 0 feet 11 cycles state 7 addressing reg indirect flags Z, S, P, CY. A C, CP. Data A. Byte 2. Compare immediate. The content of the second byte of the instruction is subtracted from the accumulator. The condition flags are set by the result of the subtraction. The Z flag is set to 1 if A equals byte 2. The CY flag is set to 1 if A byte 2. 111 feet 1110 data cycles states flags. 4. CY cycles states addressing flags. Rotate left. Immediate Z, S, PCY. A C, CY. The content of the accumulator is rotated right 1 position through the CY flag. The higher order bit is set to the CY flag and the CY flag is set to the value shifted out of the low order bit. Onto the CY tag is affected. N+1. HA, CY, I. The content of the accumulator is rotated left 1 position. The low order bit and the CY flag are both set to the value shifted out of the higher order bit POSIT onto the CY tag is affected. EQ I 110 cycles states flags 4 CY 00 feet 0 feet 0 11 feet 1 0 0 10 1 is less than 1 feet 1 feet 1 cycles 1 states 4 flags CY cycles 1 states 4 flags, none, -10, RAL, rotate left through carry, N+1, and CY, A, Q, CY. The content of the accumulator is rotated left 1 position through the CY flag. The low order bit is set equal to the CY flag and the CY flag is set to the value shifted out of the higher order bit. Onto the CY tag is affected. 001 feet 0 feet 1 feet 11 RAR rotate right through carry N+1 CY O CMA complement accumulator A the contents of the accumulator are complemented 0 bits become 1 bits become 0. No tags are affected. App I 001 feet 1 feet 1 feet 1 feet 1 cycles states flags 4 CY CMC complement carry CY the CY flag is complemented. No other flags are affected. 011 feet 1111 dress is specified in byte 3 and byte 2 of the current instruction. STC branch group low order adder higher order adder cycles 3 states. 10 addressing immediate flags none call PCH PCL SP 2 cycles states, flags, set carry, CY, low order adder, higher order adder, cycles. 3 states. 10. Addressing, immediate flags. None. Conditional jump, CY. The CY flag is set to 1. No other tags are affected. 0 1 feet 1 feet 0 111. Condition adder F. CCC. Cycles. States. Flags. 4 CY. PC. Comma byte 3.
Now I can,
The specif
I don't know if the mic's working, start or whatever.
whose address is specified in byte 3 and byte 2 of the current instruction. Otherwise, control continues sequentially. This group of instructions alter normal sequential program flow. Condition figs are not affected by any instruction in this group. The 2 types of branch instructions are unconditional and conditional. Unconditional transfers simply perform the specified operation on register PC, the program counter. Conditional transfers examine the status of one of the 4 processor flags to determine if the specified branch is to be executed. The conditions that may be specified are as follows. Conman CCC.
NZ, not 0, Z równa się 0, 000Z0, Z równa się 1, 001 NC, no cary, CY równa się 0, 010C, cary, CY równa się 1, 011 po, parity ODD, P równa się 0, 100.
PE, parity, even, P equals 1, P, plus, S equals 0, 110 M minus, S equals 1, 111 JMP adder, jump PC, byte 3, byte 2. Control is transferred to the instruction whose add core adder SP, 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 PC, 1, 2, 0 1, eliter 1, low order adder, higher order adder, minus 11, 1 feet 0, 1, byte 3, byte 2. The higher order 8 bits of the next instruction address are moved to the memory location whose address is 1 less than the content of register SP. The low order 8 bits of the next instruction address are moved to the memory location whose address is 2 less than the content of register SP. The content of register SP is decremented by 2. Control is transferred to the instruction whose address is specified in byte 3 and byte 2 of the current instruction. Cycles. States. Addressing. Flags. 7. Immediate reg indirect none. Condition adder. Condition call. PCH. RSTN. Restart. RET. Return. PCL. TF. CCC. SP. 1. SP. 2. SP. 1. SP. 2. SP. PCH. PCL. SP. 2. PCL. SP. SP. Minus 2. PC. 8. NNN. The higher order 8 bits of the next instruction address are moved to the memory location whose address is 1 less than the content of register SP. The low order 8 bits of the next instruction address are moved to the memory location whose address is 2 less than the content of register SP. The content of register SP is decremented by 2. Control is transferred to the instruction whose address is 8 times the content of NNN. PC. Byte 3. Byte 2. If the specified condition is true, the actions specified in the call instruction see above are performed. Otherwise, control continues sequentially. 100 to order adder, high order adder, PCH, SP, SP, B, SP plus 1, SP plus 2, 5 14 13 12 11 10 9 8 7 6 5 4 3 2 1 0 0 0 0 0 0 0 0 0 0 0 and N 0 0 0. Cycles. States. Addressing. Flags. 5. 1 stroke 17. Immediate reg indirect none. TT. Cycles. States. Addressing. Flags. 1. Reg indirect none. The content of the memory location whose address is specified in register SP is moved to the low order 8 bits of register PC. The content of the memory location whose address is 1 more than the content of register SP is moved to the higher order 8 bits of register PC. The content of register SP is incremented by 2. 1001 feet 001. Program counter after rester. T. L. Recondition. F. CCC. Conditional return. 1 feet 10 feet 1001. Cycles. 1 states. 5. Addressing. Register flags. None. PCL. PCH. SP. SP plus 2. Cycles. States. Addressing. tags 0 reg indirect none PCH PCL. The content of register H is moved to the higher order 8 bits of register PC. The content of register L is moved to the lower order 8 bits of register PC SP SP+1. If the specified condition is true, the actions specified in the ret instruction C above are performed. Otherwise, control continues sequentially. 100 cycles, states, addressing, flags, 3, 11, reg indirect none, -12, PCHL, jump H and L indirect, move H and L to PC, H, stack exclamation point 0, and machine control. Group. This group of instructions performs 0, manipulates the stack, and alters internal control flags, unless otherwise specified. Condition tags are not affected by any instructions in this group. Flag word D. Ds D5, D4, D3, D2, D1 do. SZ0, SC0, P1, CY. Push RP. Push. SP. 1. Pop. SP. RH. SP. -2, RL. SP. SP. 2. Pop RP. RL. RH. SP. The content of the memory location, whose address is specified by the content of register SP, is moved to the low order register of register pair RP. The content of the memory location, whose address is one more than the content of register SP, is moved to the higher order register of register pair RP. The content of register SP is incremented by 2. Note: register pair RP equals SP may not be specified. The content of the higher order register of register pair RP is moved to the memory location whose address is 1 less than the content of register SP. The content of the low order register of register pair RP is moved to the memory location whose address is 2 less than the content of register SP. The content of register SP is decremented by 2. Note: register pair RP equals SP may not be specified. 1T1 RT0 T1 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 RT1 cycles, states, addressing, flags, 1 reg indirect none cycles, states, addressing, flags, 0 reg indirect none push PSW SP -1 SP 2 O CY SP 2 1 SP -2 2 P SP -2 3 -0 SP 2 4 AC SP 2 5 0 SP -2 E Z SP -2 S SP, SP 2. The content of register A is moved to the memory location whose address is 1 less than register SP. The contents of the condition flags are assembled into a processor status word and the word is moved to the memory location whose address is 2 less than the content of register SP. The content of register SP is decremented by 2. 1 feet 1 1 feet 0 1 feet 0 feet 1 CY P SC Z S A SP. The content of the memory location whose address is specified by the content of register SP is used to restore the condition flags. The content of the memory location whose address is 1 more than the content of register SP is moved to register A. The content of register SP is incremented by 2. 1 feet 1 feet 1 feet 0 feet 0 is less than 0 1. Push processor status word A SP 2 SP 4 cycles, states, addressing, flag S 1 reg indirect none cycles, states, addressing, flags 0 reg indirect Z S P CY C -13 pop PSW pop processor status word SP O SP +1 SP +2 SP ESP Y SP +1 SP +2 XTHL exchange stack top with H and L SP H SP +1. The content of the L register is exchanged with the content of the memory location whose address is specified by the content of register SP. The content of the H register is exchanged with the content of the memory location whose address is 1 more than the content of register SP. 1 1 feet 0 feet 0 feet 0 1 feet 1 cycles. 5 states. 18. Addressing, reg indirect flags. None. SPHL. Move HL to SP. SP, H, L. The contents of registers H and L, 16 bits. are moved to register SP. 1 is less than 1 feet 110 feet 0 feet 1. E. Enable interrupts. The interrupt system is enabled for allowing the execution of the next instruction. Endport. Input. Data. Output. Cycles. 1 states. 5 addressing. Register. Flags. None. A. The data placed on the 8-bit bidirectional data bus by the specified port is moved to register A. 101 feet 1 feet 011 port. Knob. Addressing flags. Output. Data. A. Direct none. Cycles. States 10. The content of register A is placed on the 8-bit bidirectional data bus for transmission to the spec I feed port. 101001 feet 1 port. Cycles. 3 states. 10. Addressing. Direct flags. None. -14. D. Disable interrupts. The interrupt system is disabled immediately following the execution of the D instruction. 111 feet 0011 cycles. 1 states. 4 flags. None. Halt. The processor is stopped. The registers and flags are unaffected. 0111 feet 01 feet 1 feet 0 cycles. 1 states. 7 flags. None. No op. No operation is performed. The registers and flags are unaffected. Or 0000 feet 0 feet 0 cycles. 1 states. 4 flags. None. HLT. 1 is less than 1 cycles. 1 states. 4 0 1 flags. None. Exclamation point instruct. Onset. Summary of processor instructions. Og D5. Clock. Instruction column. D. D054 D3Ds ed D10. O. Clock 0. SIC Ls. MOV. MOVM. RSS MOV MI0 HLT halt 10 V10 MVIM. INRR. OCRR. INRM. OCRM. OOR. AOCR. SU6R. SBBR. 10 10 11 01 11 11 1 year 1,101,101 I 10 11 million and 10,000 and 11 10 ANARXRA Aurora RCMP RAOOM AOCM sub MSBBM ANAM XRAM Aura MCMPM ADI ASI SUI SBI ANI XRI 00110 000 1 10 00110 1 110 010111 XTHLS PHLPCHL 01111 1111 111100 1I01 0 13 1 01 1 4 011 18 11 0015 10015 00I07 1001 0 7 1 01 0 711 0107 00115 10011500115 Ori CPI RLC 00 RRC 004 RAL 004 RAL 004 O OBOD 0 DO HOAOSP stacks B stacks 0 lokes B lokes 0 I N X B I N X 0 I N X H I N X S P O C X B O C X 0 C X H D C X S P C M A S T C C M C O A A S H L O 0 1 1 0 1 0 0 1 1 0 1 0 0 1 1 0 11,110
JMPJCJNCJZJNZJP
JMJPE JPO call CCCN CCZ ed CPCM CPO red RCRNC 0 10 0 10 0 10 0 10 0 10 0 10 0 10 0 10 0 I 17 0 0 11 stroke 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 17 1 stroke 17 1 1 7 0 0 1 1 1 7 I00000011 D403D O mnemonic Rs EDAR NZRP RMRP ERPORST in out 61B 61 capital D 61H 61SP push B push T push H push PSW pop B pop 0 pop H pop PSW star LDAXCHG description return on 0 return on no 0 return on positive return on minus return on parity even return on parity odd restart input output load immediate register 000 pair BNC load immediate register 000 pair 0 and E load immediate register 001 pair H and L load immediate stack pointer 001 push register pair BNC N110 push register pair D and D on 110 stack push register pair H and L on 111 push A and flags 111 on stack pop register pair BNC off 110 pop register pair 0 and D off 110 pop register pair and LOLF 111 pap on flags 111 off stack notes 1 DDD or SSS008-001C010D011E100H101L110 memory 111A2 2 possible cycle times 5/11 indicate instruction cycles dependent on condition flags 0 ol SS I00 1000 11 LHLO 0,11/17L 010 16 110114 100114 11005/11 no operation -15 story direct loader direct exchanger 0 and E H and L registers exchanger top off stack H and L H and L to stack pointer H and L to program counter add B and C to H and L add 0 and E to H and L add H and L to H and L add stack pointer to H and L story indirect load A indirect increment B and C registers increment 0 and E registers increment H and L registers increment stack pointer ocrement B and C decrement 0 and E ocrement HSL ocrement stack pointer complement A set carry complement carry decimal register store H and L direct load H and L direct enable interrupts disable interrupt 0I100 I013 0010011 C0 05/11 005/11 005/11 005/11 10I11 010 111 010 111 000 110 0 11 111 000 110 000 110 10 0 110 page 0 0 0 0 0 0 0 0 0 0 000010115 000110115 001 0115 110 115 111 14 00I101114 00I1I1114 001 011 4 01 001 01 11 I11 00 00000 4 01016 11 Silicon Gate MOS 8088 Scangless CHTP8B TN channel microprocessor question mark ESOSOS Funkerung and Giek for Gef BEWY/7FEN for 5050 a TTL drive capability 2S instruction 6 E powerful Probeam swapping instruction set 6 genera purpose registers and an accumulator 16-bit program counter for DRSTI addressing up to 64 KB of memory 16-bit stack pointer and stack manipulation instructions for rapid switching of the program environment decimal binary and dubby precision arithmetic ability to provide priority vectored interrupts 512 DRSTI address 0 ports that Intel 8088 is a complete 8-bit Paratal central processing unit CPU. It is fabricated on a single LSI chip using Intel's N-channel Silicon Gate IVIS process. This offers the user a high-performance solution to control and processing applications. The 8088 contains 6 8-bit general-purpose working registers and an accumulator. The 6 general-purpose registers may be addressed individually or in pairs, providing both single and double precision operators, arithmetic and logical instructions set or reset for testable flags. A 5th flag provides decimal arithmetic operation. The 8080A has an external stack feature wherein any portion of memory may be used as a last-in first-out stack to store retrieve the contents of the accumulator, tags, program counter and all of the 6 general-purpose registers. The 16-bit stack pointer contrits the addressing of this external stack. This stack gives the 8080A the ability to easily handle multiple TAVS priority interrupts by rapidly storing and restoring processor status. It also provides almost unlimited subroutine nesting. This microprocessor has been designed to simplify systems design. Separate 16-line address and 8-line bidirectional data buses are used to facilitate easy interface to memory and I/O. Signets to control the interface to memory and TO are provided directly by the 8080A. Ultimate control of the address and data buses resides with the hold signet. It provides the ability to suspend processor operation and force the address and data buses into a high impedance state. This permits tying these buses with other controlling devices for DMA direct memory access or multiprocessor operation. 8080A CPU functional block diagram S-bit. Internal data bus D7-0 bidirectional 0 at a 6 US capital A data bus buffer latch instruction register 8 is instruction decoder and machine cycle encoding timing and control 88TT internal data bus multiplexer data bus interrupt write control sync clocks TT WR and T hold wait sync M AC ready incremented decrementor address /T6 is address buffer als P address bus hold wait -13 A reg D18 E181 temp reg ZW temp reg C181 reg H8 L18 register reg array stack pointer program counter 16 SL Congate MOS 8080A functional P Endift NT ton. The following describes the function of all of the 8080A pins. Several of the descriptions refer to internal timing periods. AGAO output 3 state ADDRESS bus. The address bus provides the address to memory up to 64K 8-bit words, or denotes the I/O device number for up to 256 input and 256 output devices. AC is the least significant address bit. D7D0, input-output 3-state. Data bus. The data bus provides bidirectional communication between the CPU, memory, and I/O devices for instructions and data transfers. Also, during the first clock cycle of each machine cycle, the 8080A outputs a status word on the data bus that describes the current machine cycle. 2 is the least significant bit. Sync, output, synchronizing signal. The sync pin provides a signal to indicate the beginning of each machine cycle. DBIN, output, data bus in. The DBIN signal indicates to external circuits that the data bus is in the input mode. This signal should be used to enable the gating of data onto the 8080A data bus from memory or TO. Ready. Input. Ready. The ready signal indicates to the 8080A that valid memory or input data is available on the 8080A data bus. This signal is used to synchronize the CPU with slower memory or I/O devices. If after sending an address out the 8080A does not receive a ready input, the 8080A will enter a wait state for as long as the ready line is low. Ready can also be used to single-step the CPU. WAT, output, wait. The wait signal acknowledges that the CPU is in a wait state. WR, output, write. The WR signal is used for memory write or I/O output control. The data on the data bus is stable while the WR signal is active low. WR equals 0. HOLD, input, hold. The hold signal requests the CPU to enter the hold state. The HOLD state allows an external device to gain control of the 8080A address and data bus as soon as the 8080A has completed its use of these buses for the current machine cycle. It is recognized under the following conditions. The CPU is in the halt state. The CPU is in the T2 or TW state and the ready signal is active. As a result of entering the hold state, the CPU address bus NTEL 8088 039 38 37 36 35 34 33 32 31 30 29 28 27 26 25 4 23 22 21 known 3A ICE A90 AG OI AG 0 AG 0 A4 A3 plus 12 VO A2 RIO AO 08 ready OHLDA 15A0 and D8 bus D7D0 will be in there. High impedance RNO TVSS VPO VCC VGA 02 cleared. Ground reference 12 plus 5% volts, 5 plus 5% volts, 5 plus 5% volts. Substrate bias externally supplied clock phases non-TTL compatible state. The CPU acknowledges its knowledge. HLDA pin state with the HOLD SE HLDA output hold acknowledge. The HLDA signal appears in response to the hold signal and indicates that the data and address bus -14 pin configuration will go to the high T3 for read memory or input, the clock period following T3 for write memory or output operation. In either case, the HLDA signal appears after the rising edge of and high impedance occurs after the rising edge of 02. Output interrupt enable indicates the content of the internal interrupt enable flip-flop. This flip-flop may be set or reset by the enable and disable interrupt instructions and inhibits interrupts from being accepted by the CPU when it is reset. It is automatically reset, disabling further interrupts at time T1 of the instruction fetch cycle, M1, when an interrupt is accepted and is also reset by the reset signal TNT, input, interrupt request. The CPU recognizes an interrupt request on this line at the end of the current instruction or while halted. If the CPU is in the HOLD state or if the interrupt enable flip-flop is reset, it will not honor the request. Reset. Input. M. Reset. While the reset signal is activated, the content of the program counter is cleared. After reset, the program will start at location 0 in memory. The int and HLDA flip-flops are also reset. Note that the flags, accumulato, are stack pointer, and registers impedance state. The HLDA signal begins at SLCon gate MOS 8088 absolute maximum ratings. Temperature under bias 0 degrees CTO plus 70 degrees Celsius. Storage temperature minus 65 degrees CTO plus 150 degrees Celsius. All input or output voltages.
COMAVSVS, SFRSISA OS OSES FEOANDER SASO FEAVAX AFNGRSM CATS PERMANENT DAMAGRE FOS DET ZC $7 Stress RAFN OREND 7NCS ON OPERA FONO SD. ICEAT SES ORAN OFER CONO VSCNS ABOT T barra 7 OSN di CAF DNS e OPERA FONA SEC FONS OS SPEC SK FORS NOF MPEC. Exposure FO ABSOT FEOAX MUNRA FNG CONO VS ONZOR EXFENDED.
Bose-Emmer effect Juicria F with respect to VBB, VCC VDD and VGG with respect to EGB power dissipation 0.3 VTO plus 20 V minus 0.3 V to plus 20 V 1.5 W DC character street CS tar equals 0 degrees Celsius to 70 degrees Celsius V equals plus 12 V plus 5% VCC equals plus 5 V plus or minus 5% VGS equals minus 5 V plus or minus 5%, VSS equals 0 V. Unless otherwise noted. Symbol VLLC VLH CVIL V. H Volvo BD. AV. CCAV. IBFAV. LL CLIDJ2 FL parameter minimum clock input low voltage VSS1 clock input high voltage 9.0 input low voltage VSS1 input high voltage 3.3 output low voltage output high voltage 3.7 average power supply current VQ average power supply current VCC average power supply current VSB type 060.01 max unit VSS plus 0.8 V VOD plus 1 V VGG plus 0.8 V VCC plus 1 V 0.45 VV 0 MAR 80 MAR 1 MAR 10, 10A, 100 hectares minus 2.0 mar. Test condition, lol equals 1.9 mar on all outputs. IR equals minus 150A, OPERATION, TCY equals 0.48 UZ, VSS V, VCC, VSS, VClockVod, VSS, V, VGG plus 0.8 V, VSS plus 0.8 V, V, N, VCC, VADD and A2 equals VCC, VADD and A2 equals VSS plus 0.45 V, typical supply current versus temperature, normalized F3L, 25 plus 50 ambient temperature, degrees Celsius, data bus characteristic during dBin, capacitance, T equals 25 degrees Celsius, symbol, CLN, COOT, VCC equals VOD, parameter, clock capacitance, input capacitance, output capacitance, input leakage, clock leakage, data bus leakage in input mode, address and data bus leakage during hold, 10-100, capital A, VGG equals 0V, VBB equals minus 5V. Notes, the reset signal must be active for a minimum of 3 clock cycles too. When dBin is high and V, N, VIT an internal active pull-up will be switched onto the data bus 3. At supply A2 equals minus 0.45% degrees Celsius. Type, maximum, 725. 10-10-20 unit PF. Test condition FC equals 1 MHz unmeasured pins returned to EGG minus 15 SL Congate MOS 8080 AC character it sucks. TAR equals 0 degrees Celsius to 70 degrees Celsius. V equals plus 12V plus 5%. VCC equals plus 5V plus or minus 5%. VGE equals minus 5V plus 5%. VGG equals OV. Unless otherwise noted, symbol TCY, 3 TRTF, 4 is less than 2, TOI TP2 to 3, TDA 2, TDC TOF TDS 1, parameter, minimum, max, unit, test condition, CL100PF. Clock period 0.48 clock rise and fall time 00 L pulse width 60 02 pulse width 220 delay 01 to 020 delay 02 T degrees 0170 delay 0 to 02 leading edges 80 address output delay from 02 data output delay from 02 signal OUTP UT delay from 01 or 02 sync WR watt HLDA, dBin delay from 0 to 25 delay for input bus to enter input mode. Data setup time during 01 on dBin 30.0 sec 15 second 200 sec 20 sec 120 sec 140 n sec TDF and sec CL 0 PF UMINGW AVEFO RMS 14. Note, timing measurements are made at the following reference voltages. Clock 1 equals 8.0 V, 0 equals 1.0 V, inputs 1 equals 3.3 V, 0 equals 0.8 V, outputs 1 2.0 V, 0 equals 0.8 V, a triple A, F, DCDC, R, minus 16, R, capital L, T, NS, R, I, colon, SL Congate MOS 8080 AC, character SMCS, continued. TA equals 0 degrees Celsius to 70 degrees Celsius. V equals plus 12V plus or minus 5%. VCC equals plus 5V plus or minus 5%. VGG, 5V plus 5%. VGG equals OV. On S otherwise noted, D70F, sync, 20, Symbo, DS2, TDHT, E. 2L. Treasure chest is THTFD, TAW, TO2 TWA, THF, TWFTA, parameter. Data setup time to 02 during dBin, data hold time from 02 during dBin, in output delay from 02, ready setup time during 02, hold setup time to 02, INT setup time during 02, during, hold time from 02, ready, INT, hold, delay to float during hold, address and data bus, address stable prior to WR output data stable prior to WR output data stable from WR address stable from WR, HLDA to float delay, WR to float delay, address hold time after dBin during HLDA, minimum, 50, 1, 20 140 120 0 5 6 7 7 8 9 minus 20 0 maximum 0 unit second sec test condition capital A 5V in halt mode notes load circuit minus 17 8080 output capital I CY equals D3 plus R 2 plus 2 plus TF% 2 plus to 2 plus 480 ns typical output delay versus a capacitance 20 sec CL equals I00 PF a DDRESS DATIA spec a capacitance PF a maximum output rise time from 0.8V to 3.3V equals 100 ns at C equals spec B output delay when measured to 3.0V equals spec plus 60 ns at C equals spec C if C spec add 6 NSPF if C CSPGC subtract 3 NSPF from modified delay if C CGPGC TP W equals 2 TCY TD3 TR H114 sec TDW equals TCY D3R squared 117 sec IFNet HLDA TWD equals TWI equals TD3 plus TR squared plus 10 NSI Helder 2 equals TA equals THF equals TD3 plus R 2 minus 50 NS 9 TF equals TD3 plus T squared CL equals 50 PF C equals 50 PF WR HLDA DBIN SL Congate MOS 8080A Instruct on set. The accumulator group instructions include arithmetic and logical operators with direct, indirect, and immediate addressing modes. Move, load, and store instruction groups provide the ability to move either 8 or 16 bits of data between memory, the 6 working registers and the accumulator using direct, indirect, and immediate addressing modes. The ability to branch to different portions of the program is provided with jump conditional, and computed jumps. Also, the ability to call to and return from subroutines is provided both conditionally and unconditionally. The restart or single byte call instruction is useful for interrupt vector operation. W precision operators such as stack manipulation and double add instructions extend both the arithmetic and interrupt hunting capability of the 8080A. The ability to data and instruction formats, increment and decrement memory. The 6 general registers and the accumulator is provided as well as extended increment and decrement instructions to operate on the register pairs and stack pointer. Further capability is provided by the ability to rotate the accumulator left or right through or around the carry bit. Input and output may be accomplished using memory addresses as I/O ports or the directly addressed I/O provided for in the 8080A instruction set. The following special instruction group completes the 8080A instruction set. The NOP instruction, halt to stop processor execution, and the DAA instructions provide decimal arithmetic capability. STC allows the carry flag to be directly set, and the CMC instruction allows it to be complemented. CMA complements the contents of the accumulator and XCHG exchanges the contents of 2 16-bit register pairs directly. Data in the 8080A is stored in the form of 8-bit binary integers. All data transfers to the system data bus will be in the same format. DGD5, D4, D3, D2, D1 do data word. The program instructions may be 1, 2, or 3 bytes in length. Multiple byte instructions must be stored in successive words in program memory. The instruction formats then depend on the particular operation executed. 1 byte instructions DGD5, D4, D3, D2, D1 do OP code. 2 byte instructions DGD5, D4, D3, D2, D1 do OP code DGD5, D4, D3, D2, D1 do operand. 3 byte instructions DGD5, D4, D3, D2, D1 do OP code DGD5, D4, D3, DGD1 do low addresser operand 1D. DGD5, D4, D3, D2, D1 do high addresser operand 2. Typical instructions: register to register, memory reference, arithmetic or logical, rotate, return, push, pop, enable or disable. Interrupt instructions: immediate mode or I/O instructions: jump, call or direct load and store instructions. For the 8080, a logic 1 is defined as a high level and a logic 0 is defined as a low level. -18 SL Congate MOS 8088 Instruct on set. Summary of processor instructions. Mnemonic description. Instruction code. Clock 2006004030 do cycles 01DD0SSS01110SSS01DD01100 0 1000000110 011 0110 10 00 D0 D105 DT101 500 10 0 0 0 110 101 10 0000 SSS4 10001 SSS4 exclamation point 000 SSS4 exclamation point 0011 SSS4 Much to mnemonic IDs O's D4 D3D D2 cycles M0V 2 MOVM R Mover M HLT Mover media to register MVI M Mover media to memory Rs ed 1,000,000 and 1,000 5/11 RNZ 10,000 C0 5/11 RP 1,110,000 5/11 HM11 1,000 5/11 RPE 1 NRR ROCRI NRMDCR MADDR RADCR sub SBBR ANAS RAR or CMPR RADDM ADCM sub MSBBM Increment register decrement register increment memory decrement memory add register to A with carry subtract register from A and register with or exclusive or register with or register with A compare register with or memory to A add memory to A with carry subtract memory from A RPO RST restart in output 61B 1 1000 5 11 1 1 0 0005/11 1 AA 11111 101111 10 10100011 10 00000110 00100001 10 01 0001 10 01100011 110 010111 1,010,101 111 0101 11 11110101 11 1 1 0000110 11,010,001 111,110 11,110,001 move register to memory move memory to register halt 7777 annum XRAM or more memory with the CMPM AE ASCII 01 110 7 10 0 exclamation point 071 011011107 1 0111107 1 1 0 10710 0111107 1,010,110 7 1,101 110 7 11 110 7 11101107 SUDI SBI subtract immediate Roma and memory with or exclusive or memory with A. Compare memory with the add immediate to A. M immediate to A with AMI and immediate U with the XRI capital A or U or immediate U with the 1,110,110 7 11111110 7 000 111 4 star 0011001013 LDA 00111010 13 XCHG exchange year and DH and L111 1011 4 XTH L110011 exclamation point 8 SPH L11,111,001 5 PCH L111 1001 5 DADB add bin CT and L00100110 01 01 01 01 00 00 00 1001110 7, 610, 61H, 61SPPUSHB, push 0, push H, push PSW, POPB, POPD, POF, POPPSW, pair B and C, pair D and E, pair H and L, SSS401, SSS410, SSS41, SSS4, 110, 7, 01110, 7, 101, I07, CP Icomper immediate the RLC rotator left, RRC rotator right, 0000, 111 4 DM0 at 0 and Ito and L how rotator left through carry, RA rotator right through. 0 11001 10 0 0 1 1 0 0 1 1 0 0 0 1 1 1 0 0 1 1 0 0 0 0 0 0 1 0 7 0 0 0 1 0 0 1 0 7 0 0 0 1 0 1 0 7 0 0 0 1 1 0 1 0 7 0 0 0 0 0 1 5 0 0 0 1 0 0 1 1 5 0 0 1 0 0 1 1 5 0 0 1 1 0 0 1 1 5 0 0 0 1 0 1 1 5 0 0 0 1 1 0 1 1 5 0 0 1 1 0 1 1 5 0 0 1 1 1 0 1 1 5 0 0 1 1 1 1 1 4 0 0 1 1 0 1 1 1 4 0 0 1 1 1 1 1 1 4 0 0 0 1 4 0 0 1 0 0 1 0 1 6 0 0 1 1 0 1 0 1 6 11,111,011 4 1 1 1 1 0 0 1 1 4 0 0 0 0 0 0 0 0 4 0 0 1 0 1 1 1 4 DAD H DADSP STAXB Stacks D LDAXB LOXO IWXB INXD INXH INXSP OCXB OCXO DCXH OCXSP CMA STC CMC OAA SHLD Store Rental Direct LHL OLO Dental Direct L 0011 Add and L to H and L JMP Jump Unconditional JC Jump and Carry 11,011,010 10 JNC Jump and a Carry 1 0 1 0 0 1 0 10 JZ Jump and Arrow exclamation point 0 0 1 0 0 10 JNZ Jump and a 0 110 0 1 0 10 JP Jump and positive 11,110,010 10 JM Jump on minus JP Jump on parity even JPO Jump on parity odd call unconditional CC call on carry CNC call on no carry CZ call on 0 CNZ call on no 0 CP calf on positive CM call on minus 11,111,100 11 stroke 17 CP colon parity of an 11,101,100 11 stroke 17 CPO call on parity odd red return 11101117 11001001 10 DI 01100005 stroke 11 WAP 1101000005 stroke 11 LCRNC notes return and carry return on no carry 10 1110 1,111,010 10 11,101,010 10 1 101,010 1 001017 exclamation point 1,011,111 stroke 17 101010001117 1100110011 17 110 10,011 stroke 17 T00011 stroke 17 decrement B and C 14 DDD or SSS minus 000B minus 001C010 D minus 011E 100H 101L 110 memory 111A2 2 possible cycle times 5 stroke 11 indicate instruction cycles dependent on condition flags -9 8224, Schottky Bipiter 8224 clock generator and ERVer for 8080 ACPU, Singy chip SIOC generator driver for 8080 ACPU, power up reset for CPU, ready synchronizing FTIP up advanced status strobe, OC hater output for externa, system timing, Krista, Contraide for stable system operation, reduces system package count. The 8224 is a single chip TOC generator driver for the 8080 ACPU. T is contracted by a Krista, selected by the designer, to meet a variety of system speed requirements. Also inserted a circuits to provide power-up reset, advanced status strobe and synchronization of ready. The 8224 provides the designer with a significant reduction F packages used to generate docs and timing for 8080A PNCONF Giratin block Tagrat VT oscillator clock gem D3 A reset I1 resin I2 RDYN3 ready 4 SYNC5 Italy I6 STSTB I7 GNDL8 6 15 14 13 12 11 10 VCC1 XTAL1 IXTAL2 ITANK lose ZMI ZDD resin reset RDYN ready sync STSTB 2 L XTAL1 XTAL2 E3 tank OSC 1 TTL T reset output ready output sync input status STB active low 8080 iClocks XTAL1 dual connections EPN names capital O CODQC XTAL2 tank OSC 2 TTTL VCC VDDGND for crystal used with overtone XTAL oscillator output 2CLK TTL level 5V 12V OV -1 sync STSTB resin RDYN Schmidt input reset ready Schottky bipolar 8224 funct onal DESC ton genera. The 8224 is a single chip clock generator driver for the 8080 ACPU. It contains a crystal controlled oscillator, a divide by 9 counter, to high-level drivers and several auxiliary logic functions. Oscillator. The oscillator circuit derives its basic operating frequency from an external, series resonant, fundamental mode crystal. 2 inputs are provided for the crystal connections, XTAL1, XTAL2. The selection of the external crystal frequency depends mainly on the speed at which the 8080A is to be run at. Basically, the oscillator operates at 9 times the desired processor speed. A simple formula to guide the crystal selection is TCY. Example 1, 500 C, 2 MHz times 9 equals 18 MHz. Example 2, 800 NS TOI, 1.25 MHz times 9 equals 11.25 MHz. Another input to the oscillator is tank. This input allows the use overtone mode crystals. This type of crystal generally has much lower gain than the fundamental type, so an external LC network is necessary to provide the additional gain for proper oscillator operation. The external LC network is connected to the tank input and is AC coupled to ground. See Figure 4. The formula for the LC network is $RVLC. The output of the oscillator is buffered and brought out on CSC, pin 12, so that other system timing signals can be derived from this stable, crystal-controlled source. When using crystals above 10 MHz, a small amount of frequency trimming may be necessary to produce the exact desired frequency. The addition of a small selected capacitance, 3pf-10pf, in series with the crystal will accomplish this function. COC generator. The clock generator consists of a synchronous divide by 9 counter and the associated decode gating to create the waveforms of the two 8080A clocks and auxiliary timing signals. The waveforms generated by the decode gating follow a simple 252 digital pattern. See Figure 2. The clocks generated, Phase 1 and Phase 2, can best be thought of as consisting of units based on the oscillator frequency. Assume that 1 unit equals the period of the oscillator frequency. By multiplying the number of units that are contained in a pulse width or delay, times the period of the oscillator frequency, the approximate time in nanoseconds can be derived. The outputs of the clock generator are connected to 2 high-level drivers for direct interface to the 8080A CPU. A TTL level Phase 2 is also brought out 02 TTL for external timing purposes. It is especially useful in DMA-dependent activities. This signal is used to gate the requesting device onto the bus once the 8080A CPU issues the hold acknowledgement. HLDA. Several other signals are also generated internally so that optimum timing of the auxiliary flip-flops and status strobe, STSTB, is achieved. Crystal frequency equals times 9 minus 2 T. Example, 8080 I2 I 500NS OSC FREC 1T dot R OSC equals 18 MH 55NS Schottky bipolar 8224 STSTB status strobe. At the beginning of each machine cycle, the 8080A CPU issues status information on its data bus. This information tells what type of action will take place during that machine cycle. By bringing in the sync signal from the CPU and gating it with an internal timing signal, 1A, an active toe strobe can be derived that occurs at the start of each machine cycle at the earliest possible moment that status data is stable on the bus. The STSTB signal connects directly to the 8228 system controller. The power on reset also generates STSTB, but of course, for a longer period of time. This feature allows the 8228 to be automatically reset without additional pins devoted for this function. Power on reset and ready FNP FTOPs. A common function in 8080 microcomputer systems is the generation of an automatic system reset and startup upon initial power on. The 8224 has a built-in feature to accomplish this feature. An external RC network is connected to the resin input. The slow transition of the power supply rise is sensed by an internal Schmidt trigger. The circuit converts the slow transition into a clean, fast edge when its input level reaches a predetermined value. The output of the Schmidt trigger is connected to a D-type flip-flop that is topped with 2D, an internal timing signal. The flip-flop is synchronously reset and an active high level that complies with the 8080A input spec is generated. For manual switch-type system reset circuits, an active low switch closing can be connected to the resin input in addition to the power on RC net network LS4, L3P. The READY input to the 8080A CPU has certain timing specifications such as setup and hold, thus, an external synchronizing flip-flop is required. The 8224 has this feature built in. The written input presents the asynchronous wait request to the D-type flip-flop. By clocking the flip-flop with 02D, a synchronized ready signal at the correct input level can be connected directly to the 8080A. The reason for requiring an external flip-flop to synchronize the wait request rather than internally in the 8080 CPU is that due to the relatively long delays of IVTOS logic, such an implementation would rob the designer of about 200 ns during the time his logic is determining if a wait is necessary. An external bipolar circuit built into the clock generator eliminates most of this data and has no effect on component count. XTAL1, XTAL2, tank, sync, resin, Schmidt, part, clock, ren, 9, L, OSC, L2, IS, TTLG, STSTB, 7E, HESTT, ready, 7, Royalton, -3, 2T, RJLC, used only EOR overtone crystals, OSC, 2 ITTL. RDY, N, HQH, I, 310PF, I only needed I above 10 MHz, STSTB, to 8228 pin 1, Schottky bipolar 8224, DC characteristics, TA equals 0 degrees Celsius to 70 degrees Celsius, VCC equals plus 5.0 V plus 5%, V equals plus 12 V plus 5%, symbol FRVCV, LV, H, VLH, VIL, VOL, SC, CC, parameter minimum, input current loading, input leakage current, input forward clamp voltage, input low voltage, input high voltage, 2.6.0 reading, input hysteresis 0.25, output low voltage, output high voltage, 29.4, ready, reset 3.6.4, limits type, max. Units test conditions. 0.25 MAR VP 0.45 V 10 AVP equals 5.25 V. 0.0 VLC equals -5 MAR 0.8 VVCC equals 5.0 VV. Reset input are other outputs. Output short circuit current -10. Are low voltage outputs only. Power supply current. Capital V low equals -1 MAR. BD. Note 1. Caution. And output drivers do not have short circuit protection. 60 MAR VO equals of VCC equals 5.0 V. 15 MAR 12 MAR. Crystal requirements. Tolerance 0.005% at 0 degrees Celsius 70 degrees Celsius. Resonance. Series. Fundamental. Load capacitance. 2035 PF equivalent resistance. 7520 ohms. Power dissipation. Min. 4 megawatts with tank circuit use third overtone mode. -4. 45 V. All other outputs LOL equals 15 MAR. MV. All other inputs 5.0 V. 45 VH. H. Ready. Reset. STSTB LOL equals 2.5 MAR. VLOW equals -100 NAR. VLOW equals -100 A. Schottky bipolar 8224. AC characteristics. VCC equals +50 V +5%. VON equals +120. V +5%. T equals 0 degrees Celsius to 70 degrees Celsius. Symbo. TD1 TD2 TD3 TR TF TDSS TPW. Doctors TDRH TDR TCLK. Max sin parameter 1 pulse width 2 pulse width 0 1 to 0 2 delay 2 to 0 1 delay 1 to 0 2 delay 1 and 0 2 rise 1 and 0 2 fall time 0 2 to 0 2 TTL. Delay 2 to STSTB delay. STSTB pulse width. RDYIN setup time to status strobe. RDYN hold time after STSTB. RDYIN or RESINTO 02 delay. CLK period. Maximum oscillating frequency. Input capacitance. Minimum. Y20NS. Y35NS. V14NS. Limits type. Test conduit ions. C equals 20 PF to 50 PF. 02 TTL. CL equals 30, RE equals 300H, R2 equals 600H, STSTB, CL equals 15 PF, RE equals 2K, R2 equals 4K, ready and reset CL equals 10 PF, RL equals 2K, R2 equals 4K, VCC equals +5.0 VV equals +12 VV mass equals 2.5 VF equals 1 MHz, TIGM defect time, maximum, Y plus 20 NS, 0, 0 minus 5 plus 15, 30 NS 6 TCY, 9 units, NS, 9 2 TCY, Y15 NS 9, 50 NS 4 TCY, Y25 NS 9, 7 TCY, IT, -5 MHz PF, Schottky bipolar 8224 waveforms, voltage measurement points, percent, 1%, 2 logic 0 equals 1.0 V, logic 1 equals 8.0 V. Alt other signals measured at 1.5 V. Example, AC characteristics for TCY equals 488.28 NS, 0 degrees Celsius to 70 degrees Celsius. VCC equals +5 V +5%. VPO equals +12 V +5%. Symbol T. Percent to TOI TD2, TRTF, TDSS, TPW, TDRS, TDRH, TDR, max, parameter 0 1 pulse width, 2 pulse width, delay 0 1 to 0 2 delay 0 2 to 0 1 delay 0 I to 0 2, output rise time, capital O, output fall time, 2 to STSTB delay, 2 to 0 2, TTL. Delay, status strobe pulse width, RDYN setup time to STSTB, RDYN hold time after STSTB, ready or reset to 02 delay, oscillator frequency, minimum, 89, 36 0 95 109, 96 -5 41 67, 217, 192, limits type, maximum, 29 20 20 326 plus 15. 8.432 units ns 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 megahertz. Test conditions TCY equals 488.28 ns 01 and 02 loaded to C equals 20 to 50 pf. Ready and reset loaded to 2 mar/10 pf. Our measurements referenced to 1.5 v unless specified otherwise. Leading edges -6 int JShotkey bipitter 8228. System controller and bus TRV for 8080 CPU. Single chip system controller for MCs. -80 systems. Buitin bidirectional I bus driver for data bus isolation. 8 hours the use of multiple byte instructions, for example call. For interrupt acknowledge. User selected single levy interrupt vector. RST7. 8-pin DUI inline package reduces system package count. The 8228 is a sync chip system controller and bus driver for MCS-80. It generates sales signals required to directly interface MCS-80 family RAM, ROM, and I/O components. A bidirectional bus driver is included to provide high system TTL fan-out. It also provides isolation of the 8080 data bus from memory and I/O. This allows for the optimization of control signals, enabling the systems DSNA to use stored memory and TO. The isolation of the bus driver also provides for enhanced system noise immunity. A user-selected single-level interrupt vector, RST7, is provided to simplify real-time, interrupt-driven, small system requirements. The 8228 also generates the correct control signals to allow the use of multiple byte instructions, for example, call, in response to an interrupt acknowledged by the 8080A. This feature permits large, interrupt-driven systems to have an unlimited number of interrupt levels. The 8228 is designed to support a wide variety of system bus structures and also reduce system package count for cost-effective, reliable design of the MCS-80 systems. PTNCONF Giratin 228 block diagram. STSTB1HLDA2WR3DBIN4DB4 circumflex 5D46DB7 circumflex 7D8DB39 DB2 circumflex 11 D212 DBPF13GND14 8, 27, 26, 25, 24, 23, 22. DCC, LOW, MEMWA, or, MEMR enter. CPU data bus, 228. Busan 21D6. MEMRMWIO, RLOV Busan Inter, 0 dB 610 19D5, 8 dB 517 3D116 dB I15 HD0, D7 2dB 7 dBOL or LOW MEMR MEMWDBIN. PTN names, data bus 18080 side, inter data bus, system side, HLDA, interrupt acknowledge HLDA from 8080, WR, from 8080, bus enable input, status strobe, from 8224, plus 5V volts, IO read, IO write memory write DBIN, from 8080, WR Busan STSTB, RVCC, GND, -7, Schottky bipolar 8224, Funct Onal DESCR Fon, Genera. The 8228 is a single chip system controller and data bus driver for the 8080 microcomputer system. It generates all control signals required to directly interface MCS-80 family RAM, ROM, and I/O components. Schottky bipolar technology is used to maintain low delay times and provide high output drive capability to support small to medium systems. Bidirectional bus driver, an 8-bit bidirectional bus driver is provided to buffer the 8080 data bus from memory and I/O devices. The 8080A data bus has an input requirement of 3.3 volts min and can drive, sync, a maximum current of 1.9 mA. The 8228 data bus driver assures that these input requirements will be not only met but exceeded for enhanced noise immunity. Also, on the system side of the driver adequate drive current is available, 10 mA type, so that a large number of memory and I/O devices can be directly connected to the bus. The bidirectional bus driver is controlled by signals from the gating array so that proper bus flow is maintained and its outputs can be forced into their high impedance state. 3 state. For DMA activities, status latch. At the beginning of each match, an ECMAScript 8080 CPU issues status information on its data bus that indicates the type of activity that will occur during the cycle. The 8228 stores this information in the status latch when the STSTB input goes low. The output of the status latch is connected to the gating array and is part of the control signal generation. Gating array. The gating array generates control signals, memr, memw, IOR, IOW and inter, by gating the outputs of the status latch with signals from the 8080 CPU, dbin, WR, and HLDA. The read control signals, memr, IOR and inter, are derived from the logical combination of the appropriate status bit, or bits, and the dbin input from the 8080 CPU. The write control signals, memw, IOW, are derived from the logical combination of the appropriate status bit, or bits, and the WR input from the 8080 CPU. All control signals are active low and directly interfaced to MCS-80 family RAM, ROM and I/O components. The intercontrol signal is normally used to gate the interrupt instruction port onto the bus. It also provides a special feature in the 8228. If only one basic vector is needed in the interrupt structure, such as in small systems, the 8228 can automatically insert a RST7 instruction onto the bus at the proper time. To use this option, simply connect the inter output of the 8228, pin 23, to the plus 12 volt supply through a series resistor, 1k ohms. The voltage is sensed internally by the 8228 and logic is set up so that when the dbin input is active, the RST7 instruction is gated onto the bus when an interrupt is acknowledged. This feature provides a single interrupt vector with no additional components, such as an interrupt instruction port. When using CALL as an interrupt instruction, the 8228 will generate an NTA putts for each of the 3 bytes. The BUSEN, bus enable, input to the gating array is an asynchronous input that forces the data bus output buffers and control signal buffers into their high impedance state if it is a 1. If BUSEN is a 0, normal operation of the data buffer and control signals take place. CPU data bus 228 block diagram, -8. Schottky BP, Euler 8224, 8080A CPU, from 8224. Status strobe, 360B, 1. Bidirectional 5. db inter, memr memw, IOR, ITOW. 228. Bus driver, 0. Data bus, -9. 8. db. Control bus, NTA, none. NTA, OW, 0. R. MEMW, SNALS MEV. Capital, R. MEMW memr. Control, Schottky bipolar 8224 waveforms. Status strobe, 080 data bus, dbin, inter. IR. MEMR, HLDA, during HLDA system bus during read, 080 bus during read, WR, IRMMW, 080 bus during write, system bus during write, system bus enable, system bus outputs, Y, RRT, M-, a C characteristics T equals 0 degrees Celsius to 70 C, VCC equals 5V plus 5%. Symbol parameter, width of status strobe, setup time, status inputs DG-DI, hold time, status inputs DG-DI, delay from STSTB to any control signal, limit minimum, maximum, units conduit ion, TPW, TSS, SH, TDC, TRR delay from dbin to control outputs, tray delay from dbin to enable disable 8080 bus to NS8 NS5 NS, TRO TWR TWD, THDDSTDH, delay from system bus to 8080 bus during read, delay from WR to control outputs, delay to enable system bus DB0 DB7 after STSTB, delay from 8080 bus duty to system bus DBQ DBY during write, delay from system bus enable to system bus DBQ DB7 HLDA to read status outputs, setup time, system bus inputs to HLDA, hold time, system bus inputs to HLDA, 0 60 30 45 35 45 30, 40 30, 0 20, NSCL equals 100 PF NSCL equals 100 PF NSCL equals 25 PF NSCL equals 25 PF NSCL equals 100 PF NSCL equals 100 PF NSCL equals 100 PF VI, VW DCY 3C voltage measurement points DQD7 when outputs logic 0 equals 0.8 V, logic 1 equals 3.0 V. All other signals measured at 1.5 V, minus 10. NSCL equals 100 PF 25 NS, NSCL 100 PF. Schottky bipolar 8224. DC characteristics T equals 0 degrees Celsius to 70 degrees Celsius. VCC equals 5V plus or minus 5%. Symbot VC capital F capital R VTHCC vol OS B off limits type 11 maximum 75 minus 1.0 00 750 5250 00 20 100 20 4190 parameter input clamp voltage. All inputs, input load current, STSTB, D2 and DG, do, D, D4, D5, and D. All other inputs, input leakage current, STSTB, DB. Our other inputs, input threshold voltage, all inputs power supply current, output low voltage, D0, D7. All other outputs, output high voltage, D. All other outputs, short circuit current, R outputs, off-state output current, or control outputs, capacitance. This parameter is periodically sampled and not 100% tested. Limits, symbol parameter minimum. Type 2 max. Unit, CLNCUT, intercurrent, LNT. Note 1, typical values are for T equals 25 degrees Celsius and nominal supply voltages. Input capacitance, output capacitance control signals. Note 2, for D0, D7, R1 equals 4K, H, R2 equals C equals 25 PF. For all other outputs, RL equals 500 H, R2 equals 1K, H, C equals 100 PF. A, capital O, 12 PF 715 PF. IO, test contions, VGT is equals 2.5 V, VCC equals 5.0 V, T equals 25 degrees Celsius. F equals 1 MHz. IO capacitance. dB 15 PF. IVIN unit test conditions. VVCC equals 4.75 V. LC equals minus 5 mA. HAVCC equals 5.25 V. Dua VP equals 0.45 VHA. HAVCC equals 5.25 VA. VP equals 5.25 VA. VVCC 5 V. MA VCC equals 5.25 V. VVCC equals 4.75 V. IL equals 2 mA. V lot equals 10 mA. VVCC equals 4.75 V. Low equals minus 10 tar. 0.8, 0.63.82.4, 5, V90 mA, 00 Dua minus 100, UA 5 mA, low equals TMA VCC equals 5 V, VCC equals 5.25 V, VO equals 5.25 VO equals 0.45 V, see figure below, minus 11, 45.45, NTA test circuit, for RST7. 33. Schottky bipolar 8224. Tank. OSC. TTL. RDYM. Resin 0. 12V. 0. INT. Int. 5. DB. DBI. DB. DB3. DB. DB. DBG. DBY. 6. 5V. 5V. Plus 12V. System DMAREO. System INT. Rec. INT. Enable XTAL15 8080 CPU IA a 4 as AA as a 9 a 12A14 WRDBI NHTLA address bus GND up A 1282244423 710 clock generator driver 1 4 wait ready 228 BL directional bus driver 5V5196A GND 3. 8080 CPU standard interface. 2. 6419521 status strobe, MEMW control bus 25, semicolon I, or IOLIV, 17. Contents, scope, conformance. Point 1 example normative optional clause heading. Point 2 example legacy clause heading. Point 3 example legacy normative optional clause heading. Page, normative references. Overview. Point 1 web scripting. Point 2 hosts and implementations. Point 3 ECMAScript overview. Point 4 terms and definitions. Point 5 organization of this specification. Notational conventions. Point 1 syntactic and lexical grammars. Point 2 algorithm conventions. ECMAScript data types and values. Point 1 ECMAScript language types. Point 2 ECMAScript specification types. Abstract operations. Point 1 type conversion. Point 2 testing and comparison operations. Point 3 operations on objects. Point 4 operations on iterator objects. Syntax directed operations. Point 1 runtime semantics. Evaluation. Point 2 scope analysis. Point 3 labels. Point 4 function name inference. Point 5 contains. Point 6 miscellaneous. Dot, 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 dot. 1. 1122. 2.11 clear kept objects. 0.12 add to kept objects. Value. 0.13 cleanup finalization registry. Finalization registry. 0.14 can be held weekly. V0 ordinary and exotic objects behaviors. 0.1 ordinary object internal methods and internal slots. 0.2 ECMAScript function objects. 0.3 built-in function objects. 0.4 built-in exotic object internal methods and slots. 0.5 proxy object internal methods and internal slots. 1 ECMAScript language. Source text. 1.1 source text. 1.2 types of source code. Dot, dot, dot. ECMA International 2024. I. Dot, 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 dot. 11. Dot. 11 11 19. 25 25 51. 62 62 72 77 87. 90 90.91 110 118 123 126. 134 134 152 152 154 157 160 160 162 163 164 166 167 167 167 167 167 167 175 184 186 203 213 213 215 Executable code and execution contexts. Point 1 environment records. Point 2 private environment records. Point 3 realms. Point 4 execution contexts. Point 5 jobs and host operations to enqueue jobs. Point 6 initialize host defined realm. Point 7 agents. Point 8 agent clusters. Point 9 forward progress. Point 10 processing model of weak ref and finalization registry targets. Dot. Dot. 23346. 2. ECMA International 2024. 2 ECMAScript language. Lexical grammar. Dot. 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 Comma 300. 2.1 Unicode format control characters. 2.2 white space. 2.3 line terminators. 2.4 comments. 2.5 hashbang comments. 2.6 tokens. 2.7 names and keywords. 2.8 punctuators. 2.9 literals. 2.10 automatic semicolon insertion. 3 ECMAScript language. Expressions. Dot. Dot. 243 243 245 258 269 271 273 274 274 275 276 278 279 280 281 282 291 3.1 identifiers 3.2 primary expression 3.3 left-hand side expressions. 3.4 update expressions, 3.5 unary operators, 3.6 exponentiation operator, 3.7 multiplicative operators, 3.8 additive operators, 3.9 bitwise shift operators, 3.10 relational operators, 3.11 equality operators, 3.12 binary bitwise operators, 3.13 binary logical operators, 3.14 conditional operator, 3.15 assignment operators, 3.16 comma operator, 4 ECMAScript language, statements and declarations, 291, 292, 292, 294, 299, 299, 299, 4.1 statement semantics, 4.2 block, 4.3 declarations in the variable statement, 4.4 empty statement, 4.5 expression statement, 4.6 the if statement, 4.7 iteration statements, 4.8 the continue statement, 313, 313, 314, 314, 315, 318, 320, 320, 322. 322, 322, 327, 330, 332, 335, 339, 342, 353, 356, 358. 364, 364, 367, 4.9 the break statement, 4.10 the return statement, 4.11 the with statement, 4.12 the switch statement, 4.13 labeled statements, 4.14 the throw statement, 4.15 the try statement, 4.16 the debugger statement, 5 ECMAScript language. Functions and classes, 5.1 parameter lists, 5.2 function definitions, 5.3 arrow function definitions, 5.4 method definitions, 5.5 generator function definitions, 5.6 async generator function definitions, 5.7 class definitions, 5.8 async function definitions, 5.9 async arrow function definitions, 5.10 tail position calls, 6 ECMAScript language. Scripts and modules, 6.1 scripts, 6.2 modules, 17 error handling and language extensions, 17.1 forbidden extensions, 8 ECMAScript standard built-in objects, 9 the global object, 9.1 value properties of the global object, 9.2 function properties of the global object, 9.3 constructor properties of the global object, 9.4 other properties of the global object, 0 fundamental objects, 0.1 objects, 0.2 function objects, 0.3 Boolean objects, 0.4 symbol objects, 0.5 error objects, 1 numbers and dates, 402, 403, 404, 405, 405, 406, 414, 417, 417, 417, 426, 432, 434, 438, 453, 464, 494, 494, 513, 567, 567, 596, Dart 620, 620, 626, 631, 634, 637, 637, 647, 654, 661, 672, Dart 680, 680, 682, 684, 684, 690, 707, 709, 711, 716, 722, Dart 725, 725, 728, 729, 729, 729, 731, 731, 732 732 1.1 number objects 1.2 big int objects 1.3 the math object 1.4 date objects 2 text processing 2.1 string objects 2.2 regexp regular expression objects 3 indexed collections 3.1 array objects 3.2 typed array objects 4 keyed collections 4.1 map objects 4.2 set objects 4.3 weak map objects 4.4 weak set objects 5 structured data 5.1 array buffer objects 5.2 shared array buffer objects 5.3 data view objects 5.4 the atomics object 5.5 the JSON object full stop 6 managing memory 6.1 weak ref objects 6.2 finalization registry objects 7 control abstraction objects 7.1 iteration 7.2 promise objects 7.3 generator function objects 7.4 async generator function objects 7.5 generator objects 7.6 async generator objects 7.7 async function objects 8 reflection 8.1 the reflect object 8.2 proxy objects 8.3 module namespace objects 9 memory model 9.1 memory model fundamentals 9.2 agent events records 9.3 chosen value records 9.4 candidate executions 9.5 abstract operations for the memory model ECMA International 2024 3 dot 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 29.6 relations of candidate executions 734 9.7 properties of valid executions 735 9.8 races 737 9.9 data races 738 9.10 data race freedom 738 9.11 shared memory guidelines 738 Annex A informative grammar summary 741 Annex A 1 lexical grammar Dart 741 Annex A 2 expressions 748 Annex A 3 statements Dart 754 Annex A 4 functions and classes 758 Annex A 5 scripts and modules Dart 761 Annex A 6 number conversions 762 Annex A 7 time zone offset string format Dart 763 Annex A 8 regular expressions 764 Annex B normative additional ECMAScript features for web browsers 769 Annex B 1 additional syntax Dart 769 Annex B 2 additional built in properties 775 Annex B 3 other additional features Dart 781 Annex C informative the strict mode of ECMAScript 789 Annex D informative host layering points 791 Annex D 1 host hooks Dart 791 Annex D 2 host defined fields 791 Annex D 3 host defined objects 791 Annex D 4 running jobs 792 Annex D 5 internal methods of exotic objects 792 Annex D 6 built in objects and methods 792 Annex E informative corrections and clarifications in ECMAScript 2015 with possible compatibility impacts 793 Annex F informative additions and changes that introduce incompatibilities with prior editions 795 Carla Farn, 799 Bibliography 801 Copyright and Software License Dart 803 IVE Copyright Sign ECMA International 2024 Introduction This ECMA standard defines the ECMAScript 2024 language. It is the 15th edition of the ECMAScript language specification. Since publication of the first edition in 1997, ECMAScript has grown to be one of the world's most widely used general-purpose programming languages. It is best known as the language embedded in web browsers but has also been widely adopted for server and embedded applications. ECMAScript is based on several originating technologies, the most well-known being JavaScript, Netscape, and JScript, Microsoft. The language was invented by Brendan Eich at Netscape and first appeared in the company's Navigator 2.0 browser. It has appeared in all subsequent browsers from Netscape and in all browsers from Microsoft starting with Internet Explorer 3.0. The development of the ECMAScript language specification started in November 1996. The first edition of this ECMA standard was adopted by the ECMA General Assembly of June 1997. That ECMA standard was submitted to ISO IEC JTC1 for adoption under the fast-track procedure and approved as International Standard ISO IEC 16262 in April 1998. The ECMA General Assembly of June 1998 approved the second edition of ECMA 262 to keep it fully aligned with ISO IEC 16262. Changes between the first and the second edition are editorial in nature. The third edition of the standard introduced powerful regular expressions, better string handling, new control statements, try-catch exception handling, tighter definition of errors, formatting for numeric output and minor changes in anticipation of future language growth. The third edition of the ECMAScript standard was adopted by the ECMA General Assembly of December 1999 and published as ISO IEC 16262, 2002 in June 2002. After publication of the third edition, ECMAScript achieved massive adoption in conjunction with the World Wide Web, where it has become the programming language that is supported by essentially all web browsers. Significant work was done to develop a fourth edition of ECMAScript. However, that work was not completed and not published as the fourth edition of ECMAScript, but some of it was incorporated into the development of the sixth edition. The fifth edition of ECMAScript, published as ECMA 262 fifth edition, codified de facto interpretations of the language specification that had become common among browser implementations and added support for new features that had emerged since the publication of the third edition. Such features include accessor properties, reflective creation and inspection of objects, program control of property attributes, additional array manipulation functions, support for the JSON object encoding format, and a strict mode that provides enhanced error checking and program security. The fifth edition was adopted by the ECMA General Assembly of December 2009. The fifth edition was submitted to ISO IEC JTC1 for adoption under the fast-track procedure and approved as International Standard ISO IEC 16262, 2011. Edition 5.1 of the ECMAScript standard incorporated minor corrections and is the same text as ISO IEC 16262, 2011. The 5.1 edition was adopted by the ECMA General Assembly of June 2011. Focused development of the sixth edition started in 2009, as the fifth edition was being prepared for publication. However, this was preceded by significant experimentation and language enhancement design efforts dating to the publication of the third edition in 1999. In a very real sense, the completion of the sixth edition is the culmination of a 15-year effort. The goals for this edition included providing better support for large applications, library creation, and for use of ECMAScript as a compilation target for other languages. Some of its major enhancements included modules, class declarations, lexical block scoping, iterators and generators, promises for asynchronous programming, destructuring patterns, and proper tail calls. The ECMAScript library of built-ins was expanded to support additional data abstractions including maps, sets, and arrays of binary numeric values, as well as additional support for Unicode supplementary characters in strings and regular expressions. The built-ins were also made extensible via subclassing. The sixth edition provides the foundation for regular, incremental language and library enhancements. The sixth edition was adopted by the General Assembly of June 2015. ECMAScript 2016 was the first ECMAScript edition released under ECMA TC39's new yearly release cadence and open development process. A plain text source document was built from the ECMAScript 2015 source document to serve as the base for further development entirely on GitHub. Over the year of this standard's development, hundreds of pull requests and issues were filed representing thousands of bug fixes, editorial fixes and other ECMA International 2024 Volt improvements. Additionally, numerous software tools were developed to aid in this effort, including ECMARkup, ECMARkdown, and grammarkdown. ES 2016 also included support for a new exponentiation operator and adds a new method to array prototype called includes. ECMAScript 2017 introduced async functions, shared memory, and atomics along with smaller language and library enhancements, bug fixes, and editorial updates. Async functions improve the asynchronous programming experience by providing syntax for promise-returning functions. Shared memory and atomics introduce a new memory model that allows multi-agent programs to communicate using atomic operations that ensure a well-defined execution order even on parallel CPU. It also included new static methods on object values, object entries, and object getOwn property descriptors. ECMAScript 2018 introduced support for asynchronous iteration via the async iterator protocol and async generators. It also included 4 new regular expression features: the dot or flag, named capture groups, Unicode property escapes, and look behind assertions. Lastly, it included object rest and spread properties. ECMAScript 2019 introduced a few new built-in functions: flat and flat map on array prototype for flattening arrays, object from entries for directly turning the return value of object entries into a new object, and trim start and trim end on string prototype as better named alternatives to the widely implemented but non-standard string prototype trim left and trim right built-ins. In addition, it included a few minor updates to syntax and semantics. Updated syntax included optional catch binding parameters and allowing U+ 2028 line separator and U+ 2029 paragraph separator in string literals to align with JSON. Other updates included requiring that array prototype sort be a stable sort, requiring that JSON string if I return well-formed UTF-8 regardless of input, and clarifying function prototype to string by requiring that it either return the corresponding original source text or a standard placeholder. ECMAScript 2020, the 11th edition, introduced the match or method for strings to produce an iterator for all match objects generated by a global regular expression, import, a syntax to asynchronously import modules with a dynamic specifier, bigint, a new number primitive for working with arbitrary precision integers, promise all settled, a new promise combinator that does not short-circuit, global this, a universal way to access the global this value, dedicated exporters ns from modular syntax for us within modules, increased standardization of for an enumeration order, import meter, a host populated object available in modules that may contain contextual information about the module, as well as adding 2 new syntax features to improve working with nullish values, undefined or null, nullish coalescing, a value selection operator, and optional chaining, a property access and function invocation operator that short circuits if the value to access invoke is nullish. ECMAScript 2021, the 12th edition, introduced the replace all method for strings, promise any, a promise combinator that short-circuits when an input value is fulfilled, aggregate error, a new error type to represent multiple errors at once, logical assignment operators equals, and equals, weak ref, for referring to a target object without preserving it from garbage collection, and finalization registry, to manage registration and registration of cleanup operations performed when target objects are garbage collected, separators for numeric literals, 1000, and array prototype sort was made more precise, reducing the amount of cases that result in an implementity on defined sort order. ECMAScript 2022, the 13th edition, introduced top-level await, allowing the keyword to be used at the top level of modules, new class elements, public and private instance fields, public and private static fields, private instance methods and accessors, and private static methods and accessors, static blocks inside classes, to perform per class evaluation initialization, the X and OBJ syntax, to test for presence of private fields on objects. Regular expression match indices via the D flag, which provides start and end indices for matched substrings, the cause property on error objects, which can be used to record a causation chain in errors, the it method for strings, arrays, and typed arrays, which allows relative indexing, and object has own, a convenient alternative to object prototype his own property. ECMAScript 2023, the 14th edition, introduced the to sorted, to reversed, with find last, and find last index methods on array prototype and typed array prototype, as well as the to spliced method on array prototype. Added support for comments at the beginning of files to better facilitate executable ECMAScript files, and allowed the use of most symbols as keys in weak collections. V. Copyright sign, ECMA International 2024, ECMAScript 2024, the 15th edition, added facilities for resizing and transferring array buffers and shared array buffers, added a new regexpv flag for creating regexps with more advanced features for working with sets of strings, and introduced the promise with resolve as convenience method for constructing promises, the object group by and map group by methods for aggregating data, the atomics wait async method for asynchronously waiting for a change to shared memory, and the string prototype as well-formed and string prototype to well-formed methods for checking and ensuring that strings contain only well-formed Unicode. Dozens of individuals representing many organizations have made very significant contributions within ECMA TC39 to the development of this edition and to the prior editions. In addition, a vibrant community has emerged supporting TC39's ECMAScript efforts. This community has reviewed numerous drafts, filed thousands of bug reports, performed implementation experiments, contributed test suites, and educated the worldwide developer community about ECMAScript. Unfortunately, it is impossible to identify and acknowledge every person and organization who has contributed to this effort. Alan Worfs-Brock, ECMA 262, Project Editor, 6th edition. Brian Telson, ECMA 262, Project Editor, 7th through 10th editions. Jordan Harband, ECMA 262, Project Editor, 10th through 12th editions. Shuyugwo, ECMA 262, Project Editor, 12th through 15th editions. Michael Ficara, ECMA 262, Project Editor, 12th through 15th editions. Kevin Gibbons, ECMA 262, Project Editor, 12th through 15th editions. ECMA International 2024-7. About this specification, the document at https://tc39.es/ECMARTIS62/ is the most accurate and up-to-date ECMAScript specification. It contains the content of the most recent yearly snapshot plus any finished proposals. https://github.com/tc39/proposals blobhead finished proposals MD. Those that have reached stage 4 in the proposal process. https://tc39.es/process document, and thus are implemented in several implementations and will be in the next practical revision since that snapshot was taken. This document is available as a single page and as multiple pages. Contributing to this specification is developed on GitHub with the help of the ECMAScript community. There are a number of ways to contribute to the development of this specification. GitHub repository, https://github.com/tc39/ECMARTIS62. Issues, all issues, https://github.com/tc39/ECMARTIS62/issues. File a new issue, https://github.com/tc39/ECMA262/issues new. Pull requests, all pull requests, https://github.com/tc39/ECMARTIS62/pulls. Create a new pull request, https://github.com/tc39/ECMARTIS62/pulls/new. Test suite, test 262, https://github.com/tc39//test /test262 editors shuyugwo at shu https://twitter.com/_shu Michael Ficara at smooshmap https://twitter.com/smooshmap Kevin Gibbons at backcoating https://twitter.com/backcoating community discourse https://es.discourse.group https://es.discourse.group chat matrix https://github.com/tc39/how-we-work/blob/head/matrix-guide.md mailing list archives https://isdiscus.org/refer to the Carlophon for more information on how this document is created. 8. Copyright sign ECMA International 2024. Copyright Notice 2024 ECMA International. This document may be copied, published and distributed to others, and certain derivative works of it may be prepared, copied, published, and distributed, in whole or in part, provided that the above copyright notice and this copyright license and disclaimer are included on all such copies and derivative works. The only derivative works that are permissible under this copyright license and disclaimer are I. Works which incorporate all or portion of this document for the purpose of providing commentary or explanation, such as an annotated version of the document. 2. Works which incorporate all or portion of this document for the purpose of incorporating features that provide accessibility. 3. Translations of this document into languages other than English and into different formats. And 5. Works by making use of this specification in standard conformant products by implementing, for example by copy and paste wholly or partly, the functionality therein. However, the content of this document itself may not be modified in any way, including by removing the copyright notice or references to ECMA International, except as required to translate it into languages other than English or into a different format. The official version of an ECMA International document is the English language version on the ECMA International website. In the event of discrepancy between a translated version and the official version shall govern. The limited permissions granted above are perpetual and will not be revoked by ECMA International or its successors or assigns. This document and the information contained herein is provided on an as-is basis, and ECMA International disclaims all warranties, express or implied, including but not limited to any warranty that the use of the information herein will not infringe any ownership rights or any implied warranties of merchantability or fitness for a particular purpose. ECMA International 2024-9 ECMAScript Registered Sign 2024 Language Specification Scope. This standard defines the ECMAScript 2024 General Purpose Programming Language to conformance. A conforming implementation of ECMAScript must provide and support all the types, values, objects, properties, functions, and program syntax and semantics described in this specification. A conforming implementation of ECMAScript must interpret source text input in conformance with the latest version of the Unicode standard and ISO IEC 10646. A conforming implementation of ECMAScript that provides an application programming interface API, that's up. Ports programs that need to adapt to the linguistic and cultural conventions used by different human languages and countries must implement the interface defined by the most recent edition of ECMA 402 that is compatible with this specification. A conforming implementation of ECMAScript may provide additional types, values, objects, properties, and functions beyond those described in this specification. In particular, a conforming implementation of ECMAScript may provide properties not described in this specification, and values for those properties. For objects that are described in this specification, a conforming implementation of ECMAScript may support program and regular expression syntax not described in this specification. In particular, a conforming implementation of ECMAScript may support program syntax that makes use of any future reserved words noted in subclause 1.2.7 2 of this specification, a conforming implementation of ECMAScript must not implement any extension that is listed as a forbidden extension in subclause 17.1. A conforming implementation of ECMAScript must not redefine any facilities that are not implementation defined, implementation approximated, or host defined. A conforming implementation of ECMAScript may choose to implement or not implement normative optional subclauses. If any normative optional behavior is implemented, all of the behavior in the containing normative optional clause must be implemented. A normative optional clause is denoted in this specification with the words normative optional in a colored box, as shown below. A conforming implementation of ECMAScript must implement legacy subclauses, unless they are also marked as normative optional. All of the language features and behaviors specified within legacy subclauses have one or more undesirable characteristics. However, their continued usage in existing applications prevents their removal from this specification. These features are not considered part of the core ECMAScript language. Programmers should not use or assume these features and
I realize I have to go back through all the files I've done.
legacy clause.
There's lots of places where
Sample clause contents, normative references.
it looks like this in the editor, whatever, is commented out because it's like gray or brownish, whatever.
Applies. For undated references.
Between revisions, whatever, I would like
0.
put like 0 or 1, whatever.
Versions /latest ISO IEC 10646 Information Technology Universal Multiple Octet Coded Character Set AUX plus Amendment 1 2005 Amendment 2 2006 Amendment 3 2008 Amendment 4 2008 and additional amendments and corrigenda or successor.
If this is readable, I don't know if it's whatever. So I put like if 0 or 1.
/W
And I misspelled old code here. Is that a OCD? It's whatever, it doesn't matter.
/402
So I did this, whatever, so it would look commented out like this. For like the stuff that I wasn't working on, and the stuff that I was working on, I'd like do this. And then when I do this, like 1 or 1 that's true, but in the preprocess or whatever, it looks like this, so now it's like colored. So I have like I was going through thinking that everything that's grayed out means it's not in use or old code, but really it's just, it's gonna enter anyways if it builds for that mode. So now I gotta go through and put parentheses around, or like if I go through and replace
accessed and certain functions that
if I replace all these 0 1s with 0 or 1s with, I'll just this whatever. If you put parentheses, the compiler or the not compiler, the text editor, it will not comment it out, which is what I need because I have to go back through and find all these spots. So I have to find and replace all of these, whatever, with these. But I can't replace with this because this contains this. So if I open up a file, I could open a file the second time, not know if I replaced it. And if I replace this with this, because I'm looking for this, then I'll get this, whatever. And that's just really annoying to read.
Any different environment.
So I'm gonna have to like go through and replace all of these
It provides.
with something like this, because this is it's 2025, the year is 2025, and programming is done in text editors with text, you know. It's like building with sand. It's like the most primitive form of doing anything. It's like writing by hand. It is painstakingly, I'm gonna just do this now, but if I replace everything with this, but first I have to check to make sure I'm not using this exactly, because if I'm already doing this somewhere, then I won't be able to tell what I tagged and what I didn't tag, because when I'm all done, I want to replace it back to this so it's more readable, so I know what the code that I'm most likely working with, and then as I go through, I can like turn it on and off. So like if I'm working on code and I'm like, oh, this is actually in use because of the mode I toggled, I can turn it on or I can turn it off. And it's sprinkled out throughout the whole freaking my god, it's so freaking annoying. This is gonna take up more time to just freaking, yeah. So I already started replacing this now. And I have to, or I should undo that. I'm just gonna undo the files that I was just doing, because I have to look first to see if anywhere has this on all the files. And if it's not anywhere, whatever, then I'm good to use this. But if I am using this, then I'll have to like add another space or something in some way that doesn't conflict with this, or this is just annoying as hell. So I'm gonna have to whatever. I have to go through all the old files first, because I don't want to do more files that I then have to deal with. I can just tag maybe all the new files with a new tag. I'm gonna do that so I can like try to get the rest of these, and I'll just account for this new stuff, and then I'll find the old stuff later and go back through and this sucks. I'm just gonna do something. This is just stupid. I hate. Why the fuck do we program with text editors? 3D CAD, they moved from like designing things from paper to 3D modeling in the computer, and then text editing. We still use text editors. Like, what the fuck? So I'm gonna do whatever, I don't know, I'm just gonna make a decision, so I'm gonna be back. This is just annoying. Either way, it's gonna take me like an hour and a half to like get to where I am at, because I have to backtrack. I'll be back.
Which allow obtaining input and providing output as host-defined properties of the global object. This specification follows the editorial convention of always using the most specific term. For example, if a facility is host-defined, It should not be referred to as implementation defined. Both hosts and implementations may interface with this specification via the language types, specification types, abstract operations, grammar productions, intrinsic objects, and intrinsic symbols defined herein. Point 3 ECMAScript Overview. The following is an informal overview of ECMAScript. Not all parts of the language are described. This overview is not part of the standard proper. ECMAScript is object-based. Basic language and host facilities are provided by objects, and an ECMAScript program is a cluster of communicating objects. In ECMAScript, an object is a collection of 0 or more properties, each with attributes that determine how each property can be used. For example, when the writable attribute for a property is set to false, any attempt by executed ECMAScript code to assign a different value to the property fails. Properties are containers that hold other objects, primitive values, or functions. A primitive value is a member of one of the following built-in types: undefined, null, boolean, number, big int, string, and symbol. An object is a member of the built-in type object, and a function is a callable object. A function that is associated with an object via a property is called a method. ECMAScript defines a collection of built-in objects that round out the definition of ECMAScript entities. These built-in objects include the global object, objects that are fundamental to the runtime semantics of the language, including object, function, boolean, symbol, and various error objects, objects that represent and manipulate numeric values including math, number, and 8, the text processing objects string and regexp, objects that are indexed collections of values including array and 9 different kinds of typed arrays whose elements all have a specific numeric data representation, keyed collections including map and set objects, objects supporting structured data including the JSON object, array buffer, shared array buffer, and data view. Objects supporting control abstractions including generator functions and promise objects, and reflection objects including proxy and reflect. ECMAScript also defines a set of built-in operators. ECMAScript operators include various unary operations, multiplicative operators, additive operators, bitwise shift operators, relational operators, equality operators, binary bitwise operators, binary logical operators, assignment operators, and the comma operator. Large ECMAScript programs are supported by modules which allow a program to be divided into multiple sequences of statements and declarations. Each module explicitly identifies declarations it uses that need to be provided by other modules and which of its declarations are available for use by other modules. ECMAScript syntax intentionally resembles Java syntax. ECMAScript syntax is relaxed to enable it to serve as an easy-to-use scripting language. For example, a variable is not required to have its type declared nor a types associated with properties, and defined functions are not required to have their declarations appear textually before calls to them. 3.1 Objects. Even though ECMAScript includes syntax for class definitions, ECMAScript objects are not fundamentally class-based such as those in C++, Smalltalk, or Java. Instead, objects may be created in various ways including via a literal notation or via constructors which create objects and then execute code that initializes all or part of them by assigning initial values to their properties. Each constructor is a function that has a property named prototype that is used to implement prototype-based inheritance and shared properties. Objects are created by using constructors in new expressions. For example, new date, 2009, 11, creates a new date object. Invoke copyright sign, ECMA International 2024. A constructor without using new has consequences that depend on the constructor. For example, date produces a string representation of the current date and time rather than an object. Every object created by a constructor has an implicit reference, called the object's prototype, to the value of its constructor's prototype property. Furthermore, a prototype may have a non-null implicit reference to its prototype, and so on. This is called the prototype chain. One reference is made to a property in an object that references to the property of that name in the first object in the prototype chain that contains a property of that name. In other words, first the object mentioned directly is examined for such a property. If that object contains the named property, that is the property to which the reference refers. If that object does not contain the named property, the prototype for that object is examined next, and so on. Figure 1. Object prototype relationships. CF. Prototype P1, P2. Implicit prototype link. Explicit prototype property. CFP. CFP1. CF1. Q1, Q2. CF2. Q1, Q2. CF3. Q1, Q2. CF4. Q1, Q2. CF5. Q1, Q2. In a class-based object-oriented language, in general, state is carried by instances, methods are carried by classes, and inheritance is only of structure and behavior. In ECMAScript, the state and methods are carried by objects, while structure, behavior, and state are all inherited, or objects that do not directly contain a particular property that their prototype contains share that property and its value. Figure 1 illustrates this. CF is a constructor and also an object. 5 objects have been created by using new expressions: CF1, CF2, CF3, CF4, and CF5. Each of these objects contains properties named Q1 and Q2. The dashed lines represent the implicit prototype relationship. So, for example, CF3's prototype is CFP. The constructor, CF, has 2 properties itself, named P1 and P2, which are not visible to CFP, CF1, CF2, CF3, CF4, or CF5. The property named CFP1 in CFP is shared by CF1, CF2, CF3, CF4, and CF5, but not by CF, as are any properties found in CFP's implicit prototype chain that are not named Q1, Q2, or CFP1. Notice that there is no implicit prototype link between CF and CFP. Unlike most class-based object languages, properties can be added to objects dynamically by assigning values to them. That is, constructors are not required to name or assign values to all or any of the constructed object's properties. In the above diagram, one could add a new shared property for CF1, CF2, CF3, CF4, and CF5 by assigning a new value to the property in CFP. Although ECMAScript objects are not inherently class-based, it is often convenient to define class-like abstractions based upon a common pattern of constructor functions, prototype objects, and methods. The ECMAScript built-in objects themselves follow such a class-like pattern. Beginning with ECMAScript 2015, the ECMAScript language includes syntactic class definitions that permit programmers to concisely define objects that conform to the same class-like abstraction pattern used by the built-in objects. ECMA International 2024 5.4.3 to the strict variant of ECMAScript. The ECMAScript language recognizes the possibility that some users of the language may wish to restrict their usage of some features available in the language. They might do so in the interests of security, to avoid what they consider to be error-prone features, to get enhanced error checking, or for other reasons of their choosing. In support of this possibility, ECMAScript defines a strict variant of the language. The strict variant of the language excludes some specific syntactic and semantic features of the regular ECMAScript language and modifies the detailed semantics of some features. The strict variant also specifies additional error conditions that must be reported by throwing error exceptions in situations that are not specified as errors by the non-strict form of the language. The strict variant of ECMAScript is commonly referred to as the strict mode of the language. Strict mode selection and use of the strict mode syntax and semantics of ECMAScript is explicitly made at the level of individual ECMAScript source text units as described in 1.1.2.2. Because strict mode is selected at the level of a syntactic source text unit, strict mode only imposes restrictions that have local effect within such a source text unit. Strict mode does not restrict or modify any aspect of the ECMAScript semantics that must operate consistently across multiple source text units. A complete ECMAScript program may be composed of both strict mode and non-strict mode ECMAScript source text units. In this case, Strict mode only applies when actually executing code that is defined within a strict mode source text unit. In order to conform to this specification, an ECMAScript implementation must implement both the full unrestricted ECMAScript language and the strict variant of the ECMAScript languages defined by the specification. In addition, an implementation must support the combination of unrestricted and strict mode source text units into a single composite program. Point 4 Terms and definitions. For the purposes of this document, the following terms and definitions apply. 4.1 Implementation approximated. An implementation approximated facility is defined in whole or in part by an external source but has a recommended ideal behavior in this specification. 4.2 Implementation defined. An implementation defined facility is defined in whole or in part by an external source to this specification. 4.3 Host defined. Same as implementation defined. Note editorially. See clause 4.2, 4.4 Type. Set of data values as defined in clause 6.4.4.5 Primitive value. Member of one of the types undefined. Null, boolean, number, big int, symbol, or string is defined in clause 6. Note a primitive value is a datum that is represented directly at the lowest level of the language implementation. Copyright sign, ECMA Internet, INL 2024. 4.6 Object. Member of the type object. Note an object is a collection of properties and has a single prototype object. The prototype may be null. 4.7 Constructor. Function object that creates and initializes objects. 4.8 Prototype. Object that provides shared properties for other objects. 4.9 Ordinary object. Object that has the default behavior for the essential internal methods that must be supported by all objects. 4.10 Exotic object. Object that does not have the default behavior for one or more of the essential internal methods. Note any object that is not an ordinary object is an exotic object. The 4th of April 2011 standard object. Object whose semantics are defined by the specification. 4.12 Built-in object. Object specified and supplied by an ECMAScript implementation. 4.13 Undefined value. Primitive value used when a variable has not been assigned a value. Note the value of a constructor's prototype property is a prototype object that is used to implement inheritance and shared properties. Note when a constructor creates an object, that object implicitly references the constructor's prototype property for the purpose of resolving property references. The constructor's prototype property can be referenced by the program expression constructor prototype, and properties added to an object's prototype are shared, through inheritance, by all objects sharing the prototype. Alternatively, a new object may be created with an explicitly specified prototype by using the object create built-in function. Note standard built-in objects are defined in this specification. An ECMAScript implementation may specify and supply additional kinds of built-in objects. ECMA International 2024-7. The 4th of April 2014 Undefined type. Type whose sole value is the undefined value. 4.15 Null value. Primitive value that represents the intentional absence of any object value. 4.16 Null type. Type whose sole value is the null value. 4.17 Boolean value. Member of the Boolean type. Note there are only two Boolean values. True and false. 4.18 Boolean type. Type consisting of the primitive values true and false. The 4th of April 2019 Boolean object. Member of the object type that is an instance of the standard built-in Boolean constructor. 4.20 String value. Primitive value that is a finite ordered sequence of 0 or more 16-bit unsigned integer values. 4.21 String type. Set of all possible string values. 4.22 String object. Member of the object type that is an instance of the standard built-in string constructor. A Boolean object is created by using the Boolean constructor in a new expression, supplying a note Boolean value as an argument. The resulting object has an internal slot whose value is the Boolean value. A Boolean object can be coerced to a Boolean value. Note a string value is a member of the string type. Each integer value in the sequence usually represents a single 16-bit unit of UTF-16 text. However, ECMAScript does not place any restrictions or requirements on the values except that they must be 16-bit unsigned integers. A string object is created by using the string constructor in a new expression, supplying a string note value as an argument. The resulting object has an internal slot whose value is the string value. Capital A, string object can be coerced to a string value by calling the string constructor as a function. 221111. Copyright sign, ECMA International 2024. The 4th of April 2023 number value. Primitive value corresponding to a double precision 64-bit binary format, i.e. E7542019. Value. Note: a number value is a member of the number type and is a direct representation of a number. 4.24 number type. Set of all possible number values including the special not a number. Nan. Value. Positive infinity and negative infinity. 4.25 number object. Member of the object type that is an instance of the standard built-in number constructor. 4.26 infinity. Number value that is the positive infinite number value. 4.27 nan. Number value that is an i.e. EE7542019. Not a number value. The 4th of April 2028 begint value. Primitive value corresponding to an arbitrary precision integer value. The 4th of April 2029 begint type. Set of all possible begint values. 4.30 begint object. Member of the object type that is an instance of the standard built-in begint constructor. The 4th of April 1931 symbol value. Primitive value that represents a unique non-string object property key. The 4th of April 1932 symbol type. Set of all possible symbol values. 4.33 symbol object. Member of the object type that is an instance of the standard built-in symbol constructor. A number object is created by using the number constructor in a new expression, supplying a note number value as an argument. The resulting object has an internal slot whose value is the number value. A number object can be coerced to a number value by calling the number constructor as a function. 211111. ECMA International 2024 9. The 4th of April 1934 function. Member of the object type that may be invoked as a subroutine. 4.35 built-in function. Built-in object that is a function. 4.36 built-in constructor. Built-in function that is a constructor. 4.37 property. Part of an object that associates a key, either a string value or a symbol value, and a value. 4.38 method. Function that is the value of a property. 4.39 built-in method. Method that is a built-in function. 4.40 attribute. Internal value that defines some characteristic of a property. 4.41 own property. Property that is directly contained by its object. Note: in addition to its properties, a function contains executable code and state that determine how it behaves when invoked. A function's code may or may not be written in ECMAScript. Examples of built-in functions include parse, int, and mathexp. A host or implementation may, note, provide additional built-in functions that are not described in this specification. Examples of built-in constructors include object and function. A host or implementation may, note, provide additional built-in constructors that are not described in this specification. Note: depending upon the form of the property, the value may be represented either directly as a data value, a primitive value, an object, or a function object, or indirectly by a pair of accessor functions. Note: when a function is called as a method of an object, the object is passed to the function as its this value. Note: standard built-in methods are defined in this specification. A host or implementation may provide additional built-in methods that are not described in this specification. 0. Copyright sign, ECMA International 2024. The 4th of April 1942 inherited property. Property of an object that is not a known property but is a property either owned or inherited of the object's prototype. 5. Organization of this specification. The remainder of this specification is organized as follows. Clause 5 defines the notational conventions used throughout the specification. Clauses 6 through 10 define the execution environment within which ECMAScript programs operate. Clauses 11 through 17 define the actual ECMAScript programming language, including its syntactic encoding and the execution semantics of all language features. Clauses 18 through 28 define the ECMAScript standard library. They include the definitions of all of the standard objects that are available for use by ECMAScript programs as they execute. Clause 29 describes the memory consistency model of accesses on shared array buffer memory and methods of the atomics object. Notational conventions. 1. Syntactic and lexical grammars. 5. 1. 1. Context-free grammars. A context-free grammar consists of a number of term side.
I need to, that was loud, I freaking adjust the mic. This mouse isn't working.
Namely, the, perhaps in
I need to like, man, I'm screwed. I'm so tired of this, it's just annoying as fuck. You should be able to, make a keyword in any file on the operating system, such as unsigned int, like this, whatever. And then you should be able to like take this word, whatever, put it through like, how many files here? Uh, 289 is like, that's like without the older folders. I think there's like 400. Like 289 files, whatever. You should be able to put this like, let's say like 30,000 times or 34,000 times. You should be able to spread this keyword just all over the place in any kind of file, and even in like a folder name. You should be able to use this keyword, and then it should be possible to like right click on it and then do like replace or something with like USC whatever, and then that would be beautiful. That would save me so much headache, time, if I didn't have to go through and find like 34,000 fucking places to update a goddamn program from 32-bit to 64-bit. That'd be great if you could just, that existed. It's 2025. Why doesn't that exist, you know? You would think, like, this is so stupid. Alright, so I'm gonna shut up and, get to replacing, I guess, again. After I run out of things to crack. I'm out of things to crack. This sucks. So I'm gonna like replace the files I was working on the same way as I did the rest of them, the wrong way. Just so it's I'm not gonna worry about, I'm gonna just tag things as in the gray as the commented out whatever is with the other tag, even though I know it's wrong. I'm not gonna bother to check yet. And then after I get these files, I'm like save a big backup, and then I will open all the files that have the comment keyword that I'm using, because I have like a it's like this, whatever, where it's in use. It's like this in a comment. So when I go through again later, I know which ones I'm using and which ones are a comment. Because it's all about saving time when you have to build with pieces of sand. You know, every character is a piece of sand. In a text editor, each of these is a small piece of sand, and you make things with these small pieces of sand. You make really large programs with characters that are static. They're not mutable, they're not tracked, they're just stored to a plain text file. You have hundreds of files, and when you want to change them, you have to change hundreds of files. It's a genius. This is like the best way. I love programming. This is so much fun. I'm having the best of my life. I don't regret anything. Other than that, I didn't tag things like this to start with. But even if I did, it's still just as miserable to work with, because there's no solution to using text files to write programs. This is stupid as fuck. Okay, so I'm stopping complaining for now, and I'm gonna do this thing. Oh my god, this is so freaking annoying.
Not a complete account of which token sequences are accepted as a correct ECMAScript script or module. Certain additional token sequences are also accepted, namely,
Did I find some music or something? This not gonna be any better. I'm amazed this mic doesn't pick up my heartbeat. It picks up way too much sound.
do not form a valid ECMAScript script or module. For example, this technique is used for object literals and object destructuring patterns. In such cases, a more restrictive supplemental grammar is provided that further restricts the acceptable token sequences. Typically,
I think I'm gonna listen to one song on repeat. So I'm gonna just keep it to myself. So it's why are you listening to the same song over and over and over? So you don't know what I'm listening to, but it's definitely on loop because I'm out of music. I can't find any new music. Nothing's been released lately. I'm kind of dying, so I'm gonna just run out of song till I get tired of it, and then play another song till I get tired of it. I'm running out of songs. I'm getting tired of everything. I'm tired of programming. Just everything's tiring. Anyways, I'm gonna do this now.
terminal symbols. In the ECMAScript grammars, some terminal symbols are shown in fixed-width font. These are to appear in a source text exactly as written. All terminal symbol code points specified in this way are to be understood as the appropriate Unicode code points from the basic Latin block, as opposed to any similar-looking code points from other Unicode ranges. A code point in a terminal symbol cannot be expressed by a Unicode escape sequence in grammars whose terminal symbols are individual Unicode code points, that is, the lexical, regexp, and numeric string grammars, a contiguous run of multiple fixed width code points appearing in a production is a simple shorthand for the same sequence of code points, written as standalone terminal symbols. For example, the production hex integer literal 0x hex digits is a shorthand for hex integer literal 0x hex digits. In contrast, in the syntactic grammar, a contiguous run of fixed width code points is a single terminal symbol. Terminal symbols come in two other forms. In the lexical and regexp grammars, Unicode code points without a conventional printed representation are instead shown in the form ABBREV, where ABBREV is an mnemonic for the code point or set of code points. These forms are defined in Unicode format control characters, white space, and line terminators. In the syntactic grammar, certain terminal symbols, for example identifier name and regular expression literal, are shown in italics, as they refer to the non-terminals of the same name in the lexical grammar. ECMA International 2024 13. 5. 1. 5. 2 non-terminal symbols and productions. Non-terminal symbols are shown in italic type. The definition of a non-terminal, also called a production, is introduced by the name of the non-terminal being defined followed by one or more colons. The number of colons indicates to which grammar the production belongs. One or more alternative right-hand sides for the non-terminal then follow on succeeding lines. For example, the syntactic definition while statement while expression statement states that the non-terminal while statement represents the token while, followed by a left parenthesis token, followed by an expression, followed by a right parenthesis token, followed by a statement. The occurrences of expression and statement are themselves non-terminals. As another example, the syntactic definition argument list, assignment expression, argument list, assignment expression states that an argument list may represent either a single assignment expression or an argument list, followed by a comma, followed by an assignment expression. This definition of argument list is recursive, that is, it is defined in terms of itself. The result is that an argument list may contain any positive number of arguments, separated by commas, where each argument expression is an assignment expression. Such recursive definitions of non-terminals are common. 1, 5, 3 optional symbols. The subscripted suffix opt, which may appear after a terminal or non-terminal, indicates an optional symbol. The alternative containing the optional symbol actually specifies two right-hand sides, one that omits the optional element and one that includes it. This means that variable declaration binding identifier initializer opt is a convenient abbreviation for variable declaration binding identifier initializer, and that for statement for lexical declaration is a convenient abbreviation for statement for lexical declaration for lexical declaration, which in turn is an abbreviation for expression statement, expression statement, expression statement, expression statement, expression statement, expression statement. 4. ECMA International 2024 for statement 4 lexical declaration So, in this example, the non-terminal for statement actually has 4 alternative right-hand sides. 5. 1. 5. For grammatical parameters, a production may be parameterized by a subscripted annotation of the form parameters, which may appear as a suffix to the non-terminal symbol defined by the production. Parameters may be either a single name or a comma-separated list of names. A parameterized production is shorthand for a set of productions defining all combinations of the parameter names, preceded by an underscore, appended to the parameterized non-terminal symbol. This means that statement list, return statement, expression statement is a convenient abbreviation for statement list, return statement, expression statement, statement list return statement, expression statement, and that statement list, return statement, expression statement is an abbreviation for statement list, return statement, expression statement, statement list return statement, expression statement, statement list in, return statement, expression statement, statement list return in, return statement, expression statement. Multiple parameters produce a combinatory number of productions, not all of which are necessarily referenced in a complete grammar. References to non-terminals on the right-hand side of a production can also be parameterized. For example, statement list, return statement, expression statement, plus in ECMA International 2024-15 is equivalent to saying statement list, return statement, expression statement in, and expression statement in is equivalent to statement list, return statement, expression statement. A non-terminal reference may have both a parameter list and an opt suffix. For example, variable declaration binding identifier initializer plus an opt is an abbreviation for variable declaration, binding identifier initializer in. Prefixing a parameter name with on a right-hand side non-terminal reference makes that parameter value dependent upon the occurrence of the parameter name on the reference to the current production's left-hand side symbol. For example, variable declaration in binding identifier initializer in is an abbreviation for variable declaration, binding identifier initializer, variable declaration in, binding identifier initializer in. If a right-hand side alternative is prefixed with plus parameter, that alternative is only available if the named parameter was used in referencing the production's non-terminal symbol. If a right-hand side alternative is prefixed with parameter, that alternative is only available if the named parameter was not used in referencing the production's non-terminal symbol. This means that statement list, return plus return statement, expression statement is an abbreviation for statement list, expression statement. 6. ECMA International 2024. Statement list, return statement list return statement, expression statement, and that statement list, return statement, expression statement is an abbreviation for statement list, return statement, expression statement, statement list return, expression statement, 1, 5, 1 of, when the words 1 of follow the colon.
It might not be as bad as I thought, because I just realized that I haven't been tagging things with the comment keyword this whole time. I don't think. I could double check. I think I've just been tagging them with this keyword, whatever. It's the JavaScript files I was tagging with the comment keyword, because those are like there's maybe like 20 files in HTML that make parts of the program to like output whatever. And I just like finished a couple of those last night, and I got into this and back into the C program. I've been like replacing, and I think only the new stuff I've been tagging with a comment keyword, because I have like a little note that I just found. This is wait to tag until later. So I'm gonna just tag things with a single keyword. I'll do Control F and find the ones that I tagged like an hour ago with the comment keyword, put them back to this keyword, and then none of this is an issue because everything is tagged as questionable. So I'm like really glad that I didn't get ahead of myself. I just thought that I was ahead of myself because I was just getting ahead of myself, but I didn't earlier. I need to like actually read my notes when I make notes, because I don't know why I make a note if I'm not gonna read it. It would probably save me some time. So I don't know. It's not that bad as I thought.
And followed by one or more decimal digits, the first of which is even, or a decimal digit not followed by another decimal digit. Note that when these phrases are used in the syntactic grammar, it may not be possible to unambiguously identify the immediately following token sequence, because determining later tokens requires knowing which lexical goal symbol to use at later positions. As such, when these are used in the syntactic grammar, it is considered an editorial error for a token sequence sec to appear in a look-ahead restriction, including as part of a set of sequences. If the choices of lexical goal symbols to use could change whether or not sec would be a prefix of the resulting token sequence, 1, 5, 8, no line terminator here. If the phrase, no line terminator here, appears in the right-hand side of a production of the syntactic grammar, it indicates that the production is a restricted production. It may not be used if a line terminator occurs in the input stream at the indicated position. For example, the production throw statement, throw, no line terminator here, Expression indicates that the production may not be used if a line terminator occurs in the script between the throw token and the expression, unless the presence of a line terminator is forbidden by a restricted production. Any number of occurrences of line terminator may appear between any two consecutive tokens in the stream of input elements without affecting the syntactic acceptability of the script, 1, 5, 9 but not. The right-hand side of a production may specify that certain expansions are not permitted by using the phrase but not and then indicating the expansions to be excluded. For example, the production identifier name but not reserved word means that the non-terminal identifier may be replaced by any sequence of code points that could replace identifier name provided that the same sequence of code points could not replace reserved word. 8. Copyright sign ECMA International 2024 5 1 5 1 0 Descriptive phrases. Finally, a few non-terminal symbols are described by a descriptive phrase and sans serif type in cases where it would be impractical to list all the alternatives. Source character, any Unicode code point to algorithm conventions. The specification often uses a numbered list to specify steps in an algorithm. These algorithms are used to precisely specify the required semantics of ECMAScript language constructs. The algorithms are not intended to imply the use of any specific implementation technique. In practice, there may be more efficient algorithms available to implement a given feature. Algorithms may be explicitly parameterized with an ordered, comma-separated sequence of alias names which may be used within the algorithm steps to reference the argument passed in that position. Optional parameters are denoted with surrounding brackets, name, and are no different from required parameters within an algorithm.
Now that I tagged whatever, I know they're good. I have to replace each keyword one by one because sometimes int might have like an underscore in case it like defines something weird. So I have to like look at it to make sure like when I do like replace, it's not attached to something else. Otherwise I just replace all in the whole freaking thing. And there's always like one or two spots out of like thousands of lines. But once those like spots get messed up, it's like it's a pain to like find the bug when it happens. So it's better to just go by one, whatever, and then look at it and check as I'm going through. So like when it's like a corner case, I don't hit replace or I like undo and then go past that one. But now I've tagged whatever always with the keyword like I was in the JavaScript files. I can just replace that with the keyword that I was doing for the C files with replace all, and it's saves a lot of time. So that's nice. I'm gonna do that, and I'm gonna find the files that I tagged the wrong way because it's getting ahead of myself, and replace those. And then I don't know, there's like 5,000 maybe of these unsigneds. This is so boring. This is so boring.
Algorithm steps that want to avoid this reference-like behavior should explicitly make a copy of the right-hand side. Let x be a copy of some value creates a shallow copy of some value. Once declared, an alias may be referenced in any subsequent steps and must not be referenced.
I'm only doing this because it's so fast. I can't see. Yeah, let's just shut up. The way they do, I'm just gonna whatever. This is just so much faster.
Algorithms. Abstract operations are typically referenced using a functional application style such ECMA International 2024-19 as operate iron name, arg1, arg2.
This took so long to write in the first place. If I rewrote it again, I could probably make it faster. But I got other stuff I'm doing that this is nothing.
Tax-directed operations. A syntax-directed operation is a named operation whose definition consists of algorithms, each of which is associated with one or more productions from one of the ECMAScript grammars. A production that has multiple alternative definitions will typically have a distinct algorithm for each alternative. When an algorithm is associated with a grammar production, it may reference the terminal and non-terminal symbols of the production alternative as if they were parameters of the algorithm. When used in this manner, non-terminal symbols refer to the actual alternative definition that is matched when parsing the source text. The source text matched by a grammar production or parse node derived from it is the portion of the source text that
This computer is so laggy.
ends at the end of the last terminal that participated in the match. When an algorithm is associated with a production alternative, the alternative is typically shown without any grammar annotations. Such annotations should only affect the syntactic recognition of the alternative and have no effect on the associated semantics for the alternative. Syntax-directed operations are invoked with a parse node and, optionally, other parameters by using the conventions on steps 1, 3, and 4 in the following algorithm. Let status be syntax-directed operation of some non-terminal. Let some parse node be the parse of some source text. Perform syntax-directed operation of some parse node. Perform syntax-directed operation of some parse node with argument value. Unless explicitly specified otherwise, all chain productions have an implicit definition for every operation that might be applied to that production's left-hand side non-terminal. The implicit definition simply reapplies the same operation with the same parameters, if any, to the chain production's sole right-hand side non-terminal and then returns the result. For example, assume that some algorithm has a step of the form, return evaluation of block and that there is a production block statement list, but the evaluation operation does not associate an algorithm with that production. In that case, the evaluation operation implicitly includes an association of the form, runtime semantics, evaluation block, statement list, return evaluation of statement list 5, 2, 3 runtime semantics. Algorithms which specify semantics that must be called at runtime are called runtime semantics. Runtime semantics are defined by abstract operations or syntax-directed operations. 2, 3, 1 completion record. The abstract operation completion takes argument completion record, a completion record, and returns a completion record. It is used to emphasize that a completion record is being returned. It performs the following steps when called. 2. Assert. Completion record is a completion record. Return completion record. 0. ECMA International 2024. 5. 2. 3. To throw an exception. Algorithm steps that say to throw an exception, such as 1. Throw a type error exception, mean the same things as return throw completion, a newly created type error object. 2. 3. 3 return if abrupt. Algorithm steps that say or are otherwise equivalent to 1. Return if abrupt. Argument, mean the same thing as assert. Argument is a completion record. If argument is an abrupt completion, return completion, argument, else. Set argument to argument. Algorithm steps that say or are otherwise equivalent to 1. Return of abrupt. Abstract operation, mean the same thing as let hygienic temp be abstract operation. Assert. Hygienic temp is a completion record. If hygienic temp is an abrupt completion, return completion, hygienic temp, else. Set hygienic temp to hygienic temp, where hygienic temp is ephemeral and visible only in the steps pertaining to return if abrupt. Algorithm steps that say or are otherwise equivalent to let result be abstract operation, return if abrupt. Argument mean the same thing as assert. Argument is a completion record. If argument is an abrupt completion, return completion, argument, else. Set argument to argument. Let result be abstract operation, argument, 2, 3, 4 return of abrupt shorthands, invocations of abstract operations and syntax-directed operations that are prefixed by indicate that return of abrupt should be applied to the resulting completion record. For example, the step ? Operation name is equivalent to the following step, return of abrupt, operation name. Similarly, for method application style, The step $some value operation name ECMA International 2024-21 is equivalent to return of abrupt some value operation name. Similarly, prefix is used to indicate that the following invocation of an abstract or syntax directed operation will never return an abrupt completion and that the resulting completion records field should be used in place of the return value of the operation. For example, the step let val be operation name is equivalent to the following steps. Let val be operation name. Assert val is a normal completion. Set val to val. Syntax-directed operations for runtime semantics make use of this shorthand by placing or before the invocation of the operation. Perform syntax-directed operation of non-terminal 5, 2, 3, 5 implicit normal completion in algorithms within abstract operations which are declared to return a completion record, and within all built-in functions, the returned value is first passed to normal completion, and the result is used instead. This rule does not apply within the completion algorithm or when the value being returned is clearly marked as a completion record in that step. These cases are when the result of applying completion, normal completion, or throw completion is directly returned. When the result of constructing a completion record is directly returned, it is an editorial error if a completion record is returned from such an abstract operation through any other means. For example, within these abstract operations, return true means the same things as any of return normal completion, true, or let completion be normal completion, true, return completion, completion, or return completion record, normal, true, empty. Note that, through the return of abrupt expansion, the following example is allowed, as within the expanded steps. The result of applying completion is returned directly in the abrupt case and the implicit normal completion application occurs after unwrapping in the normal case. Return completion. The following example would be an editorial error because a completion record is being returned without being annotated in that step. 2. Let completion be normal completion. True. Return completion. 2. ECMA International 2024. 5. 2. 4. Static semantics. Context-free grammars are not sufficiently powerful to express all the rules that define whether a stream of input elements form a valid ECMAScript script or module that may be evaluated. In some situations, additional rules are needed that may be expressed using either ECMAScript algorithm conventions or prose requirements. Such rules are always associated with the production of a grammar and are called the static semantics of the production. Static semantic rules have names and typically are defined using an algorithm. Named static semantic rules are associated with grammar productions, and a production that has multiple alternative definitions will typically have for each alternative a distinct algorithm for each applicable named static semantic rule. A special kind of static semantic rule is an early error rule. Early error rules define early error conditions, see clause 17, that are associated with specific grammar productions. Evaluation of most early error rules are not explicitly invoked within the algorithms of this specification. A conforming implementation must, prior to the first evaluation of a script or module, validate all of the early error rules of the productions used to parse that script or module. If any of the early error rules are violated, the script or module is invalid and cannot be evaluated. 2.5 Mathematical operations. This specification makes reference to these kinds of numeric values. Mathematical values. Arbitrary real numbers. Used as the default numeric type. Extended mathematical values. Mathematical values together with plus and numbers, i.e. 754, 2019, double precision floating point NT values. Begins. ECMAScript language values representing arbitrary integers in a one-to-one correspondence. In the language of this specification, numerical values are distinguished among different numeric kinds using subscript suffixes. The subscript refers to numbers, and the subscript Z refers to begins. Numeric values without a subscript suffix refer to mathematical values. Numeric operators such as plus, equals, and refer to those operations as determined by the type of the operands. When applied to mathematical values, the operators refer to the usual mathematical operations. When applied to extended mathematical values, the operators refer to the usual mathematical operations over the extended real numbers. Indeterminate forms are not defined, and their use in this specification should be considered an editorial error. When applied to numbers, the operators refer to the relevant operations within, i.e. EE754-2019. When applied to big ints, the operators refer to the usual.
I'm finally down to 3,344 matches, but there's more folders. Let me check.
Represented by the 4 hexadecimal digits, without explicitly specifying a numeric kind. The phrase refers to a mathematical value. Phrases which refer to a number or a big int value are explicitly annotated as such. For example, the number value for the number of code points in, or the big int value for numeric operators applied to mixed-type operands, such as a number and a mathematical value, are not defined and should be considered an editorial error in this specification. This specification denotes most numeric values in base 10. It also uses numeric values of the form 0x followed by digits 09 or AF as base 16 values, when the term integer is used in this specification.
Okay, good. There's only 5 matches and one of the other directories, so that one's like almost done. I should probably get those 5 first, just so that directory is done, and then it's just one directory left with these 70. I'm gonna try to like focus and just plow through the rest of these, get done, because it's so annoying.
A conversion from a number or big int x to a mathematical value is denoted.
Like this file, I don't think I typed it up. Some of these I freaking typed by hand. This might be one of them. I don't know. That looks exactly the same as the generated ones. To find the file that makes this file, but I don't have a file with a similar name for this one, so I'll just skip this one and then get the ones around it, because there's a lot of matches in it. It's 230 matches. $230, so one. I don't give a fuck, whatever, it's 300 something. I can't even think. This is so boring. So I'm gonna skip this one for now. And get all the other files. I need a pet monkey to do this for me, because this is like brain dead work. I'm gonna try to find the ones in those other files directory and get those 5, and then I'll do these 70 files, and I gotta find the unsigned or the signed.
Is producing floor, x, mathematical functions min, max, abs, floor, and truncate are not defined for numbers and big ints, and any usage of those methods that have non-mathematical value arguments would be an editorial error in this specification. An interval from lower bound A to upper bound B is a possibly infinite.
So like the signed ints, I wanted to remove all the unsigned ints, but like optimization wise, it was faster to use assigned ints for like right shifts for this the top bit for what are they, arithmetic right shifts. When I want to set the bits on, carry the bit, the top bit of the signed word, not word, register, whatever you want to call it. Type that it is. So signed in, I have
From 1, inclusive, to 2, exclusive, consists of all mathematical values between 1 and 2, including 1 and not including 2. For the purpose of defining intervals, -0, +0. So, for example, an inclusive
only 5,000 matches. Hooray. It looks like most of them are in this file.
ECMAScript language values are displayed in bold. Examples include null, true.
There's 2,000 in this file. But I don't know. This doesn't look that bad. There's maybe only like 2,000-ish.
Specification values and ECMAScript language values are compared for equality. When comparing for equality, values fall into one of two categories. Values without identity are equal to other values without identity if all of their in-8 characteristics are the same. Characteristics such as the magnitude of an integer or the length of a sequence. Values
This sucks, man. I think I'm done stalling. I'm gonna just do this now. Everything builds. I need to save it back up. I'll just do that later. I should do it now. This computer is a piece of crap. It could fail at any minute. I'll save it back up.
changed in place.
It's probably gonna take like 10 minutes to copy like 2 gigs to the other drive, so I'll just put up the BRB. And then like not show copyright material that's on YouTube, publicly accessible, that's like literally on YouTube itself, which is a YouTube live stream, but you can't play music or the whole copyright thing is just a bunch of bullcrap.
Without specification identity include, but are not limited to.
If the copyright thing had anything to do like with caring about the artists, giving them credit, or caring about the audience, then the whole P. Diddy thing with the baby oil, that would have never happened. But it did, so like the music industry is corrupt as fuck. Anyways, well, everything's corrupt as fuck. I'll be back. I'm gonna shut up.
Abstract closure.
I'll continue in this little pit of hell I'm in right now. I'm so freaking bored. This sucks.
Records. Specification identity agrees with language identity for all ECMAScript language values except symbol values produced by symbol 4. The ECMAScript language values without specification identity and without language identity are undefined, null, booleans, strings, numbers, and bigins. The ECMAScript language values with specification identity and language identity are symbols not produced by symbol for and objects. Symbol values produced by symbol for have specification identity, but not language identity. ECMAScript data types and values. Algorithms within the S specification manipulate values, each of which has an associated type. The possible value types are exactly those defined in this clause. Types are further subclassified into ECMAScript language types and specification types. Within this specification, the notation type X is used as shorthand for the type of X, where type refers to the ECMAScript language and specification types defined in this clause. Point 1 ECMAScript language types. An ECMAScript language type corresponds to values that are directly manipulated by an ECMAScript program using the ECMAScript language. The ECMAScript language types are undefined, null, boolean, string, symbol, number, big int, and object. An ECMAScript language value is a value that is characterized by an ECMAScript language type, 1.1 the undefined type. The undefined type has exactly one value, called undefined. Any variable that has not been assigned a value has the value undefined, 1.2 the null type. The null type has exactly one value, called null6, 1. 3 the boolean type. The boolean type represents a logical entity having two values, called true and false.
I saved it back up because this computer could go blue screen of death at any moment. I'm gonna try to like find and replace the rest of these keywords in a couple hours and get it over with. I'm already like 2 days behind. I wanted to be done with this 2 days ago, but I had something changed in the JavaScript syntax where things were errors that didn't used to be errors, because it used to build in the browser. I had things defined as const, and it used to build and it wouldn't throw a warning, but now it was deciding to like stop and it wouldn't build past that point. So I had to figure out how to like I had to find all the files that needed that const and like trace up the tree and put it in place, because you can't define two const in the same file. It makes an error. There can only be one. And it took like all day yesterday or the day before, I don't know, just there's a couple tiny little things that ate up way too much time, and then Windows crashed earlier. I installed that stupid game that didn't work. I'm gonna try to focus and get as much as possible. Yeah, I'm done talking. I have nothing else to say. I'm just gonna work. This sucks though. This really freaking sucks.
1. This arguments list. The internal method of a bound function exotic object f takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Let target be f, let bound this be f, let bound args be f, let args be the list concatenation of bound args and arguments list. Return. Call. Target. Bound this. Args 0, 4, 1, 2. Arguments list. New target. The internal method of a bound function exotic object f takes arguments list, a list of ECMAScript language values, a new target, a constructor, and returns either a normal completion containing an object or a throw completion. It performs the following steps when called. Let target be f, assert, is constructor, target, is true. Let bound args be f, let args be the list concatenation of bound args and arguments list. If same value, f, new target, is true. Set new target to target. Return. Construct. Target. Args. New target. 0, 4, 1. 3 bound function create. Target function. Bound this. Bound args. The abstract operation bound function create takes arguments target function, a function object. Bound this. An ECMAScript language value. And bound args. A list of ECMAScript language values, and returns either a normal completion containing a function object or a throw completion. It is used to specify the creation of new bound function exotic objects. It performs the following steps when called. Let proto be target function, let internal slots list be the list concatenation of, and the internal slots listed in table 31. Let obj be make basic object. Internal slots list. Set obj to proto. Set obj as described in 1, 0, 4, 1, 1. If this constructor, target function, is true, then a set obj as described in 1, 0, 4, 1, 2. Set obj to target function. Set obj to bound this. Set obj to bound args 0. Return obj 0, 4. To array exotic objects. An array is an exotic object that gives special treatment to array index property keys, C6, 1, 7. A property whose property name is an array index is also called an element. Every array has a non-configurable length property whose value is always a non-negative integral number whose mathematical value is strictly less than 32. The value of the length property is numerically greater than the name of every own property whose name is an array index. Whenever a known property of an array is created or changed, other properties are adjusted as necessary to maintain this invariant. Specifically, whenever a known property is added w, whose name is an array index, the value of the length property is changed, if necessary, to be one more than the numeric value of that array index, and whenever the value of the length property is changed, every own property whose name is an array index whose value is not smaller than the new length is deleted. This constraint applies only to own. ECMA International 2024 187. Properties of an array and is unaffected by length or array index properties that may be inherited from its prototypes. An object is an array exotic object, or simply, an array, if its internal method uses the following implementation, and its other essential internal methods use the definitions found in 10.1. These methods are installed in array create 0, 4, 2, 1. P, desc. The internal method of an array exotic object takes arguments p, a property key, and desc, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is length, then a return. Array set length, a, desc. Else if p is an array index, then a let length desc be ordinary get own property, a, length, b assert, is data descriptor, length desc, is true, c assert, length desc is false, d let length be length desc, e assert, length is a non-negative integral number, f let index be, 32, p, g if index length and length desc is false, return false, h let succeeded b, ordinary define own property, a, P desk I have succeeded is false. Return false. J if index length. Then I set length desk to index plus 1, 2. Set succeeded to. Ordinary define known property A length. Length desk 3. Assert. Succeeded is true. K return true. Return. Ordinary define known property A P desk 0 4 2. To array create. Length. Proto. The abstract operation array create takes argument length, a non-negative integer, and optional argument proto an object, and returns either a normal completion containing an array exotic object or a throw completion. It is used to specify the creation of new arrays. It performs the following steps when called. If length 232 1, throw a range error exception. If proto is not present, set proto to %array prototype %. Let A be make basic object. Set A to proto. Set A is specified in 1 0 4 2 1. Perform. Ordinary define known property A length. Property descriptor length true. False. False. Return A 0 4 2 3. Array species create. Original array length. The abstract operation array species create takes arguments original array, an object, and length, a non-negative integer, and returns either a normal completion containing an object or a throw completion. It is used to specify the creation of a new array or similar object using a constructor function that is derived from original array. It does not enforce that the constructor function returns an array. It performs the following steps when called. Let is array be. Is array. Original array. If is array is false, return. Array create. Length. Let C be. Get. Original array. Constructor. If is constructor, C, is true, then 88. ECMA International 2024. A let this realm be the current realm record. B let realm be. Get function realm. C. See if this realm and realm are not the same realm record. Then I have same value. C. Realm is true. Set C to undefined. If C is an object, then I set C to get C at species. B if C is null, set C to undefined. If C is undefined, return. Array create. Length. If this constructor C is false, throw a type error exception. Return. Construct C length 0 4 2 4. Array set length A desk. The abstract operation array set length takes arguments A, an array, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If desk does not have a field, then a return. Ordinary define known property A length desk. Let new len desk be a copy of desk. Let new len be 232 desk. Let number len be to number desk. If same value 0, new len, number len, is false. Throw a range error exception. Set new len desk to new len. Let old len desk be ordinary get own property A length. Assert is data descriptor. Old len desk is true. Assert old len desk is false. 0. Let old len be old len desk. 1. If new len old len, then a return. Ordinary define known property A length. New len desk. 2. If old len desk is false, return false. 3. If new len desk does not have a field or new len desk is true, then a let new writable be true. 4. Else. A note. Setting the attribute to false is deferred in case any elements cannot be deleted. B let new writable be false. C set new len desk to true. 5. Let succeeded be. Ordinary define known property A length. New len desk. 6. If succeeded is false, return false. 7. For each own property keep P of a such that P is an array index and 232 P new len in descending numeric index order. Do a let delete succeeded B. A P B if delete succeeded is false, then I set new len desk to 232 P plus 1 2. If new writable is false, set new len desk to false. 3. Perform. Ordinary define known property A length. New len desk. 5. Return false. 8. If new writable is false, then assert succeeded to ordinary define known property A, length, property descriptor, false, B assert, succeeded is true. 9. Return true. Note if original array was created using the standard built-in array constructor for a realm that is not the realm of the running execution context, then a new array is created using the realm of the running execution context. This maintains compatibility with web browsers that have historically had that behavior for the array prototype methods that now are defined using array species create. ECMA International 2024 189. Note, in steps 3 and 4, if desk is an object, then its value of method is called twice. This is legacy behavior that was specified with this effect starting with the second edition of this specification. 0, 4, 3 string exotic objects. A string object is an exotic object that encapsulates a string value and exposes virtual integer index data properties corresponding to the individual code unit elements of the string value. String exotic objects always have a data property named length whose value is the length of the encapsulated string value. Both the code unit data properties and the length property are non-writable and non-configurable. An object is a string exotic object, or simply a string object, if its and internal methods use the following implementations, and its other essential internal methods use the definitions found in 10.1. These methods are installed in string create. String exotic objects have the same internal slots as ordinary objects. They also have an internal slot 1, 0, 4, 3, 1, p. The internal method of a string exotic object s takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desk be ordinary get own property s, p. If desk is not undefined, return desk. Return string get own property s, p. 0, 4, 3, 2, p. Desk. The internal method of a string exotic object s takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let string desk be string get own property s, p. If string desk is not undefined, then a let extensible be s, p. Return is compatible property descriptor, extensible, desk, string desk. Return ordinary define known property s, p. Desk. 0, 4, 3, 3. The internal method of a string exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let keys be a new empty list. Let str be O, assert. Str is a string. Let len be the length of str for each integer I such that 0 I, len, in ascending order. Do a append to string I to keys for each own property key p of O such that p is an array index and to integer or infinity p, len, in ascending numeric index order. Do a append p to keys for each own property key p of O such that p is a string and p is not an array index. In ascending chronological order of property creation, do a append p to keys. 90. ECMA International 2024 8. For each own property key p of O such that p is a symbol. In ascending chronological order of property creation, do a append p to keys. 9. Return keys. 0, 4, 3, 4 string create. Value. Prototype. The abstract operation string create takes arguments value, a string, and prototype, an object, and returns a string exotic object. It is used to specify the creation of new string exotic objects. It performs the following steps when called. Let s be make basic object. Set s to prototype. Set s to value. Set s as specified in 1, 0, 4, 3, 1. Set s as specified in 1, 0, 4, 3, 2. Set s as specified in 1, 0, 4, 3, 3. Let length be the length of value. Perform. Define property or throw s, length, property descriptor, length, false, enumerable, false, false. Return s, 0, 4, 3, 5 string get own property s, p. The abstract operation string get own property takes arguments s, an object that has an internal slot, and p, a property key, and returns a property descriptor or undefined. It performs the following steps when called. If p is not a string, return undefined. Let index be canonical numeric index string p. If index is undefined, return undefined. If is integral number, int x, is false, return undefined. If index is -0, return undefined. Let str be s. Assert str is a string. Let len be the length of str. If r, int x, 0, or len r, int x, return undefined. 0. Let result str be the substring of str from r, int x, to r. Index +1, 1. Return the property descriptor. Result str. False. True, false. 0. 4. 4 arguments exotic objects. Most ECMAScript functions make an arguments object available to their code. Depending upon the characteristics of the function definition, its arguments object is either an ordinary object or an arguments exotic object. An arguments exotic object is an exotic object whose array index properties map to the formal parameters bindings of an invocation of its associated ECMAScript function. An object is an arguments exotic object if its internal methods use the following implementations, with the ones not specified here using those found in 10.1. These methods are installed in create mapped arguments object. Arguments exotic objects have the same internal slots as ordinary objects. They also have an internal slot. Ordinary arguments objects also have an internal slot whose value is always undefined. For ordinary argument object, TS the internal slot is only used by object prototype to string 20, 1, 3, 6 to identify them as such. Note 1. While creating mapped arguments object is grouped into this clause, it creates an ordinary object, not an arguments exotic object. ECMA International 2024 191. Note 2. The integer index data properties of an arguments exotic object whose numeric name values are less than the number of formal parameters of the corresponding function object initially share their values with the corresponding argument bindings in the function's execution context. This means that changing the property changes the corresponding value of the argument binding and vice versa. This correspondence is broken if such a property is deleted and then redefined, or if the property is changed into an accessor property. If the arguments object is an ordinary object, the values of its properties are simply a copy of the arguments passed to the function and there is no dynamic linkage between the property values and the formal parameter values. Note 3. The parameter map object and its property values are used as a device for specifying the arguments object correspondence to argument bindings. The parameter map object and the objects that are the values of its properties are not directly observable from ECMAScript code. An ECMAScript implementation does not need to actually create or use such objects to implement the specified semantics. Note 4. Ordinary arguments objects define a non-configurable accessor property named callee which throws a type error exception on access. The callee property has a more specific meaning for arguments exotic objects, which are created only for some class of non-strict functions. The definition of this property in the ordinary variant exists to ensure that it is not defined in any other manner by conforming ECMAScript implementations. Note 5. ECMAScript implementations of arguments exotic objects have historically contained an accessor property named caller. Prior to ECMAScript 2017, the specification included the definition of a throwing caller property on ordinary arguments objects. Since implementations do not contain this extension any longer, ECMAScript 2017 dropped the requirement for a throwing caller accessor. 0, 4, 4, 1, p. The internal method of an arguments exotic object args takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. Let desc be ordinary get own property, args p. If desc is undefined, return undefined. Let map be args. Let is mapped be has own property, map p. If is mapped is true, then a set desc to get map p6. Return desc 0, 4, 4, 2, p. Desc. The internal method of an arguments exotic object args takes arguments p, a property key, and desk, a property descriptor, and returns a normal completion containing a boolean. It performs the following steps when called. Let map be args, let is mapped be. Has own property, map, p, let new arg desk be desk. If is mapped is true and is data descriptor, desk, is true. Then, if desk does not have a field, desk has a field, and desk is false, then I set new arg desk to a copy of desk 2. Set new arg desk to get map p let allowed be ordinary define own property args p new arg desk 92 ECMA International 2024 6. If allowed is false, return false. If is mapped is true, then if is accessor descriptor desk is true, then I perform map p be else. If desk has a field, then assert the following set will succeed. Since formal parameters mapped by arguments objects are always writable, perform set map p desk false 2. If desk has a field and desk is false, then perform map p8 return true 0 4 4 3. The let map be args let is mapped be has own property map p. If is mapped is false, then a return ordinary get args p receiver 4 else a assert map contains a formal parameter mapping for p. P return get map p 0 4 4 4. The if same value args receiver is false, then a let is mapped be false. Else a let map be args b let is mapped be has own property map p. If is mapped is true, then a assert the following set will succeed. Since formal parameters mapped by arguments objects are always writable, b perform set map p v false return ordinary set args p v receiver 0 4 4 5 p. The internal method of an argument's exotic object args takes argument p, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let map be args let is mapped be has own property map p let result be ordinary delete args p. If result is true and is mapped is true, then a perform map p5 return result. ECMA International 2024 193 10 4 4 6. Create and mapped arguments object arguments list. The abstract operatio and create and mapped arguments object takes arguments list, a list of ECMAScript language values, and returns an ordinary object. It performs the following steps when called. Let len be the number of elements in arguments list. Let obj be ordinary object create %object prototype set obj to undefined. Perform define property or throw obj length property descriptor len true enumerable false true. Let index be 0. Repeat while index len a let val be arguments list index b. Perform create data property or throw obj to string index val c. Set index to index +1. Perform define property or throw obj at iterator property descriptor %array prototype values true false true. Perform define property or throw obj callee property descriptor %throw type error false false. Return obj 0 4 4 7. Create mapped arguments object func formals arguments list env. The abstract operation create mapped arguments object takes arguments func an object formals a parse node arguments list a list of ECMAScript language values, and env an environment record, and returns an argument's exotic object. It performs the following steps when called. Assert formals does not contain a rest parameter, any binding patterns, or any initializers. It may contain duplicate identifiers. Let len be the number of elements in arguments list. Let obj be make basic object. Set obj is specified in 1 0 4 4 1. Set obj is specified in 1 0 4 4 2. Set obj is specified in 1 0 4 4 5. Set obj to %object prototype %0. Let map be ordinary object create null 1. Set obj to map 2. Let parameter names be the bound names of formals 3. Let number of parameters be the number of elements in parameter names 4. Let index be 0 5. Repeat. While int x len let val be arguments list. Index be perform. Create data property or throw obj to string int x val c set index plus 1 6. Perform. Define property or throw obj length property descriptor len true false true 7. Let map names be a new empty list 8. Set index to number of parameters 1 9. Repeat. While index 0 94. ECMA International 2024 A B C. Let name be parameter names. Index. If map names does not contain name, then I append name to map names 2. If int x len, then let g be make arg getter name env. Let p be make arg setter name env. Perform map to string int x property descriptor get g false true set index to index 1 20. Perform. Define property or throw obj at iterator property descriptor %array prototype values true false true 1. Perform. Define property or throw obj callee property descriptor func true false true 2. Return obj 0 4 4 7 1 make arg getter name env. The abstract operation make arg getter takes arguments name a string and env an environment record and returns a function object. It creates a built-in function object that when executed returns the value bound for name and env. It performs the following steps when called. Let getClosure be a new abstract closure with no parameters that captures name and env and performs the following steps when called. A return env get binding value name false. Let getter be create built-in function getClosure 0. Note: getter is never directly accessible to ECMAScript code. Return getter 0 4 4 7 to make arg setter name env. The abstract operation make arg setter takes arguments name a string and env an environment record and returns a function object. It creates a built-in function object that when executed sets the value bound for name and env. It performs the following steps when called. Let setClosure be a new abstract closure with parameters value that captures name and env and performs the following steps when called. A return env set mutable binding name value false. Let setter be create built-in function setClosure 1. Note: setter is never directly accessible to ECMAScript code. Return setter 0 4 5 typed array exotic objects. A typed array is an exotic object that performs special handling of integer index property keys. Typed arrays have the same internal slots as ordinary objects and additionally length and internal slots. An object is a typed array if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by typed array create 0 4 5 1 p. The internal method of a typed array O takes argument p, a property key, and returns a normal completion containing either a property descriptor or undefined. It performs the following steps when called. If p is a string, then a let numeric index be canonical numeric index string p be. If numeric index is not undefined, then I let value be typed array get element numeric index 2. If value is undefined, return undefined 3. Return the property descriptor u value true true true. Return ordinary get own property o p. ECMA International 2024 195 10 4 5 2 p. P. The internal method of a typed array O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P. B. If numeric index is not undefined, return as valid integer index O. Numeric index return. Ordinary has property O. P 0, 4, 5, 3, P. Desk. The internal method of a typed array O takes arguments P, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P. B. If numeric index is not undefined, then if as valid integer index O. Numeric index is false, return false. 2. If desk has a field and desk is false, return false. 3. If desk has an field and desk is false, return false. 5. If is access a descriptor, desk is true, return false. V. If desk has a field and desk is false, return false. V. If desk has a field, perform. Typed array set element O. Numeric index desk 7. Return true. Return. Ordinary define known property O. P. Desk 0, 4, 5, 4. The. If P is a string, then a let numeric index be canonical numeric index string P. B. If numeric index is not undefined, then I return typed array get element O. Numeric index 2. Return. Ordinary get O. P. Receiver 0, 4, 5, 5. The. If P is a string, then a let numeric index be canonical numeric index string P. B. If numeric index is not undefined, then if same value O. Receiver is true, then perform. Typed array set element O. Numeric index V. Return true. 2. If as valid integer index O. Numeric index is false, return true. Return. Ordinary set O. P. V. Receiver 96. ECMA International 2024 10456 P. The internal method of a typed array O takes argument P, a property key, and returns a normal completion containing a boolean. EPILOGUE performs the following steps when called. If P is a string, then a let numeric index be canonical numeric index string P. B. If numeric index is not undefined, then if as valid integer index O. Numeric index is false, return true, else return false. 2. Return. Ordinary delete O. P 0, 4, 5, 7. The internal method of a typed array O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexy ST. Let keys be a new empty list. If this typed array out of bounds tar record is false, then a let length be typed array length tar record be for each integer I such that 0 length in ascending order do I append to string I to keys for each own property key P of O such that P is a string and P is not an integer index. In ascending chronological order of property creation, do I append P to keys for each own property key P of O such that P is a symbol. In ascending chronological order of property creation, do I append P to keys. 6. Return keys 0, 4, 5, 8. Typed array with buffer witness records. And typed array with buffer witness record is a record value used to encapsulate a typed array along with a cached byte length of the viewed buffer. It is used to help ensure there is a single shared memory read event of the byte length data block when the viewed buffer is a growable shared array buffer. Typed array with buffer witness records have the fields listed in Table 32. Table 32. Typed array with buffer witness record fields 0, 4, 5, 9, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, OBJ, order. The abstract operation, capital M, A, K, E, capital T, Y, P, E, D, capital A, R, R, A, Y, capital W, I, T, H, capital B, U, F, F, E, R, capital W, I, T, N, E, S, takes arguments obj, a typed array, and order, sexcst or unordered, and returns a typed array with buffer witness record. It performs the following steps when called. Let buffer be obj. If is detached buffer is true. Then a let byte length be detached. Field name, value, meaning, object, a typed array, the typed array whose buffer's byte length is loaded. Cached buffer byte length, a non-negative integer or detached. The byte length of the objects when the record was created. Copyright sign, ECMA International 2024 197. 3. Else, a let byte length be array buffer byte length. Buffer, order, return the typed array with buffer witness record. OBJ, byte length 0, 4, 5, 1 0 typed array create. Prototype. The abstract operation typed array create takes argument prototype, an object, and returns a typed array. It is used to specify the creation of new typed arrays. It performs the following steps when called. Let internal slots list be. Let AB make basic object. Internal slots list set A is specified in 1 0, 4, 5, 1. Set A is specified in 1 0, 4, 5, 2. Set A is specified in 1 0, 4, 5, 3. Set A is specified in 1 0, 4, 5, 6. Set A is specified in 1 0, 4, 5, 7, 0. Set A to prototype 1. Return A 0, 4, 5, 1 1 typed array byte length. tar record. The abstract operation typed array byte length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. If this typed array out of bounds, tar record, is true, return 0. Let length be typed array length, tar record. If length equals 0, return 0. Let O be tar record. If O is not auto, return O. Let element size be typed array element size. O. Return length element size 0, 4, 5, 1 2 typed array length. tar record. The abstract operation typed array length takes argument tar record, a typed array with buffer witness record, and returns a non-negative integer. It performs the following steps when called. Assert. Is typed array out of bounds. tar record. Is false. Let O be tar record. If O is not auto, return O. Assert. Is fixed length array buffer. O is false. Let byte offset be O. Let element size be typed array element size. O. Let byte length be tar record. Assert. Byte length is not detached. Return floor. Byte length. Byte offset. Element size 0, 4, 5, 1 3 is typed array out of bounds. tar record. The abstract operation is typed array out of bounds takes argument tar record, a typed array with buffer witness record, and returns a boolean. It checks if any of the object's numeric properties reference a value at an index not contained within the underlying buffer's bounds. It performs the following steps when called. 2. Let O be tar record. Let buffer byte length be tar record. 98. ECMA International 2024. 3. Assert. Is detached buffer. O. is true if and only if buffer byte length is detached. If buffer byte length is detached, return true. Let byte offset start BO. If O is auto, then
I have like 5 HTML files with JavaScript or whatever. I think I'm gonna like get those done first. I already just wasted time updating another one. And then when these are done, it cuts down the number of things to replace. And then this way I don't have to worry about replacing in a file that's generated, because I'm gonna like get these files now. Bleh. Blah blah blah. Get these files now, and then generate them. It'll cut down on the keywords to replace, and then I don't know. This is so boring.
capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O. Unordered. Note: bounds checking is not a synchronizing operation when O's backing buffer is a growable shared array buffer. If is typed array out of bounds, tar record is true. Return false. Let length be typed array length. Tar record. If R int x 0 or R int x length, return false. Return true. 0 4 5 1 5 typed array get element. O index. The abstract operation typed array get element takes argument so a typed array and index a number and returns a number, a big int, or undefined. It performs the following steps when called. If is valid integer index O index is false, return undefined. Let offset be O. Let element size be typed array element size O. Let byte index in buffer be R index element size plus offset. Let element type be typed array element type O. Return get value from buffer O. Byte index in buffer element type true. Unordered. 0 4 5 1 6 typed array set element O index value. The abstract operation typed array set element takes argument so a typed array index a number and value, an ECMAScript language value, and returns either a normal completion containing unused or a throw completion. It performs the following steps when called. If O is bigint, let num value be to big int value. Otherwise, let num value be to number value. If is valid integer index O index is true, then a let offset be O. B let element size be typed array element size O. C let byte index in buffer be R index element size plus offset. D let element type be typed array element type O. E perform set value in buffer O. Byte index in buffer element type num value true. Unordered. Return unused. ECMA International 2024 199 104 5 17 is array buffer view out of bounds O. The abstract operation is array buffer view out of bounds takes argument O, a typed array or a data view, and returns a boolean. It checks if either any of a typed array's numeric properties or a data view object's methods can reference a value at an index not contained within the underlying data block's bounds. This abstract operation exists as a convenience for upstream specifications. It performs the following steps when called. If O has an internal slot, then a let view record be capital M A K E capital D A T A capital V I E W capital W I T H capital B U F F E R capital W I T N E S S capital R O sexy S T B return is view out of bounds View record. Let tar record be capital M A K E capital T Y P E D capital A R R A Y capital W I T H capital B U F F E R capital W I T N E S O sexiest T. Return is typed array out of bounds. Tar record 0 4 6 module namespace exotic objects. A module namespace exotic object is an exotic object that exposes the bindings exported from an ECMAScript module. C16 2 3. There is a one-to-one correspondence between the string keydown properties of a module namespace exotic object and the binding names exported by the module. The exported bindings include any bindings that are indirectly exported using export items. Each string valued own property key is the string value of the corresponding exported binding name. These are the only string keyed properties of a module namespace exotic object. Each such property has the attributes true, true, false. Module namespace exotic objects are not extensible. An object is a module namespace exotic object if its and internal methods use the definitions in this section, and its other essential internal methods use the definitions found in 10.1. These methods are installed by module namespace create. Module namespace exotic objects have the internal slots defined in Table 33. Table 33. Internal slots of module namespace exotic objects. Internal slot. Type. Description. Module A. Module record. The module record whose exports this namespace exposes. Exports. A list of strings. A list whose elements are the string values of the exported names exposed as own properties of this object. The list is ordered as if an array of those string values had been sorted using %array prototype sort % using undefined as compare f and 1 0 4 6 1. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing null. It performs the following steps when called. Return null. 00 ECMA International 2024. Note this operation always appears to succeed, but it has no effect when attempting to write past the end of a typed array or to a typed array which is backed by a detached array buffer. 1 0 4 6 2. V. The internal method of a module namespace exotic object O takes argument V, an object or null, and returns a normal completion containing a boolean. It performs the following steps when called. 1. Return. Set immutable prototype O. V. 0 4 6 3. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing false. It performs the following steps when called. Return false. 0 4 6 4. The internal method of a module namespace exotic object takes no arguments and returns a normal completion containing true. It performs the following steps when called. Return true. 0 4 6 5 p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns either a normal completion containing either a property descriptor or undefined, or a throw completion. It performs the following steps when called. If p is a symbol, return ordinary get own property O. P. Let exports be O. If exports does not contain p, return undefined. Let value be O. Return property descriptor value true, true, false. 0 4 6 6 p. Desk. The internal method of a module namespace exotic object O takes arguments p, a property key, and desk, a property descriptor, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. If p is a symbol, return ordinary define own property O. P. Desk. Let current be O. P. If current is undefined, return false. If desk has a field and desk is true, return false. If desk has an field and desk is false, return false. If is access a descriptor, desk, is true, return false. If desk has a field and desk is false, return false. If desk has a field, return same value, desk, current, return true, 0, 4, 6, 7, p. The internal method of a module namespace exotic object O takes argument p, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If p is a symbol, return ordinary has property O, p. Let exports be O. If exports contains p, return true, return false. ECMA International 2024 201 10 4 6 8. The if p is a symbol, then a return ordinary get O, p. Receiver. Let exports be O. If exports does not contain p, return undefined. Let m be O. Let binding be m. Resolve export p. Assert binding is a resolved binding record. Let target module be binding. Assert target module is not undefined. If binding is namespace, then a return get module namespace target module 0. Let target env be target module 1. If target env is empty, throw a reference error exception. 2. Return target env get binding value, binding, true 0, 4, 6, 9. The return false 1, 0, 4, 6, 1, 0. P. The internal method of a module namespace exotic obj CTO takes argument p, a property key, and returns a normal completion containing a boolean. It performs the following steps when called. If p is a symbol, then a return ordinary delete O, p. Let exports be O. If exports contains p, return false, return true 0, 4, 6, 1, 1. The internal method of a module namespace exotic object O takes no arguments and returns a normal completion containing a list of property keys. It performs the following steps when called. Let exports be O. Let symbol keys be ordinary own property keys. O. Return the list concatenation of exports and symbol keys. Note resolve export is side effect free. Each time this operation is called with a specific export name, resolve set pair as arguments, it must return the same result. An implementation might choose to pre-compute or cache the resolve export results for the of each module namespace exotic object. 02. ECMA International 2024 10 4 6 1 2. Module namespace create module exports. The abstract operation module namespace create takes arguments module, a module record, and exports a list of strings, and returns a module namespace exotic object. It is used to specify the creation of new module namespace exotic objects. It performs the following steps when called. Assert module is empty. Let internal slots list be the internal slots listed in table 33. Let n be make basic object internal slots list. Set m's essential internal methods to the definitions specified in 10 4 6. Set m to module. Let sorted exports be a list whose elements are the elements of exports ordered as if an array of the same values had been sorted using %array prototype. Sort % using undefined as compare fn. Set m to sorted exports. Create own properties of m corresponding to the definitions in 28.3. Set module to m 0. Return m 0, 4, 7. Immutable prototype exotic objects. An immutable prototype exotic object is an exotic object that has an internal slot that will not change once it is initialized. An object is an immutable prototype exotic object if its internal method uses the following implementation. Its other essential internal methods may use any implementation, depending on the specific immutable prototype exotic object in question. 0, 4, 7, 1. V. The internal method of an immutable prototype exotic object O takes argument v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Return set immutable prototype O v1 0 4 7 2. Set immutable prototype O v. The abstract operation set immutable prototype takes arguments O, an object, and v, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Let current be O if same value v current is true. return true, return false. 0.5 Proxy object internal methods and internal slots. A proxy object is an exotic object whose essential internal methods are partially implemented using ECMAScript code. Every proxy object has an internal slot called the value of is an object, called the proxy's handler object, or null. Methods, see Table 34, of a handler object may be used to augment the implementation for one or more of the proxy object's internal methods. Every proxy object also has an internal. Note, unlike other exotic objects, there is not a dedicated creation abstract operation provided for immutable prototype exotic objects. This is because they are only used by %object prototype % and by host environments. And in host environments, the relevant objects are potentially exotic in other ways and thus need their own dedicated creation operation. ECMA International 2024 203. Slot called whose value is either an object or the null value. This object is called the proxy's target object. An object is a proxy exotic object if its essential internal methods, including and, if applicable, use the definitions in this section. These internal methods are installed in proxy create. Table 34. Proxy handler methods. Internal method. Handler method. Get prototype of set prototype of is extensible. Prevent extensions. Get own property descriptor. Define own property. Has get set delete property. Own property keys. Call apply construct. When a handler method is called to provide the implementation of a proxy object internal method, the handler method is passed the proxy's target object as a parameter. A proxy's handler object does not necessarily have a method corresponding to every essential internal method. Invoking an internal method on the proxy results in the invocation of the corresponding internal method on the proxy's target object if the handler object does not have a method corresponding to the internal trap. The and internal slots of a proxy object are always initialized when the object is created and typically may not be modified. Some proxy objects are created in a manner that permits them to be subsequently revoked. When a proxy is revoked, its and internal slots are set to null, causing subsequent invocations of internal methods on that proxy object to throw a type error exception. Because proxy objects permit the implementation of internal methods to be provided by arbitrary ECMAScript code, it is possible to define a proxy object whose handler methods violates the invariants defined in 6.1.7.3. Some of the internal method invariants defined in 6.1.7.3 are essential integrity invariants. These invariants are explicitly enforced by the proxy object internal methods specified in this section. An ECMAScript implementation must be robust in the presence of all possible invariant violations. In the following algorithm descriptions, assume O is an ECMAScript proxy object. P is a property key value. V is any ECMAScript language value and desc is a property descriptor record. O for copyright sign. ECMA International 2024 1051. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing either an object or null, or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Get prototype of. If trap is undefined, then a return target. Let handler proto be. Call. Trap. Handler. Target. If handler proto is not an object and handler proto is not null, throw a type error exception. Let extensible target be. Is extensible target 0. If extensible target is true, return handler proto 1. Let target proto be target 2. If same value, handler proto, target proto, is false, throw a type error exception 3. Return handler proto 0, 5, 2. V. The internal method of a proxy exotic object O takes argument V, an object or null, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set prototype of if trap is undefined. Then a return target. V. Let boolean trap result be to boolean. Call. Trap. Handler. Target. V. If boolean trap result is false. Return false. Let extensible target be. Is extensible. Target 0. If extensible target is true. Return true 1. Let target prota be target 2. If same value, v, target prota, is false. Throw a type error exception 3. Return true. Note for proxy objects enforces the following invariants. The result of must be either an object or null. If the target object is not extensible, applied to the proxy object must return the same value as applied to the proxy object's target object. Note for proxy objects enforces the following invariants. The result of is a boolean value. If the target object is not extensible, the argument value must be the same as the result of get prototype of applied to target object. ECMA International 2024 205 1053. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler is extensible. If trap is undefined, then a return is extensible. Target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. Let target result be. Is extensible. Target. If boolean trap result is not target result, throw a type error exception 0. Return boolean trap result 0, 5, 4. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy O. Let
I have one file that doesn't generate the same exact output. I don't know what it's doing. I must have been like logging stuff, and I left it in that state of like testing mode. Now I gotta like go through and figure out what to turn off just so it makes the right output. So I'm gonna wait on this file and get back to it because it's really complicated. Ugh. So I'm gonna work around it and get everything else, and then have this one file left that I'm gonna have to deal with at some point. I'm gonna have to sit down, look at it, figure it out. Oh my god, this is so much work. I was so close. Everything was almost in like the perfect state where I could just find and replace, but like literally one file out of like 400 something files is in like a test mode state. One file out of all of them. Man, the odds of one file. Oh, I'm so pissed. I can like just copy paste whatever it outputs, but it's tied to like a whole bunch of stuff, so I can't just keep whatever output because other parts of the program use this one little part. If I change one thing, the whole thing has to be adjusted where it was placed. So I'll get back to this later. It's just really annoying. I have one fucking file I have to go through. And I don't know if I can get the rest of them, like, done in a couple hours. I'm gonna try to focus, whatever that means. If I could get this over with, then all the unsigned-ins replaced. I still have to go through and replace where it's a comment or not, but that's easier because I already thought of that earlier by planning ahead and all whatever. This is gonna take a couple more days. What's another day? You know, just another day. And another day. And another day. And another day. And another day. I didn't say whatever the whole time. I didn't say whatever. That's a good thing. I think I'm gonna stop saying whatever. I was able to not say it. I think I got it out of my system. I didn't even say it. I could have said it right there, but I didn't say that word. So I'm gonna whatever. This sucks. One file. And I'm like so annoyed though. Like inside I'm like screaming. Like how did I forget one file? I like saved it in like a state where I'm like everything's good. I can open this whenever I want and I'll be able to do whatever because the whole program's just ready to build what I need. And then there's one file that's not. It's in like a middle state where it's testing stuff. Because like this is clearly not the same as this. This one's outputting a whole bunch of like test stuff, and this one's literally just the code that has to build. And I turn this off to print this stuff, whatever, where I have this toggle here. I turn this part off, so it should like do this, whatever. Instead, it does this.
For a type error exception.
Wait, is it building now? Oh wait, hold on. Oh, it's because I turned it back on. Oh wait. Oh, I made a copy of the original so I don't mess it up. But I moved global to the top here and open the copy file. Does this? Oh, it's turned on. I gotta turn off. Whatever. Here's where like the state it's at. Makes this. Which is what's inside of here right now. And then when I turn it off, I need it to look like this, the original. So turn that off. Which is whatever to blah blah blah. It outputs this. And this is broken. This is not even output. The JavaScript failed. Somewhere. I don't care where it failed, it failed. I'm not gonna look into it. So I'm gonna have to look into why when I turn this off to debug, it breaks it. Because I need it to do this. Not output all this. This doesn't even build. This isn't even build code. It's just to log stuff. So I can see what it's holding in memory. So, I don't know. One file. I'm kind of pissed.
Property that has undefined as its 0, 5, 9. The perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Set. If trap is undefined, then a return target. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. V. Receiver. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is not undefined and target desk is false, then ECMA International 2024-209. If is data descriptor, target desk is true and target desk is false, then I if same value, V, target desk is false. Throw a type error exception. B if is accessor descriptor, target desk is true, then I if target desk 1. Return true. Note, the result of cannot change the value of a property to be different from the value of the corresponding target object property if the corresponding target object property is a non-writable, non-configurable own data property. Cannot set the value of a property if the corresponding target object property is a non-configurable own accessor property that has undefined as its set attribute 0, 5, 1, 0. P. The internal method of a proxy exotic object O takes argument P, a property key, and returns either a normal completion containing a boolean or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Delete property. If trap is undefined, then a return target. P. Let boolean trap result be to boolean. Call. Trap. Handler. Target. P. If boolean trap result is false, return false. Let target desk be target. P. 0. If target desk is undefined, return true. 1. If target desk is false, throw a type error exception. 2. Let extensible target be. Is extensible target. 3. If extensible target is false. 4. Return true. Note for proxy objects enforces the following invariants. The result of is a
I don't know.
A property cannot be reported as deleted if it exists as a known property of the target object and the target object is non-extensible. 0, 5, 1, 1. The internal method of a proxy exotic object O takes no arguments and returns either a normal completion containing a list of property keys or a throw completion. It performs the following steps when called. Perform. Validate non-revoke proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Own keys. 10. ECMA International 2024. 6. If trap is undefined, then a return target. Let trap result array be. Call. Trap. Handler. Target. Let trap result be. Create list from array like trap result array, string, symbol. If trap result contains any duplicate entries, Throw a type error exception. 0. Let extensible target be. Is extensible target 1. Let target keys be target 2. Assert target keys is a list of property keys. 3. Assert target keys contains no duplicate entries. 4. Let target configurable keys be a new empty list. 5. Let target non-configurable keys be a new empty list. 6. For each element key of target keys, do a let desk be target key be if desk is not undefined and desk is false. Then I append key to target non-configurable keys. See else. I append key to target configurable keys. 7. If extensible target is true and target non-configurable keys is empty, then a return trap result. 8. Let unchecked result keys be a list whose elements are the elements of trap result. 9. For each element key of target non-configurable keys, do if unchecked resu lt keys does not contain key. Throw a type error exception. Be remove key from unchecked result keys. 0. If extensible target is true, return trap result. 1. For each element key of target configurable keys, do if unchecked result keys does not contain key. Throw a type error exception. Be remove key from unchecked result keys. 2. If unchecked result keys is not empty, throw a type error exception. 3. Return trap result. Note for proxy objects enforces the following invariance. The result of is a list.
This song's a little dramatic, just saying.
Or symbol. The result.
I'm not gonna see what
Extensible. Then the result list must contain all the keys of the own properties of the target object and no other values. 0, 5, 1, 2. This arguments list. The internal method of a proxy exotic object O takes arguments this argument, an ECMAScript language value, and arguments list, a list of ECMAScript language values, and returns either a normal completion containing an ECMAScript language value or a throw completion. It performs the following steps when called. Perform. Validate non-revoked proxy. O. Let target be O. Let handler be O. Assert. Handler is an object. Let trap be. Get method. Handler. Apply. If trap is undefined, then a return. Call. Target. This argument. Arguments list. From list. Arguments list. Return. Call.
These YouTube playlists are not random.
Note a proxy exotic object only has internal.
I'm picking like energize, whatever super mix, I don't even know who's in there. But like, it plays like the same combination of songs. I don't know, whatever, it's stupid.
ECMAScript language values. A new target. A constructor. And returns either a normal completion
like, if they could just play like a couple songs out of order, even though they're like the same songs that are picked every time. Like I could like refresh this like 5 times, and it'll like, I'm so bored. This is so freaking boring. I need to just get these files done. This is so boring. I hate updating this program to 64-bit. This is so boring. Okay, I'm done cleaning. I have to stop. I didn't say whatever. Nope. I didn't say whatever.
X enforces the following invariance. The result of must be an object. 0, 5, 1 for validate non-revoke proxy. Proxy. The abstract operation validate no. And revoke proxy takes argument proxy, a proxy exotic object, and returns either a normal completion containing unused or a throw completion. It throws a type error exception if proxy has been revoked. It performs the following steps when called. If proxy is null, throw a type error exception. Assert. Proxy is not null. Return unused. 0, 5, 1, 5 proxy create. Target. Handler. The abstract operation proxy create takes arguments target, an ECMAScript language value, and handler, an ECMAScript language value. and returns either a normal completion containing a proxy exotic object or a throw completion. It is used to specify the creation of new proxy objects. It performs the following steps when called. If target is not an object, throw a type error exception. If handler is not an object, throw a type error exception. Let p be make basic object. Set p's essential internal methods, except for and, to the definitions specified in 10.5. If is callable, target, is true, then a set p is specified in the 10th of May 2012. B if is constructor, target, is true, then I set p is specified in the 10th of May 2013. Set p to target, set p to handler, return p, 12, ECMA International 2024. Note 1. A proxy exotic object only has an internal method if the initial value of its internal slot is an object that has an internal method. 11. ECMAScript language. Source text. 1.1 Source text syntax. Source character. Any Unicode code point. ECMAScript source text is a sequence of Unicode code points. All Unicode code point values from U plus 0000 to U plus 10FF, including surrogate code points, may occur in ECMAScript source text where permitted by the ECMAScript.
I closed the wrong file. And it messed up the ordering. So now I gotta reopen all these fucking files again. Because I don't want to like figure out which one I closed because they almost all look the same. I'm gonna lose my mind. This is so boring. I hate this. I have to stop complaining. I have to stop. I'm done complaining. I'll never be done complaining. I'm just full of complaints.
Also be expressed using Unicode escape sequences that explicitly express a code point's numeric value. Within a comment, such an escape sequence is effectively ignored as part of the comment. ECMAScript differs from the Java programming language in the behavior of Unicode escape sequences. In a Java program, if the Unicode escape sequence U000 for example, occurs within a single line comment, it is interpreted as a line terminator. Unicode code point U plus 000A is line feed, LF, and therefore the next code point is not part of the comment. Similarly, if the Unicode escape sequence U000A occurs within a string literal in a Java program, it is likewise interpreted as a line terminator, which is not allowed within a string literal. One must write n instead of U000A to cause a line feed, LF, to be part of the string value of a string literal. In an ECMAScript program, a Unicode escape sequence occurring within a comment is never interpreted and therefore cannot contribute to termination of the comment. Similarly, a Unicode escape sequence occurring within a string literal in an ECMAScript program always contributes to the literal and is never interpreted as a line terminator or as a code point that might terminate the string literal. 1 static semantics. UTF-16 encode code point, CP. The abstract operation UTF-16 encode code point takes argument CP, a Unicode code point, and returns a string. It performs the following steps when called. Assert 0 CP0 times 10FF. If CP0 XFF, return the string value consisting of the code unit whose numeric value is CP. Let K1 be the code unit whose numeric value is floor. CP0 times 10,000, 0 times 400 plus 0 XD800. Let Q2 be the code unit whose numeric value is CP0 times 10,000, modulo 0 times 400 plus 0 XDC00. Return the string concatenation of Q1 and Q2. ECMA International 2024 213. 1 2 static semantics. Code points to string. Text. The abstract operation code points to string takes argument text, a sequence of Unicode code points, and returns a string. It converts text into a string value, as described in 6.1.4. It performs the following steps when called. Let result be the empty string. For each code point CP of text, Do a set result to the string concatenation of result and UTF-16 encode code point CP3. Return result 1, 1, 3 static semantics, UTF-16 surrogate pair to code point, lead, trail. The abstract operation UTF-16 surrogate pair to code point takes arguments lead a code unit, and trail, a code unit, and returns a code point. Two code units that form a UTF-16 surrogate pair are converted to a code point. It performs the following steps when called. Assert. Lead is a leading surrogate and trail is a trailing surrogate. Let CP be lead 0xD800. 0 times 400 plus trail 0xDC00 plus 0 times 10,000. Return the code point CP 1, 1. 4 static semantics. Code point at string position. The abstract operation code pointer takes arguments string, a string, and position, a non-negative integer, and returns a record with fields, a code point, a positive integer, and a boolean. It interprets string as a sequence of UTF-16 encoded code points, as described in 6, 1, 4, and reads from it a single code point starting with the code unit at index position. It performs the following steps when called. Let size be the length of string. Assert. Position 0 and position size. Let first be the code unit at index position within string. Let CP be the code point whose numeric value is the numeric value of first. If a first is neither a leading surrogate nor a trailing surrogate, then I return the record CP 1, full 6. If a first is a trailing surrogate or position plus 1 equals size, then I return the record CP 1, true. Let second be the code unit at index position plus 1 within string. If second is not a trailing surrogate, then I return the record CP 1, true. Set CP to UTF-16 surrogate pair to code point first, second 0. Return the record CP 2, false 1, 1. 5 static semantics. String to code points. String. The abstract operation string to code points takes argument string, a string, and returns a list of code points. It returns the sequence of Unicode code points that results from interpreting string as UTF-16 encoded Unicode text as described in 6, 1, 4. It performs the following steps when called. Let code points be a new empty list. Let size be the length of string. Let position be 0. Repeat. While position, size. Let CP be code point at string, position. Be append CP to code points. C set position to position plus CP. Return code points. 14. ECMA International 2024. 111. 6 static semantics. Parse text. Source text, goal symbol. The abstract operation parse text takes arguments source text, a sequence of Unicode code points, and goal symbol, a non-terminal in one of the ECMAScript grammars, and returns a parse node or a non-empty list of syntax error objects. It performs the following steps when called. Attempt to parse source text using goal symbol as the goal symbol, and analyze the parse result for any early error conditions. Parsing and early error detection may be interleaved in an implementation-defined manner. If the parse succeeded and no early errors were found, return the parse node, an instance of goal symbol, at the root of the parse tree resulting from the parse. Otherwise, return a list of one or more syntax error objects representing the parsing errors and/or early errors. If more than one parsing error or early error is present, the number and ordering of error objects in the list is implementation-defined, but at least one must be present. Note to see also clause 17. 1.2 Types of source code. There are 4 types of ECMAScript code. Global code is source text that is treated as an ECMAScript script. The global code of a particular script does not include any source text that is parsed as part of a function declaration, function expression, gener, at a declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Eval code is the source text supplied to the built-in eval function. More precisely, if the parameter to the built-in eval function is a string, it is treated as an ECMAScript script. The eval code for a particular invocation of eval is the global code portion of that script. Function code is source text that is parsed to supply the value of the and internal slots, C10.2, of an ECMAScript function object. The function code of a particular ECMAScript function does not include any source text that is parsed as the function code of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. In addition, if the source text referred to above is parsed as the formal parameters and function body of a function declaration or function expression, the formal parameters and generator body of a generator declaration or generator expression, the formal parameters and async function body of an async function declaration or async function expression, or the formal parameters and async generator body of an async generator declaration or async generator expression, then the source text match by the binding identifier, if any of that declaration or expression is also included in the function code of the corresponding function. Module code is source text that is provided as a module body. It is the code that is directly evaluated when a module is initialized. The module code of a particular module does not include any source. Note 1. Consider a text that has an early error at a particular point, and also a syntax error at a later point. An implementation that does a parse followed by an early errors parse might report the syntax error and not proceed to the early errors parse. An implementation that interleaves the two activities might report the early error and not proceed to find the syntax error. A third implementation might report both errors. All of these behaviors are conformant. Copyright sign, ECMA International 2024 215. Text that is parsed as part of a nested function declaration, function expression, generator declaration, generator expression, async function declaration, async function expression, async generator declaration, async generator expression, method definition, arrow function, async arrow function, class declaration, or class expression. Note 1. Function code is generally provided as the bodies of function definitions, 15.2, arrow function definitions, 15.3, method definitions, 15.4, generator function definitions, 15.5, async function definitions, 15.8, async generator function definitions, 15.6, and async arrow functions, 15.9. Function code is also derived from the arguments to the function constructor 20, 2, 1, 1, the generator function constructor 27, 3, 1, 1, and the async function constructor 27, 7, 1, 1. Note 2. The practical effect of including the binding identifier in function code is that the early errors for strict mode code are applied to a binding identifier that is the name of a function whose body contains a use strict directive, even if the surrounding code is not strict mode code. 1, 2, 1 directive prologues in the use strict directive. A directive prologue is the longest sequence of expression statements occurring as the initial statement list items or module items of a function body, a script body, or a module body, and where each expression statement in the sequence consists entirely of a string literal token followed by a semicolon. The semicolon may appear explicitly or may be inserted by automatic semicolon insertion. 12.10. A directive prologue may be an empty sequence. A use strict directive is an expression statement in a directive prologue whose string literal is either of the exact code point sequences use strict or use strict. A use strict.
Now I can rebuild whatever these files. Save a file. Run the compiler. Then find and replace whatever's left. Oh, this is so boring. I'm like 2 days behind. This is taking so long. 3 of these files. They didn't even have, they weren't even using unsigned. It was just commented out. It's a whole lot of effort to like open up these files, run them all, paste them up in the tabs, everything organized, and then not even, it doesn't even matter for 3 of them. I should stop complaining.
Async function declaration, async function expression, async generator declaration,
Run these, paste them in,
or async.
and if it doesn't build, I'm gonna like explode. Crap, this is so messed up. That's cool. Well, I had one bug I gotta redo, apparently.
Directive, ECMAScript code that is not strict mode code is called non-strict code. 16. Copyright sign, ECMA International 2024. Note the expressee on statements of a directive PROLOGUE are evaluated normally during evaluation of the containing production. Implementations may define implementation-specific meanings for expression statements which are not a use-strict directive and which occur in a directive PROLOGUE. If an appropriate note...
The keywords not defined. So we gotta include the file. Oh, it's not in here. It's great.
defined by the implementation.
It'll take like slightly more effort, because now I gotta like try to keep it looking the same as the other files, so we can like organize later.
ECMAScript source text. Whether a function object is defined with an ECMAScript code or as a built-in function is not observable from the perspective of ECMAScript code that calls or is called by such a function object. 2. ECMAScript language. Lexical grammar. The source text of an ECMAScript script or module is first converted into a sequence of input elements, which are tokens, line terminators, comments, or white space. The source text is scanned from left to right, repeatedly taking the longest possible sequence of code points as the next input element. There are several situations where the identification of lexical input elements is sensitive to the syntactic grammar context that is consuming the input elements. This requires multiple goal symbols for the lexical grammar. The input element hashbang or regexp goal is used at the start of a script or module. The capital I, N, P, U, T, capital E, L, E, M, E, N, T, capital R, E, G, capital E, X, P, capital O, R, capital T, E, M, P, L, A, T, E, capital T, A. Goal is used in syntactic grammar contexts where a regular expression literal, a template middle, or a template tail is permitted. The input element regexp goal symbol is used in all syntactic grammar contexts where a regular expression literal is permitted but neither a template middle nor a template tail is permitted. The input element template tail goal is used in all syntactic grammar contexts where a template middle or a template tail is permitted but a regular expression literal is not permitted. In all other contexts, input...
The file path directory is different. I hate file paths. I'll stop complaining. This is just stupid. This sucks so much.
In examples such as the following: app equals b high g exec, cmap, d, where the first non-white space, non-comment code point after a line terminator is u plus 002 f, solidus, and the syntactic context allows division or division assignment. No semicolon is inserted at the line terminator. That is, the above example is interpreted in the same way as app equals b high g exec.
And it builds. So I can copy it, paste the output.
End of punctuator, right brace punctuator, input element regexp, white space, line terminator, comment token, right brace punctuator, regular expression literal, ECMA International 2024 217, capital I N P U T, capital E L E M E N T, capital R E G, capital E X P, capital O R, capital T.
And then I can check, double check, triple check at the top here that it is the correct output. Because I am so bored, I could totally screw it up on accident.
Substitution tail, input element template tail.
And this one matches. Hopefully. Please just match. Please match. Sync over. I do not understand. Something is different. That's cool. This is great.
Our control codes used to.
This is different to start with. I want to die. This is so annoying. Oh, I was clicked on the wrong one. Good. That's good. Okay. This is why I'm double checking. Okay, it matches. And
Zero width join.
I swear to God, this is so frustrating. I'm clicking on these tabs, and then it doesn't register the click because this computer is so laggy.
Encoding and byte order. ZW
That matches.
can sometimes also appear after the start of a text. For example, as a result of concatenating files.
This one matches. This one doesn't. I have to figure out why it doesn't.
Of certain format control characters out.
It's the same as this file. Is something fucked up? What's wrong? What's different? I don't care. I just want to be done.
Name, abbreviation, usage, U plus 200C, 0 width non-joiner, ZWNJ, identifier part, U plus 200D, 0 width joiner, ZWJ, identifier part, U plus FEF, 0 width no break space, ZWNBSP, white space, 218, ECMA International 2024, 12.2 white space code points are used to indivisible lexical units from each other, but are otherwise insignificant. White space code points may occur between any two tokens and at the start or end of input. White space code points may occur within a string literal, a regular expression literal, a template, or a template substitution tail where they are considered significant code points forming part of a literal value. They may also occur within a comment, but cannot appear within any other kind of token. The ECMAScript white space code points are listed in Table 36. Table 36. White space code points. Code points. Name. Abbreviation. U plus 0009. Character tabulation. Tab. U plus 000B. Line tabulation. VT. U plus 000C. Form feed. FF, U plus FF, 0 width no break space, ZWNBSP, any code point in general category space separator, USP, note 1 U plus 0.
I don't know if originally it was the wrong file.
Points listed in Table 36. ECMAScript white space.
Sucks.
In general category space separator. Zs. 2.3 white space. Tab. VT. FF. ZWNBSP. USP. Line.
I'm gonna fall asleep. I'm so bored. This is like mind numbing. This is so boring. Everything looks exactly the same. Why is there a difference? This is different. It's the same. I can't make any mistakes because I don't want to track down any bugs or deal with any bugs, because this was originally working perfectly fine. And if I make a bug, I won't know if I have a bug later, because I won't know if it's a new bug that's made when I'm converting the address, or if it's an old bug when I was getting it to the point to convert the address.
D carriage return CR U plus 2028 line separator L.
I'm gonna have to just hope for the best here.
Only the Unicode code.
It matches this other file in the original. So I think that is a copy of the original, but it might be the same exact HTML file, except I made a copy with like one tiny tweak, but it didn't change the output, so I like just left the other copy in there. I'm just gonna paste it and hope for the best. Oh man.
However, the line terminator at the end of the line is not considered to be part of the single line copy.
I like make a note of it and then not read the notes, because I make notes and I don't fucking read the notes. I should read the notes because I made them, and I don't. At least I made the note to read. It's the thought that counts.
Discarded except that if a multi-line comment.
I'm so tired of thinking this is so boring.
A line terminator for purposes of
Freaking checking if two files are the same. So I'm gonna paste these and then build it, and then if I have a bug later, it's probably one of these.
asterisk char multi-line comment charsopt post asterisk comment charsopt post asterisk comment chars capital M.
I'm between a rock and a hard place, and I'm going to make a decision and hope for the best. Still have to figure out that one file anyways, so what's does it matter? I hate this computer. Is so fucking laggy. What the fuck?
I-N-E capital N-O-T.
I think it's gonna crash. I need to save everything and restart. Something is wrong with this computer. It's acting up. It's gonna give me a blue screen any minute. For the love of crap, I hate. This computer is so old.
charsopt single line comment chars.
And even if it was a new computer, Windows wouldn't run any better, because it's just as bad, even on a new processor.
In section B.
Never worked in the first place. Oh, it's so laggy, this computer is so laggy.
Identifier name, private identifier punctuated.
And I get to build it, and then we'll have to check those unsigned ins.
Punctuator, and template substitution tail productions
I don't think there is.
production. ECMA into
So I got them all.
12.6.
Whoop-de-doo.
Identifier and pattern syntax, with some small modifications. Reserved word is an enumerated subset of identifier name.
I'm gonna double check these fuckers because it's so laggy. It could have like not pasted and I wouldn't notice. Because it's not updating when clicking.
ECMAScript implementations. ECMAScript implementations may recognize identifier code points defined in later editions of the Unicode standard. Syntax: private identifier, identifier name, identifier start, identifier name, identifier part, identifier start char, Unicode.
Oh, the file paths are different than the original. That's great. I'll just check the file name here at least.
By letter, one of A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P.
I'm gonna build it and hope it builds.
X, Y.
First I want to see if there's how many unsigned ins left.
ID start. Any Unicode code point with the Unicode property ID start. Unicode ID continue. Any Unicode code point with the Unicode property ID continue. The definitions of the non-terminal Unicode escape sequence is given in 129.4. Note 1. This standard specifies specific code U plus 0024 $.
So it looks like it was 3091.
An identifier name, and the code points U plus 200C, 0 width non-joiner, and U plus 200D, 0 width joiner, are permitted anywhere after the first code point of an identifier name.
Now it's 3000. Let's paste it.
ID continue. 2, 7, 1 identifier names. Unicode escape sequences are permitted in an identifier name, where they contribute a single Unicode code point equal to the identifier code point of the Unicode escape sequence. The preceding the Unicode escape sequence does not contribute any code points. A Unicode escape sequence cannot be used to contribute a code point to an identifier name that would otherwise be invalid.
So that was a whole lot of effort for like 20-something matches. I was hoping for a bigger difference than this, so I have to like, that saved very little time and just made me frustrated because now I know that there's two potentially problematic files and I have note of them, but I'm gonna forget to check my notes, but at least I took note of them, that they're problematic. I'll even put these are problematic. I just will problematic. That's not correct though, I just missed like 4 letters. This computer is so laggy. I'm just gonna use it to crash this. This stream will be done soon. I think it's almost 12 hours. So I'm gonna try to find and replace the rest of these and I'm gonna get off. I wish this number was smaller. A smaller number, but it's not that small of a number. I still gotta find all the sign-ins. So I'm gonna do that. Oh man.
3 static semantics. Identify a code point. The syntax-directed operation identify a code point takes no arguments and returns a code point. It is defined piecewise over T. Following.
I have to check if it builds too. And then I gotta save it back up. Oh, please. Please, just build. Do not. Just build. Please. Fucking build with no issues. I think it's gonna build. It's still building. It takes 2 minutes to build. This is a long 2 minutes. I'm really hoping there's no error. If there's an error, I'm gonna lose it. So I gotta like backtrack. That's not fun.
Used as an identifier. Many keywords are reserved words, but some are not. And some are reserved only in certain contexts and while a reserved words await is reserved only inside async functions and modules, async is not reserved. It can be used as a variable name or statement label without restriction. This specification uses a combination of grammatical productions and early error rules to specify which names are valid identifiers and which are reserved words. All tokens in
This song that's playing right now, that's a little overdramatic too.
Specified.
Yeah, 2 minutes is a long fucking time. I'm out of knuckles to crack. I need to get some more water. Oh, it's done. It is. No errors. Oh my god, please just work. Well, this will still take a minute. I think it literally takes 1 minute to run each time. So I'll be back. Let's pour water. Only like 3,000 and 5,000 whatever left to replace. So much fun.
As identifiers, but also appear as keywords within certain syntactic productions, at places where identifier is not allowed, as async, from, get, meta, of, set, and target. The term conditional keyword, or contextual keyword, is sometimes used to refer to the keywords that fall in the last 3 categories, and thus can be used as identifiers in some contexts and as keywords in others. Syntax. Reserved word. 1 of await break case catch class const continue debugger default delete 2 else enum export extends false finally for function of import an instantia of new null return super switch this throw true try type of var void well with a yield 24 capital ECMA International 2024 note 1 per 5 1 5 keywords in the grammar match literal sequences of specific source character elements. A code point and a keyword cannot be expressed by a Unicode escape sequence. An identifier name can contain Unicode escape sequences, but it is not possible to declare a variable named else by spelling it else u. 65. The early error rules in 1.3.1. 1 rule out identifiers with the same string value as a reserved word. Note 2 enum is not currently used as a keyword in this specification. It is a future reserved word, set aside for use as a keyword in future language extensions. Similarly, implements, interface, package, private, protected, and public or future reserved words in strict mode code. Note 3. The names, arguments, and eval are not keywords, but they are subject to some restrictions in strict mode code. C13 1 1 8 6 4 1 5 2 1 1 5 5 1 1 5 6 1 and 1 5 8 1. 2.8 Punctuators. Syntax: punctuator, optional chaining punctuator, other punctuator, optional chaining punctuator, look ahead decimal digit, other punctuator, 1 of, comma, equals plus, percent plus plus, and equals plus equals percent equals and equals. Div punctuator, equals sign, right brace punctuator, 2.9 literals, 2, 9, 1 null literals. Syntax: null literal, null. ECMA International 2024 225, 1 2 9, 2 Boolean literals. Syntax: Boolean literal, true, false, 2, 9, 3 numeric literals. Syntax: numeric literal separator, numeric literal, decimal literal, decimal big integer literal, non-decimal integer literal, plus sep, non-decimal integer literal, plus sep, begin literal suffix legacy octal integer literal, decimal big integer literal, 0 big int literal suffix, non-zero digit decimal digits, plus sep opt begin literal suffix, non-zero digit numeric literal separator decimal digits, plus sep, begin literal suffix, non-decimal integer literal, integer literal sep, hex integer literal sep, begin literal suffix, n, decimal literal, decimal integer literal, decimal digits, plus sep opt exponent part, plus sep opt, decimal digits, plus sep, exponent part, plus sep opt, decimal integer literal exponent part, plus sep opt, decimal integer literal, 0, non-zero digit numeric literal separator.
I need to finish finding and replacing these now, whatever. I can't do it tomorrow.
Digit, decimal digit.
I'd rather die than do this again tomorrow.
Decimal digits, plus.
So I'm gonna end the stream, and then I'll, for 10 minutes, and then I'll start a new stream. I gotta give it a 10-minute timeout because it doesn't always send the whole stream and whatever.
123.
BRB.
1789. Exponent part. Sep. Exponent indicator signed integer sep. Exponent indicator.
I hope I don't get copyright for this song. Because, whatever.
Literal. Sep. 0b binary digits sep. 0b binary digits sep. Binary digits. Sep. Binary digit. Binary digits sep. Binary digit. Plus sep. Binary digits. Plus sep. Numeric literal.
Man, the mouse isn't even working. Come on. I hate this streaming software.
0 octal digits sep. Octal digits. Sep. Octal digit. Octal digit sep. Octal digit. Plus sep. Octal digits. Plus sep. Numeric literal separator octal digit. Legacy octal integer literal. 0 octal digit. Legacy octal integer literal octal digit. Non-octal decimal integer literal. 0 non-octal digit. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L, non-octal digit, non-octal decimal integer literal decimal digit. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R, capital L, 0 octal digit, capital L, E, G, A, C, Y, capital O, C, T, A, L, capital L, I, K, E, capital D, E, C, I, M, A, L, capital I, N, T, E, G, E, R, capital L, octal digit, 1 of 1,234,567, non-octal digit, 1 of 89, ECMA International 2024 227, hex integer literal, SEP, 0x hex digits SEP, 0x hex digits SEP, hex digits, SEP, hex digit SEP, hex digit plus SEP, hex digits plus SEP, numeric literal separator hex digit, 1 of 0 1 2 3 4 5 6 7 8 9 abdef a b c d e f. The source character immediately following a numeric literal must not be an identifier start or decimal digit. 2, 9, 3, 1 static semantics, early errors, numeric literal, legacy octal integer literal decimal integer literal, non-octal decimal integer literal. It is a syntax error if the source text matched by this production is strict mode code. Note in non-strict code, this syntax is legacy 2, 9, 3, 2 static semantics, MV, a numeric literal stands for a value of the number type or the big int type. The MV of decimal literal, decimal integer literal. Decimal digits is the MV of decimal integer literal, plus the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal, decimal integer literal. Exponent part is the MV of decimal integer literal, 10e, where e is the MV of exponent part, the MV of decimal literal, decimal integer literal. Decimal digits exponent part is the MV of decimal integer literal plus the MV of decimal digits 10n, 10e, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator and e is the MV of exponent part, the MV of decimal literal. Decimal digits is the MV of decimal digits 10n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal literal. Decimal digits exponent part is the MV of decimal digits 10e, n, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, and e is the MV of exponent part, the MV of decimal literal. Decimal integer literal exponent part is the MV of decimal integer literal, 10e, where e is the MV of exponent part, the MV of decimal integer literal. 0 is 0, the MV of decimal integer literal. Non-zero digit numeric literal separator op decimal digits is the MV of non-zero digit 10n plus the MV of decimal digits, where n is the number of code points in decimal digits. Excluding all occurrences of numeric literal separator, the MV of decimal digits. Decimal digit is the MV of decimal digits 10 plus the MV of decimal digit, the MV of decimal digits. Decimal digits numeric literal separator decimal digit is the MV of decimal digits 10 plus the MV of decimal digit, the MV of exponent part. Exponent indicator signed integer is the MV of signed integer, the MV of signed integer. Decimal digits is the negative of the MV of decimal digits, the MV of decimal digit. 0 or of hex digit. 0 or of octal digit. 0 or of 228. ECMA International 2024. Note, for example, 3 inches is an error and not the 2 input elements 3 and in legacy octal escape sequence. 0 or a binary digit. 0 is 0, the MV of decimal digit. 1 or of non-zero digit. 1 or of hex digit. 1 or of octal digit. 1 or of binary digit. 1 is 1, the MV of decimal digit. 2 or of non-zero digit, the MV of decimal digit. 3 or of non-zero digit, the MV of decimal digit. 4 or of non-zero digit, the MV of decimal digit. 5 or of non-zero digit, the MV of decimal digit. 6 or of non-zero digit, the MV of decimal digit. 7 or of non-zero digit, the envy of decimal digit. 8 or of non-zero digit, the envy of decimal digit. 9 or of non-zero digit, or of hex digit. 2 or of octal digit. 2 is 2, 3 or of hex digit. 3 or of octal digit. 3 is 3, 4 or of hex digit. 4 or of octal digit. 4 is 4, 5 or of hex digit. 5 or of octal digit. 5 is 5, 6 or of hex digit. 6 or of octal digit. 6 is 6, 7 or of hex digit. 7 or of octal digit. 7 is 7, 8 or of non-octal digit. 8 or of hex digit. 8 is or of non-octal digit. 9 or of hex digit. 9 is the envy of hex digit, A or of hex digit. A is 10, the envy of hex digit. B or of hex digit. B is 11, the envy of hex digit. C or of hex digit. C is 12, the envy of hex digit. D or of hex digit. D is 13, the envy of hex digit. E or of hex digit. E is 14, the envy of hex digit. F or of hex digit. F is 15, the envy of binary digits. Binary digits. Binary digit is the envy of binary digits 2 plus the envy of binary digit. The envy of binary digits. Binary digits. Numeric literal separator. Binary digit is the envy of binary digits plus the envy of binary digit. The envy of octal digits. Octal digits. Octal digit is the envy of octal digits 8 plus the envy of octal digit. The envy of octal digits. Octal digits. Numeric literal separator. Octal digit is the envy of octal digits 8 plus the envy of octal digit. The envy of legacy octal integer literal. Legacy octal integer literal. Octal digit is the envy of legacy octal integer literal times 8 plus the envy of octal digit. The envy of non-octal decimal integer literal. Capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L. Non-octal digit is the envy of capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L times 10 plus the envy of non-octal digit. The envy of non-octal decimal integer literal. Non-octal decimal integer literal decimal digit is the envy of non-octal decimal integer literal times 10 plus the envy of decimal digit. The envy of capital L, E, G, A, C, Y. Capital O, C, T, A, L. Capital L, I, K, E. Capital D, E, C, I, M, A, L. Capital I, N, T, E, G, E, R. Capital L, E, G, A, C.